Good morning. My name is Natalie. I am from the Celestia team. There's a bunch of us today. And this is the Modular Meetup. Today we're going to go a little bit different. Normally we have an introduction to the modularity. We talk about the light nodes. Anyone ran a light node here? Yes. So today, because we have a Mustafi here, we're going to be focusing more on asking questions. Before we're going to start with, let's say start with Mustafa, and if you can tell us something about you.
Hello, I'm Mustafa. I'm co-founder at Celestia and CEO of Celestia Labs.
I'm Yaz. I'm the head of dev role at Celestia Labs.
I'm Nam, co-founder of Hyperlane.
So Celestia and Hyperlane today, also good to know that we're hosting Modular Day. I think let's kick in. I want to know what you guys, Mustafa and Yaz, what you were doing for the last month. Well, maybe more, but for maybe 3 to 4 years. But I want to ask, like, specifically for this month, how did it feel for you to launch a mainnet?
You want to take that, and I'll add on.
Yeah, what we've been doing over the last month is shipping, basically.
Are we going to continue shipping?
Yeah. You always have to. Yeah, you always have to keep shipping. But yeah, I mean, it was a massive milestone that we've been working on for 4 years. You know, the story started 4 years ago with Lazy Ledger white paper, and it's a major milestone because it's the first chain that supports data availability sampling, which is a very important primitive to scale verifiability in blockchains. And it's also like it's very easy to take it for granted, but like right now, Celestia is the only chain that supports any significant size data blobs for rollups. Like before Celestia, the only option you had was Ethereum EIP4, not even EIP444. You had Ethereum, which just had like something like 10 kilobytes per second of data throughput. And now Celestia has something on the magnitude of 1 megabit per second of data throughput. So it's basically a massive upgrade from dial-up era for rollups to the broadband era. And that's very easy to take for granted, but like it sounds such a simple thing, just have a chain where you can post data. But till last month, that didn't exist.
And to answer the original question, also, not the past 4 years, I wasn't there for 4 years and stuff. Yeah, I mean, discovering Celestia, I was reading the Lazy Ledger paper, which is like one of my favorite papers, but I'm biased about it. But for the past month, it's been an insane amount of work in terms of shipping. Like Mustafa is saying, like, we're focused on shipping. We have a meme at Celestia where, like a SpongeBob meme about you gotta ship, you gotta ship it, Patrick. So yeah, it's been an insane month of like coordination from the core devs to node operators to validators, the whole community coming together just to coordinate mainnet launch. It's one of the most major milestones we had. For me personally, I haven't slept for the past month, but I'm personally very happy with mainnet launch. It went smoothly.
Yes, can you also walk us through the last 30 minutes before mainnet? How the setup looked, what you had to do, all the coordinations?
Yeah, so I created a little dashboard, one of the on-site that we had, for mainnet launch, where we were like looking at the countdown timer prior to like when the first block gets produced, the whole Celestia Labs team, some validators, and everyone was watching the countdown together. There's a few people we're coordinating went all over the world, were dialed in, and everyone was watching it. As the timer went down, we had packed meeting rooms for like the core dev waiting together, the DevOps team working together, and yeah, once the countdown happened, seeing block 1 get produced was such a powerful feeling. between block 1 and block 2 took a little bit longer than we expected, so I was like frozen on the dashboard screen. But then when block 2 got produced, I was like, we're good. And then we started all the kind of work that happened after and stuff. There was like from the Celestia node client making a new release so that we can start running light nodes and bridge nodes, all the way to more validators going online, and all the node operators starting to run in their nodes.
Was there anything that surprised you that day? Question is for both of you.
I don't know if there was anything specifically that surprised me. I mean, it was actually a very boring day because everything went very smoothly because we've been testing it for a very long time. So, and yeah, there was nothing weird or unusual. Basically, it was just like spinning up another testnet for the most part.
Yeah.
Yeah.
I had everyone ask me, "Are you stressed?" prior to launch, and I was like, I don't know. I'm not stressed. Should I be stressed about mainnet launches? Because, like Mustafa said, it's kind of like spinning up a testnet, and we've done it so many times that there was no stress. But I felt everyone else was kind of stressed. But seeing it happen, as we've seen it happen so many times in a testnet, it went smoothly. It was like actually, I would say, remarkably boring as a launch.
Thank you. Let's move to Nam. Nam, can you tell us a little bit more about Hyperlane? And are you doing any integrations with Celestia?
Yeah. So Hyperlane is a modular interoperability protocol, and we're specifically designed to support modular ecosystems such as Celestia's. Right? The idea was that if anybody spins up a Celestia rollup, they will likely want to have interoperability with all the other chains. And when we knew that you guys were launching, it was very important for us to be there on day one. And so the integration that we have is basically like, depending obviously on your execution environment of your rollup, it's very easy, and it's permissionless to deploy Hyperlane to that chain. And so we launched Nexus, which is kind of like this interface that allows these rollups to basically get access to TIA or any other asset or messaging via Nexus, and that kind of in our opinion, kind of completes the modular vision, right? Because this allows us to have this universe of rollups, ideally all settling to Celestia DA to create just a richer environment.
And what is your milestone for the next quarter?
Yeah, for next quarter, I think it wasn't. I would say mainnet launch wasn't quite as intense as it was for you guys, but it was definitely still a sprint that we had to make it happen. And so definitely looking forward for the team to get to recuperate a little bit. But I think since the launch, since Nexus, there's been a lot of interest from Celestia rollups and other modular blockchains to kind of come up to us and ask basically how can we get interoperability, right? And so combined with our most recent V3 launch, I think it's just for us, it's all about serving that demand and making sure that everybody's having a good time, because we've definitely, again, been sprinting, and maybe some things have been, not as clean as we would like to. So that's our focus. So
before I'm gonna let you ask questions, I have one more that I want to ask. There's a debate on Twitter about data availability, and I want to ask, what does data availability means for you? And what does it mean, data availability as a term versus data publishing? Let's say Mustafa.
Well, I think I actually propose that we should rename it to data publishing, because it's kind of easy, it's more intuitive to understand and it's more accurate. But it's very difficult to change words when everyone's using data availability everywhere. It might happen over time, but data availability can be a very confusing term, because it's not really about making data permanently available. It's actually just about publishing the data to make sure that anyone that wants to access that data, like rollup nodes and so on and so forth, can access that data and store it. Because that's fundamentally the core primitive of a blockchain. Like a blockchain at its heart is just a publication. It's just a proof of publication protocol. You can post arbitrary data into it, and you have proof that it's been published. And once you have proof it's been published, you can detect, you know what the state of your chain is. You can detect double spend attacks, and you can ignore the second transaction that double spent the coin, for example. And so that's basically the fundamental primitive of the blockchain.
Yeah, there's also been like an initial CIP proposal. We haven't really officially kickstarted the CIP process with the Celestia improvement proposal process, but there is already one, like an informational one about changing the term from data availability to data publishing, which I agree with Mustafa that it actually makes more sense to call it data publishing, but the DA as a term is so part of the Web3 zeitgeist right now that it's kind of hard to shift it. It's kind of like modifying the terminology around Web3 to mean something else and stuff. So it will take time, yeah.
Okay, thank you. Does any one of you has any questions for our speakers?
Will you be running any ambassador program soon?
Will we be, sorry, could we?
Ambassador program.
Ambassador program. So what we have is currently like personally, me, I don't like the term ambassador and stuff, but what we have is like something as close as possible to it, the Modular Meetup program, right? So the Modular Meetup Istanbul, we had 10 other Modular Meetup that happened in the past. The last one happened in Modular Meetup in Madrid. And we have 2 upcoming ones in Paris and in Tokyo. So if you want to start a Modular Meetup, you can contact us. You can talk to me or Nat after, and depending on the location and stuff, we can provide you kind of support and speakers so that you can host a meetup, and you'll have a lot of people from the Modular ecosystem who can be speakers. Not only Celestia, but anyone from Modular ecosystem. Like maybe Nam would want to be a speaker, right?
I'll try.
He already is a speaker.
Can never be enough.
Yeah.
Anyone else?
No.
What are good ways to launch rollups on Celestia today? How can I start building a rollup?
I can take that.
Well, you'll develop relations.
Okay, sure. All right, so there's many ways to deploy a rollup today on Celestia. You can deploy what we call a sovereign rollup. With a sovereign rollup, you submit the data directly to Celestia. You're not relying on a settlement layer. There's different kind of developer toolkits to deploy a sovereign rollup. There's Rollkit, which Manav is working on Rollkit. There's Sovereign SDK. Separately, if you want to deploy other types of rollup using what we call Blobstream, you can deploy any kind of L2 or Ethereum-based rollup, let's say Optimism or Arbitrum, which settles on Ethereum but takes DA directly from Celestia using what we call Blobstream. Diego worked on Arbitrum integration with Celestia. And technically, like in basically any kind of execution environment becomes a rollup, right? Because Celestia doesn't have an execution environment, you're just submitting data to Celestia. Any kind of execution environment can become a rollup. Whether if you want to move VM, you want an SVM, I think, Eclipse is another example of that. So there's infinite ways to deploy a rollup on Celestia.
There's also various rollup as a service providers popping up. Like you can literally just fill out a form, or like upload your code, and it deploys a rollup for you. So it's like it's easy as deploying a virtual machine. And one of them is called Vistara. That's live right now.
What are you like most excited about after that boring launch, like you said?
There's a lot of rollups on testnet right now that are coming to mainnet, and that's going to be exciting to watch. For example, there's Manta Pacific, which is an Ethereum L2 that is going to use Blobstream to use Celestia DA for cheaper transaction fees. 'Cause the users there are complaining about high transaction fees. So, and then there's also Dimension is doing some pretty cool stuff. So Dimension is like a Cosmos rollup kind of framework or project. And they've got incentivized testnet with like 11,000 rollups that people have deployed. And it's going to be really, really cool watching that come into mainnet, because L2 Beat will need to think about how they're going to go from 32 rollups on the website to like 10,000 rollups. I'm not sure how they're going to do that.
What I'm most excited about are two things. The CIP process, which I think is much needed, especially if you come from the world of Cosmos, which doesn't have anything. It's like the Celestia improvement proposal process. It's kind of like the EIP process in Ethereum, which doesn't exist in the Cosmos world, right? And I think it's much needed because currently in Cosmos, if you want to modify anything in the Cosmos SDK, the attitude you get is, well, if you don't like how it is, you can fork it, which is fine, it's open source. But if you have 50 different versions of the Cosmos SDK, it becomes kind of hard to like align all these new features into one specification, right? So I'm very excited about this because I think that will like truly decentralize, but help coordinate a lot of core development around the modular stack, especially with Cosmos SDK technology, and everything that Celestia is building. The second thing I'm really excited about is hackathon. So, but not like I have ideas for hackathon that are not following the traditional model and stuff. And the Celestia Labs team and I will have really exciting things around hackathon that will truly take it back to the hacker culture that it started with, and minimize any kind of bounty hunting kind of behavior that we see in hackathons and stuff.
Yeah, maybe to add to that, I think, like Mustafa said, I think Cosmos has been very good about kind of like dealing with like, oh, it's very easy to spin up a chain, versus I think probably the non-Cosmos ecosystem has very much been in this mode of operation where like, yeah, it just takes a lot of effort to spin up a chain, and so there's only going to be so many of them. So there's a lot of like, I think, innovations in Cosmos that now that we as a Hyperlane team also been more recently exposed to it, that we expect will kind of like spill over from the Cosmos, and I'm very excited to see that, because yeah, like again, in a world of like 10,000 rollups, like the EVM kind of like infrastructure stack is just not set up for that. And that's going to be exciting or terrifying, depends on how you look at it.
Why that would be terrifying?
Just because I think it's, again, because people are so not prepared for it. Like I just expect there's going to be, like people already kind of complain about like, oh, adding like one more network in MetaMask, right? And just like the list of network lists is just like going to be so hard to scroll through with like more than just like several dozen networks. And so I think there's just going to be a lot of like probably UX pain that we'll encounter as this kind of explosion of rollups happens.
Nem, are you, as a Hyperlane, also participating in any hackathons this week?
Yes, we will be big fans of the ETH Global Hackathons, and so we'll be there this weekend as well. So we'll have a workshop there, come find us. And I think that's the only hackathon we're at this week.
We're participating in ETH Istanbul. There's about $10,000 worth of hackathon bounties. The largest pool is for if you deploy an application on top of Celestia or roll up on top of Celestia. And the second one is around integration work. If you integrate a new kind of roll up and stuff into Celestia, we're going to post a tweet with more information. So if you guys are hacking at ETH Istanbul, do check out our bounties, check out the Hyperlane bounties. We should do like a co-bounty together.
We should.
You know,
yes.
like quick integration with Hyperlane and a roll up, you know.
Do we have any more questions? Yes.
Hi. So my question kind of goes for all three of you. What are kind of the big ideas you think we need to go from kind of the 0 to 1 with rollups still, discussing kind of UX being kind of a pain? People aren't probably going to want to switch from 50 different chains to use it. Do you think we're going to need a changed wallet? Do you think it's going to be something rollup as a service figure out? Or where do you think the 0 to 1 is going to click, where people won't really care what chain they're on, but they'll just use it? Thanks.
Yeah. I mean, like, I really think there's obviously modular versus monolithic debate. And I truly believe that like modular chains just make more sense from a product perspective because because imagine how different the web would look like today if every website ran in the same data center on the same servers and you could only use PHP and MySQL to develop your web application. The web would look completely different. So, but obviously the main kind of challenge with modular right now is that to achieve more scale or to have rollup applications, to have application-specific rollups, there's a bigger composability challenge. It's a solvable one, and people like Hyperlane are solving that. But, and as you said, like there's issues of like the infrastructure isn't really prepared for that. Like MetaMask is not prepared for a world where there's 10,000 EVM chains. But right now we're kind of in a situation where it's like, imagine if your browser could only access 10 websites. You had to like, it required a long time to add a new website to access your browser. But I do think that those challenges can be overcome. But I think that is the main challenge right now.
Thanks.
Do we have more questions? I think we have last question.
You mentioned that you see some things spill over from Cosmos ecosystem to other ones. Which ones do you have in mind?
Yeah, I mean, I think just the first thing that popped into my mind right now somehow was like there's an actual central chain registry, right? Like you have like there's a chain registry, you have like all the like relevant metadata that you can easily import on the Cosmos side. Like to my knowledge, I know there's chainlist.org, but it doesn't quite have the kind of same weight. That they're not quite have the same amount of metadata, and so that just makes I think building like wallets like much harder, right? Like everybody in the EVM world has like their own add to MetaMask like button on their docs, but like actually having a central registry, I think makes just a ton more sense in a world where the cost of spinning up a new chain, a new rollup goes down significantly. And so honestly, I'm not a Cosmos expert. I've really spent most of the last couple of weeks more on the Cosmos side. But it's just, I think, a lot of like very interesting innovations. Actually, another one's like IBC hooks, right? Like being able to like send data from one chain to a third chain via a second chain. Like those are the kind of things that like just we in the EVM world never really had. So I'm expecting some of those innovations to be very useful in a world of, again, 10,000 rollups.
One more question. Okay, last one. Besides Celestia and Hyperlane, what are you guys excited about in the space? What are you looking at? Mustafa.
I'm excited about all of the applications that are being built on Celestia, of course. All the test nets that are coming. I mean, all the test nets that are coming to mainnet. Rollup, especially rollup as a service providers. It's just going to be crazy seeing a world where deploying a new rollup is as easy as deploying a new website. I just like the possibilities are kind of like unbounded there. It's just like I have no idea what like the blockchain space will look like in a few years as a result of that.
Yeah, I'm just wondering like the use case like for. Like what would you see like, let's say in like
so the use case
3 years?
The use case for that is, the use case for being able to create your own chain is fundamentally a better product. Because if you're limited to the Ethereum virtual machine, there's a lot of like decentralized applications that you can't easily build. So to give you some examples, like there's a project called Couture, which has modified the EVM to make it possible to embed the real-time strategy game inside the EVM. Like with a 0.5 second, like if you move your character, it moves instantly. Because it's got a 0.5 second tick engine with like faster finality time than L1. But they could only do that because they could actually embed the game directly as an opcode inside the EVM. And that's just something that's fundamental. Like, before rollups, that just wasn't fundamentally possible without deploying a new L1. Because the only way you can have your own execution environment is if you deploy the new L1. So fundamentally, what you get is fundamentally better products.
Yeah, I agree. I think one of the hardest things, as per usual, I guess, in a maybe frontier industry, is that the hardest thing is imagination, right? Like you have to think about like what is possible. And I think up until now, right, like the only block space available was block space that somebody else created, somebody that had to like raise probably millions of dollars to do so. And so if you had like right, like kind of requests of this block space. They just couldn't do it. And so now in this world where it's like much easier to create your own block space, customize the block space, it's just, yeah, it's kind of hard to imagine. Like, obviously we can give you a lot of examples, but ultimately, like, it's up to the imagination of developers to do so. And we've seen the same thing, right? Like with the internet, right? Like when the internet came out, people didn't really know what Uber was going to be. And so I think we'll see similar things here.
But this is an interesting topic. How do you, let's say, explore your creativity or your imagination? Like what would you suggest to the developers?
Do it. Like, I think I said earlier, the SpongeBob meme, just ship it. Like, I think the only thing, right, like the way we've gotten all of the fun stuff that we have now in Web 2, we got it because some developers in the garage decided, like, you know what would be cool? This thing. And I think we will, again, like making it easier for those developers to do so, right? Like, instead of now taking a year, taking a weekend, like that will unleash, I think, the creativity of all developers, not just, right, like used to be in Silicon Valley, but like now all over the world. And I think that's just like that's why it's fun to be in this industry, right?
Yes.
Yeah, I think when it comes to like being creative and stuff, you always have to think about what is available, right? So what is available, like with creativity, it's about trying to find two different things that never been connected together before, right? And then, creating something new out of it. So with a modular architecture, it's like Legos, right? You can play with totally different kind of architectures that allow you to build specific kind of applications that nobody has ever dreamed of, right? And that's only possible because you have a lot of really good developer toolings, good APIs, and kind of like a modular playground that you can play around with. And because of these tools, they kind of give you the freedom to explore as a developer what you want, because you control the stack, you can build any kind of dream application, whether it's gaming or things in DeFi or an NFT or things that we haven't imagined before. Me personally, I think the one thing I really want to see is payments, because payments has not been solved in Web3. Me sending money from my phone like instantly to anyone without abstracting that away it still hasn't been solved in Web3. I mean, we had Valora, but with Valora, it still required confirmation by SMS and stuff, but it was as close as possible from the payment point of view. But I do want to see that kind of thing solved. And what would take to solve it? A lot of imagination and creativity, right?
Great. Thank you for all of your answers. Thank you, everyone, for your questions and being here. I hope you're going to enjoy Modular Day. If you like this meetup or if you want to host one, you can talk to me. We have upcoming ones in Tokyo and in Paris. And if you don't have any plans for tomorrow, we're hosting a game night. So that's with me too. And thank you.
Hello. All right, everybody. I think we should get started. We have a full day ahead of ourselves. So if you don't mind, just come sit down up front here. If you want to have a conversation, like Fazila said, like go have it in the courtyard. There's another room as well. But yeah, we have a full day, so let's get started. Welcome to Modular Day. It's very exciting here to be in Istanbul, one of my favorite cities. I think just a combination of history of 1,000-year-old worlds, as well as like us all talking about this new fancy technology we'll call crypto. I think the combo is pretty fascinating. We've gathered here today at Modular Day to talk about the latest and greatest in the modular ecosystem. And if you're here today, you probably have some interest in modularity, right? We all here come from very different parts of the world, with very different backgrounds, experiences, but what all binds us together here is this interest in this ecosystem. And if you're not interested, at least you're curious, right? Like you came here because you heard like, hey, modularity, I heard it all about on crypto Twitter, but like what actually is it? And so let me tell you a little bit about, actually, do you have a clicker for the presentation? Well, how do I do? I kind of forgot about that. All right, let me, there you go. Yeah, but so why we're here? Why do we care? Right? We're here because we care about crypto, right? We care about these like really cool internet computers, these applications which can be built and used permissionlessly. Presumably everybody here wants to kind of expand the crypto economy and like expand the reach of these applications. But however, an impediment to that growth has been the building of applications that at least rival, but ideally supersede the Web 2 equivalents, right? Like if you've been in this space for a little bit, you know what I'm talking about, right? Like the applications are not quite there yet. Too often, the block space itself is the limiting factor. And that means that not only is the gas too damn high, but sometimes we just have different needs from our compute environments. We've seen this kind of play out in Web 2, where we used to have like PCs and the internet, but it wasn't really until like better web browsers enabled Gmail, right? It wasn't really until the arrival of the iPhone which made it possible to create applications like Uber. Even cloud computing itself really came only later, that then enabled an application like Snapchat to be built without needing to have like your own custom ops team, right? That you were able to leverage GCP and AWS. And so in history, it's always been true that like better infrastructure leads to better application development, which itself leads to better applications. And that allows the kind of whole pie of our industry to grow. And so we believe that the same thing will be true of modular blockchains, right? Like we said earlier in the modular meetup, like up until this point, like the block space that you had available to you was the one that you had available to you. There was like just no ability for you to change that, right? It was like Ethereum or bust, basically. Or you had to raise like millions of dollars in VC money to like create your own L1 to like make this one precompile change or make add this one opcode. And so now with the modular blockchain stack, we're able to create block space without the kind of trade-off of security decentralization, right? Without having to raise this like crazy amount of VC money. And so that allows you now as a developer to choose different trade-offs in your block space. And so we believe that these kind of innovations, either when it comes to like adding your precompiles or opcodes, that allows you to build better applications, and better applications, once again, leads to, I think, just a bigger pie for all of us. I might go into some examples, right? Like precompiles, one of the really cool precompiles that I was excited about the last couple of months ago, I think it was a local team here in Turkey, the ones behind EIP 7212, which basically adds this precompile to verify, right, like the signatures that are being created by the passkeys or the secure enclaves of our mobile phones, right? And that, for example, would allow us to build much better wallet experiences than we have today, where like everything is basically a plain hex key in MetaMask or like a ledger. Other things, for example, on the opcode side, right? EIP 1153 has been kind of in review seemingly forever, and like somebody like Uniswap has been kind of like prodding the core dev team to kind of get transient storage in for at least, I think, two years now, right? And I think, imagine, like this is Uniswap, right? Like if Uniswap can't get an EIP into Ethereum, like developers like ourselves are not going to be able to. And so DA layers, right? Like again, up until now, basically Ethereum has been our only option. With Celestia, right, and other folks like EigenLayer or Near, most recently coming in, we're able to drive down the DA costs so significantly that this will just fundamentally enable very different applications. And then last but not least, like sequencers, right? Like today, the sequencer architectures that we have are pretty, I guess, limited. And again, with more modular blockchains, we're able to come up with sequencer architectures that will just allow us to have different trade-offs under like decentralization spectrum, allow us to have better interoperability maybe. And so all of that being said, it basically allows us as developers to create better block space. And so for months now, right, like we've kind of hearing this like, I guess, progress of modular blockchains kind of play out maybe on Twitter and like on conversations that we've had with different folks. But really, like Celestia's launch about 2 weeks ago, I think will be kind of remembered as an inflection point for our ecosystem, right? Like this is now kind of this like singular point in time that we can look back on, hopefully, and be like, all right, this is what started kind of like our ecosystem. This is what started the growth of our ecosystem. And so Modular Day was organized by Hyperlane, but is co-hosted with Celestia to kind of like celebrate basically kind of the birth of, or like maybe the next milestone of our ecosystem. And we wanted to kind of connect all of these people who are working on a modular blockchain space in Meet space as well. And so it was important for us to come here today to talk about, right, like the problems that are still remaining, the kind of the progress that we have already made, connecting faces and people to their Telegram handles. But most and foremost, like, right, like have fun as we are hopefully kind of building this next phase of our industry. And so how are we going to do this? We have a full day of talks and panels in front of you today. Right after me will be Nick White and Dougie from Figment Capital, and we have a bunch of panels covering sequencing, rollup interoperability, security, infrastructure, ZK systems, and finally, like a favorite of mine, a modular meets monolithic conversation. At the end of the day, we'll also hear from Lagrange's co-founder Ismael and Aztec's Zach Williamson. And I think that will be for today. So it's pretty packed. So we'll try to keep, and by we I mean mostly Fazila, we'll try to keep us on schedule. And yeah, with the remainder of the time, I would like to introduce you to Hyperlane, because probably some of you guys might have heard about us on Twitter, heard the term permissionless interoperability, but like, why does it matter? So like I mentioned, it's very cool that now, again, with Celestia, with many different kind of rollup stacks, people are able to create new block space, custom block space. But the single biggest downside of the creation of this, right, like this explosion of block space, is basically the loss of composability, right? Like when everything was on Ethereum, it was very easy to like access state from a different application. If everybody kind of lives on their own blockchain, like what happens? And so without interoperability, like applications no longer have access to this kind of shared state that was the kind of whole basis of this like internet computer, as we called it, right? And until recently, if you created a new block space, right, and I think a bunch of us have been in a situation, you then have to go petition these like centralizing like gatekeepers who kind of like get access to all the other chains, and I would call like these bridges. And so we believe that modular blockchains need permissionless interoperability, right? Like you don't, like we cannot live in a world where you spin up a new blockchain and have to ask somebody for permission. It's like spinning up, right, like a new server, but then having to ask like Comcast to connect it to the internet. Like this needs to be like a completely permissionless thing, and so we believe that interoperability is kind of the last remaining kind of like, the last remaining layer in the blockchain, in the modular blockchain stack. And so, quick overview of how Hyperlane works. It's pretty simple at the surface, right? The interface is like on the origin side, the sending contract just sends a message to the mailbox, and on the destination chain, the mailbox delivers a message to the receiving contract, and that is secured by what we call the init-chain security module. Because unlike other protocols, Hyperlane has decided to modularize the security model from the messaging interface itself. And the reason why is because we need, right, like the security model to be permissionless, right? Like if there was a kind of like coupled security model to messaging interface, we would now no longer be able to like have Hyperlane be available in any arbitrary chain. But also the benefit of kind of what we call modular security is that developers can actually choose different security models depending on their application, right? Like something like the Uniswap DAO will always have very different trade-offs than like a gaming developer who's just starting their new game. And so this kind of like modularity basically kind of like supports all of these different use cases. And not only that, but also like as research goes on and is able to kind of come up with better security models such as ZK-like clients, developers using the messaging interface can just easily kind of like upgrade into better security without having to like re-architect their smart contracts. On the next side, we have our most recently announced v3 version protocol upgrade, which basically adds hooks, which kind of completes the modular security narrative, because up until this point, you needed to have like a separate call on the origin chain to leverage, let's say, other security models, like it's like native rollup bridges or external bridge providers. And with hooks, now we've kind of like fully abstracted away basically these security models where you as a developer, if you want to send a message, let's say, right, like from Ethereum to Arbitrum, you can actually just use the native rollup bridge. While maybe if you go from Ethereum to like Avalanche, you actually use like a aggregation of multiple different security models to kind of get the optimal security. And so this is what allows, I think, developers now to build these fully modular security models and come up with ones that we haven't even like thought of. Cool. Alongside Celestia's launch, which happened, as I mentioned, 2 weeks ago, we have launched Nexus, which is an interface to the modular world, right? Like in this world of 10,000 rollups, as Mustafa earlier mentioned, rollups will need the ability to get TIA, right, to be able to pay for DA costs. And so we've built Nexus to make it very easy for any rollup who deploys Hyperlane onto the rollup to get, for example, TIA, but also any other asset that you might want to have, as well as get basic interoperability. And there is a single interface through which like users can basically explore this modular ecosystem without having to jump around. If you spin up a rollup, like we can easily add your chain here as well, right? Like you can deploy Hyperlane yourself. Again, it's permissionless. And so we're hoping that Nexus will kind of become the nexus of this ecosystem. Speaking of permissionless deployment, up until now, if you've maybe tried deploying Hyperlane yourself, you kind of knew that it was possible, right? There was like this Hyperlane deploy repo that you had to clone and to run some scripts, fiddle with some TypeScript. And so it wasn't the greatest experience. And so happy to announce that this week we are rolling out the Hyperlane CLI, which is just an NPM package. You run it, there's going to be an interactive configuration management, artifact management. And so that should be much easier. Also very happy to say that we're working with Kurtosis to easily run the off-chain agents directly on their cloud. And so no longer do you need to fiddle with AWS credentials or like figure out how Docker works and what are the command line arguments again. And so yeah, if you're curious, we'll be at ETH Global's hackathon this weekend at ETH Istanbul, and we'll have a workshop there as well. I'm happy to show you more on that front. And you know, permissionless interoperability is all great, but I think as we all know, like infrastructure is probably not the crypto developer's strongest trait. And so, you know, if you don't want to actually run your own infrastructure, like you can come talk to us. We, as Abacus Works, the core developers behind Hyperlane, are very happy to kind of work with you and make this a fully managed experience, right? So similar like with rollup as a service providers, where you can just click a button, you get a rollup. We aim for the same experience where you click a button or mostly send us a Telegram message and everything spins up as well. Cool, all right. Last not but least. But yeah, like again, Modular Day is right, like the celebration of this new phase of our ecosystem. We seeing more and more rollups come online. And yeah, if you are working on one right now, if you're about to launch one, start thinking about like, you know, like how can you leverage Hyperlane, right? Like whether it's about getting TIA, whether it's about getting any other asset, whether it's kind of like some more integrated cross-chain experience that you want to build. We believe that Hyperlane is your way to take advantage of this kind of next phase of our ecosystem. You can have you can have your rollup show up in the Nexus UI, but also the UI is completely open source. If you want to fork it and kind of directly integrate it into your own app experience, that's totally possible as well. And one thing that we're also very excited about is to use Hyperlane as a canonical bridge, right? So like again, one of the questions that you have to do as a rollup, you have to think about like, hey, like what is going to be like my native token, right? Like what will people do with this native token? And most often they will use it to pay for gas, right? Like on your rollup. And so actually there's a way to use Hyperlane to basically mint the native token on your rollup. Let's say if you're using Polaris, right? Like you can add a precompile to Polaris that actually is integrated with Hyperlane. And that way, your users, right, like don't have to kind of like fiddle with different fee tokens. And so yeah, very happy, like very excited for somebody. We're talking with some people about it right now, but like if you're going to do that, yeah, definitely come talk to us because I think that's going to be very interesting. And then yeah, maybe the last point I would want to leave you at with is, this is a point I'm always stealing from Zaki Minion from Cosmos, but you know, like the Cosmos app chain thesis, I think in a lot of ways was kind of ahead of its time, and right, like they're the ones who kind of always talked about like app chains and like applications want to build their own, want to be able to build their own blockchains. But really, we're seeing this kind of app chain thesis spill over outside the Cosmos, and I think he always calls this like this kind of Cambrian explosion of block space. That I think is a very like fun term, I guess, to say, but. Yeah, like I think a lot of us are not quite prepared for what that's going to look like, and it's going to be super exciting. I think it's going to be so different. It's going to feel a lot like like the 80s, right? Like where like everybody had these own manual servers, and now we're going to kind of enter this phase where yeah, like web servers and cloud computing all is going to be available, and that just leads to like many different applications that like people in the 80s were just not able to imagine themselves on. And so this, I think, is the time to kind of get involved in this ecosystem. And so, yeah, very happy to see all of you guys here to participate in that. And so here's some of our contact info. Come find us either here today or online. And yeah, like I guess most importantly, have fun. And I think that's from me. The next people on stage are going to be Nick White from Celestia, as well as Dougie, I think, from Figment. And yeah, please have fun. Thank you, guys.
Where do you want to sit? All right, it's been quite the week. I think everyone's bringing a lot of excitement to this week, which is great. Really excited to chat with Nick today. So I'm Dougie from Figment. I don't think Nick needs an introduction, but do you want to do a quick introduction, just for the sake of it, of who you are?
I'm the COO at Celestia Labs.
Awesome. And so, yeah, obviously Celestia launched 2 weeks ago. I'm sure you guys are really excited. Like, what's it like in the team right now? Like, how are you guys feeling about your launch? Like, it's a huge accomplishment. Like, what are you guys talking about as a team?
Well, you know, earlier we had a modular meetup, and Yaz and Mustafa were talking about the launch, and it was surprisingly calm, I think, at least on the surface. A lot of us were feeling a lot of excitement and energy and anticipation, but it went extremely smoothly, and I think we're fortunate, partly because, you know, we've launched so many different test nets, as well as, you know, we were building on a stack that's kind of been proven, you know, like Tendermint and the Cosmos SDK, so I think that made it a little bit easier. We weren't launching something that's like completely new from that side. However, the part that's completely new is the data availability sampling. I think that is something we'll talk more about, and is the really novel, pioneering kind of moonshot aspect to the Celestia launch that makes it this event that I think marks kind of what Nam said, an inflection point, sort of like the dawn of the proper dawn of the modular era. But we're really excited, and there's a huge amount of work, you know, 4 years of work since the publishing of the Lazy Ledger white paper by Mustafa, and yet in reality it's actually just the first step on a much longer journey of building out this whole modular stack, attracting more developers and unleashing a lot more innovation in the blockchain space that's been held back, I think, by just the limitations of the underlying infrastructure.
Yeah. I mean, I definitely want to go more into like what this means for the industry. Before doing that, I'm super curious. A lot of people here are, you know, building, whether it's applications, blockchains, et cetera. You guys have done it. Like, you've launched a blockchain. Like, if you were to tell like one tip to someone who's like about to do that or like thinking about doing that, like, what would it be? Because like it's obviously like a major accomplishment. You launched a first of its kind blockchain. Like, what would be like your biggest tip for a builder?
My biggest tip would be find someone like Yaz, who's been doing this his whole like career and just knows it backwards and forwards. I think he's been absolutely instrumental in making sure that everything actually went according to plan. And aside from that, I guess it's really important to have a very close relationship with the validator community. And again, I think that's something that Yaz knows extremely well. But we've had teams like Cube Labs and POps who've helped us significantly there. I don't think there's any one thing. Just be ready to work your ass off because it's not easy. And that actually kind of brings me to another point that I think, the reason that Celestia exists, right, is so that other people, it becomes much easier to launch your own chain. Like having just gone through that process as a team, and I did that something similar with my previous project, Harmony. I know how much work it is. And that's really one of the value props of modular blockchains is that you can launch your own chain, but you don't have to bootstrap a whole validator set. You don't have to go through all this overhead to do so. And so that's like, hopefully, we make it so that people can get the benefit of launching their own chain without having to do nearly as much work.
Yeah. I mean,
so I guess my piece of advice is like, don't launch a new chain. Build a roll-up on Celestia or some other DA layer.
Yeah, you've done the work, so now everyone else can like leverage your work to do it easier than ever before. So it's a huge improvement. And like one of the things, obviously, that Celestia has brought to the table that no one's really done before is data availability sampling, DAS. Like, we've seen you running light nodes everywhere. So everyone, I think, at this point knows what light nodes are. But I mean, I'd be curious to hear like your view of like, one, like what makes this such a big innovation, and two, like really how you think it can be applied and like be done in a way that's like, again, like people haven't been able to do these type of things before.
Yeah, well, I think that the launch of Celestia being the first data availability sampling network is sort of like the broadband moment for crypto, in the sense that in the old days of the internet, when it was just like all like dial-up, or you were really constrained with the bandwidth of the underlying network, and so that fundamentally limited the kinds of applications you could build. And I think data availability sampling is like broadband, where it's going to dramatically increase the the throughput and the capacity of the underlying network, and therefore unlock new applications like the internet equivalent of like e-commerce and streaming and social apps and all the things that we now use on a daily basis. So I think that's kind of the first thing. And then how does data availability sampling work? Obviously, one of the important things is like the light nodes, as you mentioned. And I think that's another part of what adoption means for Celestia, is not just how many people are building rollups, but also how many people are actually running light nodes. And the core property that's so unique about Celestia, as opposed to other blockchains, is that it scales securely with the number of users. So as users start interacting with the rollups on Celestia, they'll be running light nodes in the browser or in their wallet in the future, and that will naturally increase the secure capacity of data availability to build on. And so that's something that I'm really excited about, and it also, I think, is just symbolic and important to the underlying values of what crypto is all about, which is that you're supposed to be a first-class citizen of these networks. You're supposed to be able to verify things directly. You're not supposed to trust an RPC endpoint to tell you what the truth of the chain is. And it shouldn't be like this, like a layer that sits between you and the protocol. It's meant to be peer-to-peer. And so light nodes are a really, really important step towards that vision and that future, where the users are directly interacting with each other through the protocol, not making additional trust assumptions, verifying everything directly. And so that's the future that we want to build towards.
Yeah, I mean, that's incredibly powerful, like very much ethos aligned with the space, I think, in a huge way. So it's amazing to hear. And then another notable aspect of Celestia and its tech stack is blob streaming, which obviously is a very unique name. I think we've all like learned about it a bit more over these past few months, but also curious to hear like how you define that and also like what it means to innovation for the space.
So Blobstream is a way that we can stream modular data availability to Ethereum. And what that does is it enables people who want to build an L2 on Ethereum to tap into really cheap DA on Celestia. And so the underlying, like the unlock to me is that right now, if you want to build an L2 on Ethereum, if you post your data to Ethereum, it's going to cost a lot.
Yeah.
And so we want to try to help to scale the Ethereum community by providing this really cheap but also secure off-chain data availability via Blobstream. And I think, hopefully the Ethereum community, we're already integrating obviously with, we've integrated with OP Stack and Arbitrum, and hopefully in the future more like L2 stacks that integrate with Ethereum as a settlement layer. And the hope is that the Ethereum community goes buck wild and builds a bunch more rollups. Like I think ultimately the number of L2s that have been built has been constrained by the fact that it's kind of expensive to do. You kind of need to be a venture-backed team, and so we want to like drop the cost down so that anyone in the world is going to be able to build a rollup. So like obviously one of the visions for Celestia and the modular ecosystem is that we believe it should be as easy to deploy an L2 as it is to deploy a smart contract. And so I think Blobstream is one way in which we are making that possible on Ethereum itself.
Yeah. Curious to hear your thoughts on this. So I think another powerful part of this you mentioned is like the cost reduction of like right now L2s, they're cheap compared to L1, but still I don't think enough for like a lot of applications to exist in the way that we all want them to. And presumably through blob streaming, through Celestia, they can now be extremely low cost, very price competitive. Like, would you say that like Celestia is actually like the hidden secret for like how L2s can actually like survive in a mass adoption scenario? And like, do you think the ETH community is aware enough of that right now?
Yeah, I mean, I think one of the spicy things is that from just some like, I don't want to, these are just like sort of back in the napkin calculations, but we think that a like L2 transactions on an L2 using Blobstream on Ethereum will be significantly cheaper or materially cheaper than like transactions on Solana. So like it could actually drop the cost to run your app on Ethereum to something that's actually very competitive with Solana. As I know that there's a lot of tension there.
Yeah.
And the beauty of it too, which I didn't touch upon earlier, is that the cost savings get passed on to the user and also the developer. And I think that's just ultimately like a better world where like every user wants to save money. I think developers also will have the chance to potentially capture more sort of the fee revenue of their rollup rather than just passing that to the base layer.
Yeah. And I think a key thing you touched upon is like how this applies to developers, which is a great like segue to my next question, which is like you and the Celestia team have been an amazing champion of build whatever. Mm-hmm. Like, what does that mean to you and like to developers out there, like seeing that like truly how vast is this design space that you're imagining right now? Yeah, so the build whatever has become a mantra for the Celestia team as well as like the broader modular ecosystem. And what build whatever, it means a lot of different things all kind of rolled into one. I think that's why it resonates. So the first thing is it's about removing constraints. So we want developers to have the maximum amount of freedom to build whatever they want, right? Yeah. Build whatever. And so the way that it removes constraints, like the modular stack, is obviously cost, like we just talked about. It also makes it so that you have full control and like customization over like what components you want to use. So you as a developer are able to just choose whatever things suit your use case. And then the last thing is that it's also kind of like about being experimentation, like just try whatever you want, throw things against the wall and see what sticks. Because I think part of like what made Ethereum so successful is that it encouraged all this experimentation and innovation at the application layer with smart contracts. Like for the first time, it made it so easy to deploy new smart contracts that people just messed around. Like people were just deploying random stuff. And that's how we ended up with the applications that we have today, like DeFi and NFTs and social and gaming and stuff like that. And
we want to see something similar take place in the modular stack, where we're making it possible now to not just deploy your own smart contract, but your own chain, and to try so many new things that have never been tried before. So it's like, build whatever, like whatever you can think of, build it, like let's do it. And so it's a kind of a call to action for people to explore the frontier of what's possible now that we have modular blockchains.
I love that. Yeah, I mean, it's a huge like 0 to 1 innovation in my view. It's like a transition of like the design space of what can be built and how things can be built. So it's incredibly exciting. And I think, obviously the chain is launched, like Celestia is live, and we've talked about kind of like what it means. And like looking ahead, like what's next? I think like I'm like genuinely curious, like how does Celestia now think about its next year and beyond, honestly?
Yeah, well, so obviously the first thing is to, the most important thing is actually to have people build things.
Correct.
And
Yes.
and use the protocol to launch rollups and L2s. And so it's something that we're really focused on. We're working closely with a lot of teams. The entire modular ecosystem of infrastructure has grown tremendously in the last year, and so we're seeing many more rollup frameworks, new like execution environments, shared sequencers, like proving networks. There's just like this explosion of all these teams that are helping to make it even easier for developers to build the L2s, and then we're working with a lot of those teams. Hyperlane being one of them, actually, and so they've been huge in terms of like building new modular bridging infrastructure. But then there's also the app layer, and I think so. We have a couple of rollups in the pipeline. Obviously, Manta is one that we hope to launch with soon, and there's also Eclipse coming up, which is a SVM. Based one. But something that I think people are underestimating is that, I predict in 2024, we're going to see like hundreds, if not maybe even more, rollups, net new rollups be deployed, or L2s. And like if one example of that is if you look at on the Dimension incentivized testnet, there's 1,000 rollups that have been deployed. And I think that's kind of like the wave, this like tsunami that is coming. And I think Celestia is like positioned and has the integrations with all of these different infrastructure providers to sort of be one of the go-to data availability layers that people choose to build on.
Yeah. When I saw Dimensions testnet, I was like, wow, this is crazy. I did not expect that many. It's an amazing sight to see. How many late nodes do you think that means in the future?
That's a good question. So the number of light nodes that you need to secure the network depends on is related to the block size, and I think it kind of leads into like the other side of the vision. Is like aside from getting people to use the protocol, one of the priorities is to like our long-term vision, like our next milestone after mainnet is to scale to gigabyte blocks, to have 1 million rollups deployed, and to have 1 billion light nodes. And that's like a very
wow.
This is a far in the future. This is when crypto is like mainstream.
Yeah.
But we think that all those things are possible, and we should strive for that. And so, in terms of how many, like the next step. So right now we have 2 megabyte blocks. We can scale to 8 megabyte blocks without any network upgrades. But we're trying to scale soon to 32 or 64 megabyte blocks. And like with that, I think we're going to need a number of light nodes probably in the thousands or 10,000, something on that order of magnitude.
Awesome.
I'm not completely sure off the top of my head. But I also actually want to give a shout out to Vistara Labs, who have been doing a really good job of making it super easy for people to run a light node. Just literally, you can run a light node in 2 commands in your terminal, and everything else is taken care of. And I think they were tracking, last I checked with Mayur, there was like 300 to 400 light nodes that had been deployed. So he's like tracking those numbers.
Awesome.
And I was like, wow, kind of blown away that there's already that many.
Not
like
bad.
right after
2 weeks in. Not
yeah,
bad.
exactly. So I think I'm excited to see where that goes.
Love it. Last question, kind of facetious, but where's the weirdest place you've run a light node?
That's a really, really good question. I should have an answer to this off the top of my head. I don't know, maybe like, I mean, I have one running on an Android device I have. Maybe in the bathroom is the weirdest place. I don't know.
Okay.
Like, sitting there, like trying to like get it to work or something. I'm not sure. That's a really good question. But
Not like Mustafa told me to ask that question. So
yeah,
that's
I
what
think
inspired
actually,
it.
I don't know if Connor from our team, from the Rollups team, is here.
Oh,
in the
I'm sure
audience,
he's
but
done some interesting things.
My favorite thing was he tweeted out that he was running a light node from Chili's.
Awesome.
Restaurant.
Yeah,
which
yeah.
is just, like, hilarious.
Love
So,
that. Actually, I remember that tweet. That was a great tweet.
Yeah, I just cracked up. And so anyway, I hope yeah, people like have fun with it and run light nodes in really weird places. Obviously, I run them on the plane. That's not really weird, but it's cool that like it proves that you can run it on really really low bandwidth because like airplane Wi-Fi sucks.
Yes.
For the most part.
I could barely load Gmail on my flight, so that's very impressive. You can do that.
Yeah.
Awesome. Absolute pleasure. Where can everyone find you the rest of the week?
I'll be here, and I think there's a panel, Modular versus Monolithic later,
Sweet.
and then I'll be at L2 Days tomorrow. But yeah, I'd love to meet everyone and build whatever, build modular.
Awesome. Sweet.
Thank you,
Nick.
Dougie.
Yeah.
Thank you. Let's have a 10 minutes break. You can have coffee. I'm craving for coffee, so see you later.
All right, y'all. Take a seat. We're going to have some fun, okay? Hey, hello, everyone. Name's Ben Rodriguez. I'm a protocol specialist at Coinbase, and we're going to be talking about sequencing, shared sequencing, and all the fun things that are related to that. We have some spicy questions for today. We have a lot of questions for today as well. We might not get to all of them, that's okay. But with me is AJ Park, co-founder of Radius, Josh Bowen, CEO and founder of Astria, and Charles Liu, co-founder and CEO of Espresso Systems. I'm going to let them introduce themselves. I just wanted to introduce them there. So, AJ, let's start with you.
Okay. Hi. First of all, thanks for having me here. I'm AJ from Radius. I'm founder of Radius and also co-founder of ZK Soul, which is the zero knowledge research community called in Seoul. So, Radius is building a sequencing layer, especially using encrypted mempool and ZK to make sure that the rollups can be MEV and censorship resistant as possible. Thank you.
Josh?
I'm Josh. I'm the founder and CEO at Astria. We're building a shared sequencing network using Tendermint and built on top of Celestia.
Hey, I'm Charles. I am one of the co-founders of Espresso. We are also building a shared sequencing network. And what we are focused on are two things, I would say. The first is, very importantly, credible neutrality through decentralization. And secondly, also very, very fast finality. So yeah, that's Espresso.
Awesome. Cool. We got those introductions out the way. Let's get right into it. So I think one of the big things right now is that it feels like crypto Twitter always argues about what decentralization actually means, right? So, in the context of sequencing, right, what does decentralization mean? What are the risks of centralized sequencing? And is there a world that centralized sequencing is actually enough? What is decentralized enough for a rollup?
I guess there's a lot of different perspectives you can take here, right? There's when we say like liveness is one thing, but you can solve that through a distributed sequencer where you have a load balancer architecture or whatever. There's a censorship resistant thing, and generally I think when we're talking about censorship resistance, there's two tiers. There's am I being censored by a single kind of malicious sequencer who doesn't like me? And that's I think not a huge concern. It's more the what does it take for the government to say you have to turn this box off and there is only one box, and so now your thing doesn't run. So that's probably the primary starting point, but there's some more nuance in kind of guarantees around kind of how the algorithms are expected to run and the guarantees you get in a network that assumes you have a rotating leader, not a single leader that has a persistent monopoly on ordering. But it's broad design space, I guess.
Yeah. I think that decentralization means a bit different from the one why we need in AES-1, I suppose, because the reason why decentralization is needed for layer 1 of Ethereum is security, but as long as security for rollups can be inherited from Ethereum, I think decentralization is needed for different proposed for rollups, like to better to operate the rollup network, like as Josh mentioned, that liveness, censorship, resistance, or like or governance or something. So to make sure that not like a centralized, the sequencers cannot decide like a transaction fee or something. So those kind of operation thing is much more needed for rollups. So I think the decentralization of sequencers for rollups is needed for those kind of reasons.
Yeah, I would definitely agree with everything that Josh and AJ said. I think to add to those points, from a very low level, I think there are two really key parts of how a sequencer operates. So first, I think, is who exactly is proposing the ordering of transactions. And then the second part is how does the network or the underlying the sequencer, if there even is one, finalize that proposed ordering. When it comes to a centralized sequencer, which is how most rollups are operated today, there's really just one entity that is always proposing the ordering, and they're also the only ones that determine whether that is final. And as Josh mentioned, there are various risks around that. One being censorship. You can have very discriminatory pricing. You could have a monopoly pricing because, as I mentioned, there's always one entity in a centralized sequencer model that always determines the proposed ordering. They know that they're always going to have a monopoly on that, and therefore they can really charge you whatever you want. And of course, there are differences based on the rollup design, such as escape hatches that kind of alleviate that, but they don't do that fully. And then when it comes to more decentralized models, such as, say, switching off the leader or switching off the proposer every once in a while, that actually introduces that actually breaks the monopoly pricing protocol, or the tendency to monopoly price, because it actually encourages the proposer or the sequencer to become myopic, which is actually a good thing. They know that they're not going to be the proposer of the ordering forever, so they actually want to include transactions and to gain as much in fees as possible during the time that they are the sequencer. And that is actually a good thing. It actually prevents censorship. But of course, then there's also the question of how that actually proposed ordering is finalized, and that's where the consensus protocol comes in. So sorry to.
Awesome. No, that's great because I do want to actually, before we get into shared sequencing, right, I do want to talk a little bit about the design space right now currently where there's certain protocols, for example, that might be experimenting or about to do something with, let's say, just general proof of stake, right, for their L2. Or something like, people have been kind of thinking about this, proof of governance, right, something where, use the governance token in terms of being able to select sequencers, right, to be able to do that. I want to get all your thoughts on that kind of design space right now before we get into what y'all are doing.
Yeah, so I guess we were looking at proof of stake, proof of governance. Usually these are used to define the leader set. And so it's usually meta to the actual leader rotation mechanism, right? In that, proof of governance is sort of a fancy word for proof of authority or whatever, right? Authority is a form of governance, I suppose. You just arbitrarily define these entities are the ones chosen. You could look at Lido as a mechanism where Lido has their operators, right? And that's the example that John Charbonneau has used a lot, right? And they say, okay, we pick these 30 and we equally distribute it to all of these 30 rather than doing a proof of stake, which is a stake weighted thing. But fundamentally, I think that is a somewhat secondary thing to the idea of having a decentralized set. One of the big things I think about decentralized sequencing, which I think we generally assume is implicit in a shared sequencer, is this lack of a persistent monopoly across blocks, right? And it's mentioned that's what leads to myopic action where they say, look, I have a use it or lose it opportunity, so thus I am not going to withhold transactions for a better opportunity to arbitrage them or whatever later.
As rollup is a scalability solution, Radius like to use consensus thing as least as possible. But there are some aspects that consensus have to be operated there, leader-based or POS thing can be used as a consensus. So when building a block, leader can be selected randomly, using a VRF or something, and then leaders can take full control of building a block or something. So, and then after that, they can make a consensus between other sequences or something. So, yeah, but there is other way that we can avoid those consensus model. For example, right now we are researching some kind of a deterministic way to build a block. So, like based on hash or anything, but so we can build a block to in corporate model, like not competitive model. So we'll see what Zen choice is better.
Yeah, I think in terms of the design space for sequencing, it's a very huge design space. There are many points within that design space about how a sequencer can operate. I think all three of our projects are at different parts of that design space. I think one dimension on sequencer design is really who is operating the underlying consensus protocol. So on one side of that, it's the very centralized model, which is what many rollups are doing right now, which is a single centralized sequencer. And then on the total opposite side is what's called based sequencing, which is basically the idea of just using the L1, like Ethereum, to order transactions. So the L1 validators would just be ordering that in Ethereum, for instance, on call data. And that is like totally decentralized with the same guarantees and properties as the L1. What we're trying to do at Espresso is we're trying to get as close to based sequencing as possible without being based sequencing. And we're doing that with various techniques, such as using a very scalable consensus protocol that we're developing called Hotshot, which scales to tens of thousands of nodes. And we're trying to involve the Ethereum validator set in that. So that's one dimension, which is really the centralization versus decentralization. And then I think, of course, there are many dimensions, but one other dimension, as AJ was hinting at, is the approach that the sequencer takes to MEV. So for instance, Espresso, we take a very agnostic approach. So we allow any rollup to use any really ordering scheme or MEV approach that they would desire. That could include threshold decryption, MEV resistant schemes. You could do various forms of priority fees, or we're working with Off-Chain Labs on developing time boost right now, which is another scheme. So I think, I think we all have are at very different points on that design space, and I think we're actually pretty complementary. At least I think Astria and Espresso are quite complementary with Radius's approach, which is taking a very MEV resistance approach. So yeah, that's my thoughts.
Awesome, I love that, and we're jumping into MVB. We'll get to that in a little bit, right? I do want to actually step back a little bit and talk about shared sequencing, where modular blockchains. We're here. It's modular day, right? Let's get modular, yo. What do you call that? The whole point is that it splits out functions of the blockchain and splits it out to do certain things, certain functions very, very well, right? So what does shared sequencing do well, right? In terms of in the context of modular blockchains, what does it solve? And what are some of the trade-offs, assumptions, stuff like that you have?
So our architecture coming out of Celestia as a project, to some degree, Astria came out of my time working at Celestia and the development of what do we need to do to have rollups build on top of Celestia. And it was based on the assumption that Celestia exists as a network wholly optimized to have large quantities of data made available with low trust requirements to guarantee the availability of that data via light nodes and data availability sampling. But the fundamental design space of Celestia is focused on having a large quantity of data and making other trade-offs that may restrict other things. So for example, Celestia runs at 11.8 second block time or something. It ranges between 11 and 15 or something. To have larger blocks due to how the block or reconstruction process is working and the sampling requirements. And so they're going to bias towards having larger blocks, even if that means having a slower block time. There's various designs on how you do sampling intra-block time or as an extra outside of the timestamp of a block time. But fundamentally their design space is trying to have large blocks and a large quantity of data. Astria is not trying to be duplicative in that and say, oh, we're going to provide data availability of the same set of data, because that data is assumed to be posted to Celestia, which again, optimized for exactly that use case. We want to offer, kind of fast finality and a lot of a more kind of smooth, dev tooling. There's all this fundamental design and kind of like DA layers for like the erasure encoding in Celestia. You also see this in like 4x4 with blobs, where like there's a minimum size of data you can buy on the chain. You know, in Celestia it's a share, in Ethereum it's like a blob. Well, if I want to buy, say, like a sub-blob amount of data, it's like 128 kilobytes. All right, well, like, what do I do that? You kind of need this kind of like, you know, aggregation layer above. And so that's also one of the functionalities we see like a sequencing layer providing. But generally we're in this design space of like thinking about ordering in a contextualized sense. That's where like MEV comes in. I'm not going to tangent into that too much. And then like faster finality is like obviously like a big thing because that is like the desired user experience that led to why we have sequenced rollups instead of like based rollups as the kind of status quo.
Radius want to help developers when they want to launch, when they want to develop their own rollup network, but developing rollup is really different from developing with smart contracts. If developers use smart contracts, sequencing is going to be taken care of in like Ethereum or any other chains. But when developing the rollups, sequencing should be taken care of for rollup network itself. So, but it's really a difficult one because you need to come up with like how to incentivize these rollup sequencers for rollups, those kind of economic way that you need to come up with. So I think shared sequencing layer, first of all, make those deployment of rollups kind of easy. So you can boost up your network as fast as you can, and then you can only care about your business logic. Now, another one is that as long as a shared sequencing layer help multiple rollups communicate with each other, we can come up with some kind of a unique services like a cross rollup MEV or like for example, flash loans can happen between multiple rollups. It's really difficult, but I think a shared sequence layer is really well positioned to support those kind of new way of services. Like since shared sequencing layer have a full control of building a block, we can make sure that atomic inclusion can happen between multiple rollups. But another one, but it's not enough. We need atomic execution also can happen between rollups. So that's what Radius been researching on for a couple of months. But so basically we can solve this fragmentation thing that always the problem of rollup approach can be solved with a shared sequencing layer, I suppose.
Cool. Yeah, I'll talk a little bit about our approach to the shared sequencing part, because I think we already talked about the decentralized sequencing part. And so, yeah, I think AJ hinted at a lot of good points. So right now, first of all, the Rollups ecosystem is quite fragmented. Rollups are an amazing scaling tool for Ethereum and other layer ones. It's allowing many hundreds, thousands of times more transaction throughput. But at the same time, we're getting very similar silos to what we had with the many layer ones before. And it's, rollups are basically like different chains right now. So the idea behind shared sequencing is to allow multiple rollups to plug into the same sequencer. And that sequencer can give guarantees around, as AJ put it, atomic inclusion. What that means is that a sequencer can guarantee that if a user wants to have 2 transactions on multiple rollups go through at the same time, but only together. So let's say, for instance, Alice wants to buy an NFT from Bob on, say, Zora, which is a rollup, and wants to pay for that using USDC on Optimism or Arbitrum. Alice might want those 2 transactions to go through together, but not one by itself, because then either the NFT would be getting transferred to Alice without payment, or Alice would be paying Bob without getting the NFT. So that's sort of the use case a very simple use case where you would want atomic execution. So you want a guarantee that both of those transactions are going to go through and actually execute. The problem is with the design of sequencing that Espresso is working on, and I believe Astria as well. We're not really doing we can only guarantee atomic inclusion, as AJ said, not atomic execution. So then the question becomes, what is the value of shared sequencing in this sense? And what can you get from atomic inclusion that gets you part of the way to atomic execution? And one really important thing to consider here is how shared sequencing benefits the building ecosystem, how it helps builders provide the actual atomic execution guarantees that you need. So for instance, if you're thinking about a builder or a builder protocol like Suave, which Flashbots is working on, the builder wants to be able to know that when they build blocks on multiple rollups, that they can make these atomic execution guarantees across multiple rollups. And without a shared sequencer, it'd be very, very hard to do that, because imagine you want multiple transactions to go through on n different rollups, on many different rollups at the same time. That builder or that builder protocol would have to coordinate with all these different rollups and be selected for all of those rollups, or coordinate with the proposers on all of those rollups and make sure that all these transactions that you want to be atomically executed go through at the same time. But with a shared sequencer, let's imagine that all those rollups are plugged into the same shared sequencer. That's much, much easier, because the builder really only needs to interact with that sequencer. So that's really the advantage of shared sequencing. It doesn't get us all the way there to what we need, but it does help tremendously to an extent that no other solution really can.
Awesome. And there's a lot to unpack there. One thing that I want to actually unpack is the transaction flow, right? I think there's so many layers now, right? We got for example, we have the L1, then we have the L2, and then if we have a shared sequencing layer that's going to be doing some of that stuff as well, like abstracting away some of the functionality, right? How does that transaction flow look like? And we can also add on to it value accrual, right? Where does value accrue in this set of stacks that we have here, right? Where is it the L1, the L2, the shared sequencing layer, right? And how does that is that part of fragmentation as well, for example, right? There's certain things that that are kind of unclear in terms of where value accrual happens. So let's start with that.
Yeah, so if we just start with the transaction flow, there's again, the design space is very broad and abstract. We have a roughly defined, we'll call it a reference architecture or whatever, where we assume an end user wants to interact with a roll-up state machine and not the shared sequencer state machine. Thus, the shared sequencer is a network to some degree, depending on how much you want to enshrine a given roll-up into it. It can be thought of as a wholly distinct network where it has metering, essentially just for DOS resilience, right? You have a decentralized network. How do I meter the kind of usage of the network? You have a token native to it, and it costs money to spam the network or whatever, right? We assume that an end user doesn't really care about the sequencing layer. They just care about I have state on a given roll-up state machine and I want to interact with that state. So we assume they will be having a wallet, a MetaMask, whatever, that talks to an RPC of an EVM roll-up, and they're going to sign a transaction that is going to essentially authorize, right, a transfer of funds within that state machine, right? And then the flow of that transaction into the sequencing layer, that is actually where, to Charles' point, we think PBS or a builder market will come in, such that if I'm an end user and I want to have a transaction that goes across chain A and chain B, whatever, I want to buy on one, I want to sell on the other, I will actually sign a transaction for both of those. Maybe you have a UI layer that is abstracting this through an order routing protocol, or something like that, a CowSwap, a Uniswap or whatever, such that you make one interaction on one website. It results in two signed transactions for two distinct state machines, right? That is where your wallet kind of authorization goes in. And then you have a searcher, builder, solver, whatever, call them what you want, right? That is then taking these transactions, they're signed out of state machine A, state machine B, and it is bundling them into this actual kind of atomic bundle that is then being submitted. And right, we can get an argument over how vertically integrated a searcher, builder, prover is, but roughly think of it as one entity for now. That's accurate enough. And they are going to then get this bundle to be landed atomically in the shared sequencing layer. And the shared sequencer fundamentally provides this kind of single temporal zone, right? Such that from an MEV perspective, it is really an intra-domain MEV, such that the builder is not taking any kind of inventory risk, saying I have settled one leg of my trade, whereas a naive design cross chain, or say if we're looking at the SexDex arb between Binance and another chain, you're having to hold some position open for some time longer. But that's roughly how we see the flow. Briefly on value accrual, I think fundamentally it's a multi-sided market. How that is going to work is going to be highly dependent on the negotiating power of different entities in this space, right? I need this from the DA has yay much scarcity. How much do I have to pay to get that? The shared sequencer has so much demand. To some degree, its bandwidth is going to be constrained by the underlying bandwidth of the DA layer from which it is posting to. And then the rollups are going to presumably have the liquidity on them. They're going to have the state that is actually meaningful to a user. They might have the community, the ecosystem, the front ends, that is going to play into like their negotiating power there. Where the actual value accrues is going to be some kind of hand-wavy negotiation between all of those different parties.
Okay. So transaction flow in our architecture is kind of somehow optimized for MEV. I know that there's a MEV is kind of controversial, but we define bad MEV, which leads to financial losses on user side, like front running or sandwich attack. But there's a good MEV also, like arbitrage or liquidation, bankrunning. Those things are not likely lead to financial loss on user side. So Radius uses encrypted mempool to make sure that to protect users from these bad MEV. So there's two things that users need to do when creating transactions. First, they need to encrypt the transactions so no one can see your contents, so there's no harmful MEV happening with your transactions. Another one is that ZK proof, because since these transactions are encrypted, sequencers cannot distinguish these transactions is valid or not valid. So it's the responsibility for users to prove that the integrity of transactions. So we used ZK to prove that this integrity and also the integrity of the whole encryption process. So make sure that sequencers are not wasting their computing resources or any block spaces. So after sequencers build a block with this encrypted mempool, and then decrypting all of the transactions, we will post this bundle transactions to like build a market. So we can extract good MEV from this one. But we can guarantee that a user's transactions, the order of users' transactions in encrypted mempool are protected because we, as sequencers, have to respond to users with the order commitment. It's kind of pre-confirmation that should be followed by sequencers, so they cannot manipulate the order of transactions. So we can extract a good MEV from this bundle, so you can make a profit, and then this profit would go to Rollup network, so they can make their network sustainable in an economical way. So, and then value accrual, I think probably, as I said before, we can support this cross-Rollup MEV, those kind of services that only unique in sequencing layer thing, but we'll see how to accrue value.
Cool. Yeah, just to speak very briefly about the transaction flow in Espresso, one of the design principles for Espresso is to really make things as seamless for the users as possible and to also make integration with rollups as easy as possible. So really, there should not be much difference in user experience compared to current rollups when users are using current rollups and just submitting transactions to the centralized sequencer. With Espresso, similarly, users can submit to an RPC endpoint that's very quickly sequenced by the Espresso network. We use, as I mentioned, Hotshot, which really prioritizes fast finality. So the experience should actually be very fast. And in fact, in our test nets, the finality time is actually even faster than MetaMask refreshes. So should be very, very similar in terms of user experience. There certainly won't be a need for any extra fee token or native token or anything like that. Fees are still managed by the rollups themselves. And what's going on in the back end is really, as Josh hinted, there's sort of a builder market that we imagine that will interact with the proposers in the network. And of course, the approach to MEV is also pretty agnostic that we're taking in Espresso as well. In terms of value capture, that is a great question. I've heard many people say, since the sequencer is the part of the stack that decides the ordering of transactions and therefore can extract MEV, that is where the value is going to flow. But I actually disagree with that point. As Josh said, there's many entities interacting in this modular stack that we envision, and value really is going to stay with the rollups and their users. Rollups and their stakeholders are ultimately going to be the entity that determine what sequencer they use and what approach to MEV they're going to take. And the fact that a sequencer determines the ordering does not mean that the value is going to flow there. Sequencers need to be providing a good deal to the rollups and their users in order to be adopted. And therefore, Espresso, we intend to allow rollups to decide what approach they want to take to MEV. Much of that value is going to be shared back to rollups and their users, and there's going to be a lot of flexibility as well for rollups that decide to integrate with Espresso.
Awesome. And let's expand a little bit in terms of we were talking about value accrual in general. I think this is a question where there are many different layers, and the idea is that these rollups will plug in to a shared sequencer, right? I think the question is, why would they? That's one. And two, what's to stop, for example, let's just say Arbitrum or Optimism just build their own, shared sequencer across their stack, for example, and why would they use any of your solutions?
Yeah, I mean, it's fundamental an economic specialization thing, right? It's inherent to the idea of a modular ecosystem, right? You can just say, oh, well, we'll have another piece and we'll vertically integrate, and that will allow us to capture a larger portion of the stack. And I think this is an open question, the broad modular space, right? Is there sufficient revenue flow to pay out due to it's broadly go back to the original firm paper of why do people organize into organizations that we now call corporations, right? Is because it is an easier way to align interest in a centralized manner. We split that across a modular stack. There is overhead due to communication between distinct parties, and incentivization mechanisms are more difficult here. But fundamentally, the argument is that in a broad enough economy, you want economic specialization at different parts of your stack. And so you say, okay, the DA layer is going to do this. The sequencing layer is going to be good at doing sequencing things. Is that the useful thing that a roll-up thinks is their core expertise, or are they saying no, we're actually building a state machine? Whether that's an EVM with modifications to it, a la Stylus, are they working on fraud proof generation or validity proof generation? And do they say actually I want to go get an off the shelf sequencing solution? There's network effects from this potentially, right? If we think about order flow, one of the interesting things looking at intent networks and various things, you question whether liquidity is going to continue living on a state machine, or if you look at Uniswap X's paper, it says the solver is able to satisfy a user's transaction preference using liquidity that is available on off-chain venues. So now we see, okay, does liquidity actually cease living so much on individual state machines and move off? Does that now mean that a shared sequencer, as the person coordinating these searcher, builder, solver networks, is going to be an entity that might have access to this order flow by way of having searchers and builders with bags on centralized exchanges to actually settle the kind of transactional preferences from a user, and that gets taken away from the end, the roll-up actual place? Again, I think there's a lot of questions around this, from do we assume the roll-up market is fundamentally going to be as static as it is now with call it 5 players with ballpark, with most of the liquidity on really one, right? Arbitrum is the dominant player right now, right? Optimism is number 2, everyone else is a distant 3, 4, 5. Do we think there's only going to be 5 roll-ups, in which case then yeah, those roll-ups are going to have an extremely strong negotiating position. It may be more desirable for them to say, no, I'm not going to build this out, I'm going to do an acqui-hire or an acquisition, or build it out myself. If we think there's going to be 500 roll-ups, it's probably not all of them are going to build their own decentralized network.
Okay, so let's suppose you want to deploy your own roll-up network to operate your network transparently. It's really different. I mean, running sequencing node is really challenging for you. So, because if you want to decentralize sequencers properly, there are a lot of things that you need to care of. If you want to decentralize sequences, there will be in modular approach, there will be builders, proposers, and also approvers who generate a ZK proof or any other proof that you calculate new states correctly. So those 3 entities should be communicate each other very well. So it's coordination between these 3 entities kind of difficult to manage. So I think shared sequencing layer can help the coordination and communication between these 3 entities to make sure that your roll-up network works properly. For example, we make sure that prover get enough data from a proposer, but there should be some kind of attack vector that somehow withholding attack something. So I think sequencing layer can help those kind of things. So with a quite good approach. So yeah, that's my point of view.
Yeah, I think Ben asked a really good question, which is why would rollups adopt a shared sequencing layer rather than build one themselves? especially in a world, as Josh said, where I certainly imagine there's going to be thousands of rollups rather than just 5, maybe even as early as a year from now. And I think it really comes down to credible neutrality, and that's really what we're focused on at Espresso, is building a very neutral and a very decentralized platform that rollups can plug into. That's part of why our design philosophy behind Hotshot, the consensus, is to be able to scale to thousands of nodes and ideally scale to become the same size and even the same physical nodes as the Ethereum validator set. And if you think about, approaches to shared sequencing, many rollups are certainly not going to buy in. They're certainly not going to plug into a shared sequencing layer that is just a single node operated by a company, say in the US, or even a sort of distributed sequencing layer with maybe like 10 nodes operated by a small group of companies. So that's really where credible neutrality comes in. To give an example, a couple months ago, we announced a partnership with Offchain Labs, which was the original developer of Arbitrum. And Steven, their CEO, actually made a really interesting tweet on why they decided to partner with Espresso rather than build it themselves, because certainly Ed and the team at Arbitrum, or at Offchain Labs, they have all the technical expertise necessary to build something like this. But the reason is because if Offchain Labs were to build their own sequencing network, it'd be very difficult to convince the other rollup stacks like the Optimism stack, Base or ZK Sync, all of these stacks to plug in. And that's really where Espresso comes in. We view ourselves as a neutral, credibly neutral sequencing layer for the entire rollup ecosystem.
Awesome. This is just one last question. I know we're at time right now, but this is more to just show yourselves a little bit. What's next for Radius, Astria, and Espresso? What is immediately on the roadmap? Promote yourselves a little bit.
So it's just briefly, we launched a DevNet a couple weeks ago. We fixed a bunch of bugs. We'll be regenesing that kind of this coming week. That'll move us towards kind of something much closer to a testnet architecture. We've got a bunch of interest from validators moving towards a proper decentralized testnet, such that we can actually make sure we can run this network with multiple operators, not just multiple nodes. Moving on to a live Celestia network, and then alongside that, we're working on a lot of tooling we hope to have out in the next 2 to 3 weeks to kind of really reduce the barrier to entry to kind of launching a rollup that utilizes a shared sequencing network.
Okay. So we also launched our first testnet called Curie with encrypted mempool and ZK. So you can find out in Twitter that we explained how it works or something. So our next stage of Radius would be we are planning to publish our research article about this, how to manage this coordination between this proposer, builder, prover thing. So that's why we are focusing on discuss it with actual clients Rollup as a service project or any other tab project who wants to build their own Rollup network. So we right now we are gathering some requirements from them. So we will see how it goes.
For Espresso, we recently launched our third testnet called Cortado. That I believe was one of the first, if not the first, sort of shared sequencer in testnet, since we had between 2 rollup stacks. So we had an OP stack integration, and we also had a Polygon stack integration, and it was possible to send transactions across both. Gibraltar, our next testnet, is coming out in January. That will have an Arbitrum stack integration as well, and we'll also have a lot of improvements to to the speed and reliability. Right now with Cortado, it's still live. We've deployed it in partnership with Caldera. We've deployed a test rollup with Caldera, and you can try it out. You can try out the very, very fast pre-confirmations, almost instant, despite the network being run by thousands of nodes. And yeah, very, very cool.
Awesome. Thank you so much, y'all. Really appreciate it. And also thank you to Hyperlane and Celestia for having us here. This was super awesome. And thank you so much.
Hi guys, how are we doing? We are not making a break because you're running behind schedule, so we're going to jump right into the interoperability panel. Thank you. If you want to go out and speak, please go out.
All right, everyone, we're back. for the second panel of the day. If you want to have conversations, I invite you to step outside. If you want to follow along in this fascinating conversation about interoperability, I invite you to get seated, get comfortable, and listen in. I'm Sebastian Couture. I'm the GP at Interop Ventures, also host of a couple of podcasts, Epicenter, the Interop, which you may have heard of. And today we're talking about interoperability. It's one of my favorite topics in crypto. I think I've done about every interoperability protocol on the podcast. Actually, a few of the teams here I haven't had on. Hyperlane was on a couple weeks ago. Yeah, so before we get started, I just want to get everybody to introduce themselves and briefly explain the project they're working on. Starting to my left.
I'm Uma. I'm one of the co-founders of Succinct. We're making it easier for any developer to build with ZK, and we've worked on a bunch of ZK-like clients, which make Interop more secure.
Cool. I don't know if this is on, but yeah, my name's Trevor. I'm an engineer at Hyperlane. We are a modular and permissionless interoperability protocol, so anybody can deploy Hyperlane, and we're not prescriptive about what security model to use in messaging.
Nice. My name's Noah. I'm the co-founder and CEO of Nodekit. Our big thing is making shared sequencing as easy as possible for both the end users as well as developers. We think interoperability is a big piece of that.
Thank you. So interoperability is also a scaling topic. You know, we're here because Celestia is making blockchains modular, so scaling vertically. Interoperability, I think, scales blockchains horizontally by making domains of state interoperable with each other. Scaling has always been an uncomfortable topic in crypto. I mean, I remember the scaling debates in Bitcoin back in the day, and scaling has always been something that sort of pushes us to the limits of, you know, the ethos of crypto in terms of decentralization and trust minimization and finding the right trade-offs here. So I'd like to ask all of you, you know, in terms of providing better interoperability for blockchains, you know, what specific solutions are each of your projects sort of tackling, and where do you situate yourself on the decentralized, permissionless, trust minimization scale or trifecta?
I can go, sure, yeah. So like I mentioned, we kind of decouple the interface for sending messages from the actual security for those messages. So by doing that, there are a couple of things. So it allows for future proofing, like if you are waiting for some kind of succinct proof, like from a particular type of blockchain's consensus, but you want to ship today, like you can do that, and then in the future swap out for that better version of security. You can compose security, so let's say I want to go from Ethereum to Avalanche, like I can choose to use like the, I think they have like some kind of canonical bridge between the two, or Axelar or us, and you can say I want all three of these to sign off on this message. And then another thing is that anybody can deploy Hyperlane themselves. So in a world where there are like thousands of these modular chains that are being created, and we're hoping to lower the bar for having these interoperability protocols on these chains. The current state is I go to one of our competitors and say, hey, here's 300 grand, like deploy onto us. And I think that's like totally unsustainable and like super messed up. And with us, you can just go to our docs, you can run a couple scripts, you can deploy all of our smart contracts on chain and run the off-chain infrastructure yourself. So we're not prescriptive at all about like the security, and we want people to be able to deploy these things today.
Nice. So with shared sequencers and really tackling the problem of interoperability, it's mainly for rollups. That's kind of the main customer for most shared sequencers. With a shared sequencer, you're able to do this thing called atomic inclusion. And what that term really means is you're able to guarantee the inclusion of two transactions in a given block, but the ordering of those transactions and this concept of atomic execution is one thing that a lot of shared sequencers are trying to tackle currently. The way that we view composability as well as interoperability is really something that needs to be something that can scale over time. It's obvious to our team that CK is kind of the way of the future, but the current state of the environment is to go sub-second and sub-block. There are some methods to be able to do it, but they haven't reached mass adoption yet. So we kind of have taken kind of an agnostic take on it by building our systems out to essentially be able to integrate with CK technology as they get more fleshed out,
but also being able to do composability seamlessly via different builder guarantees currently?
Yeah, we're focused on the ZK layers for security, as you guys both mentioned. I think our opinion is that the ZK is the future of scaling interoperability and making it more secure. I think interoperability, if it's always just relying on these like permission multi-sigs, doesn't scale super well because there's like no fundamental trust in it. And so I think like the ZK proof of consensus is kind of like the ultimate end game for scaling between like different L1s, and then you have like the ZK rollups and ZK proofs of execution that's helpful for scaling interop between different L2s. Similar to Hyperlane, we try to make it easy for anyone to deploy our ZK-like clients on any chains that they want, so that anyone can use ZK in making any bridge. And we also intend on like integrating with a bunch of different bridge providers, so that it's not just like our own bridge that's ZK. It's like all bridges can be secured with ZK.
So one of the things I've been thinking about recently, since just talking with so many different interoperability solutions, is fungibility. So by introducing many different bridges or ways to interoperate, or essentially have chains be able to verify the state of each other, we introduced sort of this problem of fungibility of tokens. John. Actually, no, sorry, it was someone else who came on the show recently, was talking about how they're trying to solve the fungibility problem by providing proof of provenance of where the tokens come from. I hope that that is one day the case, right, where we don't have all these sort of like wrapped assets coming from different bridges. So yeah, in the context of what you guys are doing, how do you think about like the future of interoperability and making it such that we don't have a terrible user experience, or at least that the user experience goes into a better direction rather than a already sort of like not great state of the affairs?
Sure. I guess I have two microphones. Yeah, I think it's a hard problem. Like, I think for the last 2 years, everybody's kind of been like saying, oh, like token bridges are bad. Like, we want to change token bridges. But I think many people haven't like really innovated too much there. And I think like having these different representations that relate to like a different origin chain or a different kind of security model that secures those tokens is kind of inevitable. I think you're seeing like some chains that have like tried to be more prescriptive about, hey, this is the canonical like bridged version, and I think that's probably the right move. I think you see like a tremendous first mover advantage for these kind of bridges who are like, I want to support this token on this chain. I'm going to try really hard to cement my representation on this chain. And I think it's no question that like the user experience is pretty terrible using all these chains, and it's just going to continue to get worse. And when I were just talking, like if you go on Ethereum and look at all these like really cool infrastructure projects like Dune or Gnosis, like none of these are available on all these other chains. And I think like that's something that we're just going to have to focus on, try to lower the bar for bringing these like really intense pieces of infrastructure to these other chains that are just spun up with the snap of a finger.
Yeah, I agree. I actually was speaking of Nick White about it earlier as well, and kind of the difficulties that you face as you increase the amount of rollups, because the interactions between them get really weird really quick. Because I don't know if anybody's used MetaMask with over like 10 or 15 chains. UX kind of sucks, and who can blame them? These applications and these wallets and all this infrastructure was developed for a world when we only thought we were going to have 10, 20 chains max people were going to use, and now we're seeing rollups. And we're seeing rollups, like one of the great examples is Iris, which powers this thing called Momoka for Lens Protocol. Momoka costs roughly $250, $300 a month to run. That's insanely cheap compared to most rollups. So when we're seeing that rollup costs can get so low, you really change kind of how fungibility can act on these different rollups. So I think one of the big things is kind of the social layer, and also it's probably going to come down to DAOs for a lot of the representation as we kind of saw with Lido and their wrapped staked ETH. I think it's going to come down to DAOs, which is something that I don't think a lot of people are kind of betting on currently. But the fundamental matter is if a DAO says, we won't partner with anybody that uses, let's say, Layer 0 or Hyperlane or Wormhole version of my asset, and the DAO says, we won't support any partnerships on this given chain because you're using their asset, who would want to use that asset? It's going to make it untouchable. It's going to make that asset basically be diseased, and there's going to be no liquidity for said asset. So your only options could be turn around, burn it, and go back to the origin. So I think that's going to be the really tough fundamental issue is DAOs are going to run it, and it's just kind of kind of be the reality for most crypto native apps, in my opinion.
Yeah, I think having a canonical asset anointed by the DAO is really great. And then maybe we'll get into this later, but you can have like a relayer system or liquidity network on top that, you know, maybe like changes between these like different versions with like different security mechanisms. But I strongly feel for like having a sane user experience, having a canonical version on each chain is kind of like the only way to go.
Yeah, I mean, that works as long as there is either like strong governance mechanism or an organization that is pushing that canonical asset or that canonical bridge. You know, for ecosystems that are, you know, that pride themselves for being more decentralized, you know, maybe expanding on this liquidity layer on top, like how would that work to facilitate fungibility between tokens when there are multiple bridges providing interoperability to that destination?
Yeah, I think if there's no like canonical asset, then it's kind of hard to have like the fungibility. But if you do have a canonical asset, you could imagine that like different relayers basically kind of front the money through like they're responsible for bridging through the different canonical or the different security mechanisms, and then they'll be responsible for swapping it into the canonical asset and using like whatever liquidity exists. And the user doesn't have to deal with that. Because I think as a user, the hardest part is, okay, you purchased token, now you want to use it, but your protocol that uses it, you have to first go through a DEX, and that leads to like way too much effort. But I do think if there isn't social consensus around like a canonical integration asset, then of course the solution doesn't work as well.
I mean, what you're talking about here, and this kind of touches on my next question, and maybe make it a bit provocative, is that you're talking about a hub essentially, right? And so from the perspective of Succinct and Hyperlane, correct me if I'm wrong here, but the idea is to have chain-to-chain interoperability, direct chain-to-chain message passing that scales to, you know, exponentially on the number of chains. You know, Axelar has the sort of more hub and spoke architecture where you have this liquidity layer in addition to interoperability, and it facilitates the interoperability between the different assets. Isn't that the model that sort of you're describing in the end, only in one single product?
I think you can have it both ways. Like, I think if you want direct chain-to-chain interop, which might make sense for some like larger chains that don't want an intermediate hub, then you can have these like ZK proofs that when you verify the ZK proof, then it becomes like the canonical asset. So that is how you bridge the canonical asset. But then for other chains, maybe it doesn't make sense to have this intensive process, which requires a lot of work to maintain these canonical assets. So in that case, maybe relying on like Axelar or some other hub and spoke model to be your quote unquote canonical asset actually does make sense from the perspective of the people who run that chain. And then the social consensus can be around like this hub bridged model, whereas maybe for other chains, and over time you can definitely migrate to between the hub model to like having your own canonical asset if you want to facilitate chain-to-chain interop, if you get big enough to warrant that.
Yeah, I would say in a similar vein, like you can still have fungibility without this kind of hub and spoke security model. Like it's just easier to reason about because you don't need to worry about like the weakest link. But if you're willing to worry about the weakest link, you can still like totally have fungibility between all these different chains. I think Axelar's approach is like interesting because it's easy to reason about. I think like there are definitely some downsides to it. Like they, can't connect to that many chains. Like they're trying to come up with solutions for this, but it's looking really similar to just some kind of marketplace where you pay their validators to do it, and like that's not really permissionless in my mind. I think also like if things really do take off as we want to, there will be just so many messages going through, and like I don't think you'll want to have to worry about additional fees on another chain.
Yeah. To follow up on that as well, I think we've also it's sad, but we've seen the issue when you don't have token fungibility at all. I don't know if other people are familiar, I'm sure you guys are familiar with Hyperlane. When you see the 10-character long token name, because they've been wrapped, bridged, so many times, and then you end up with having to do like IBC unwrapping essentially. And stuff like that I think should really be something all of us look at going forward and say, this is what we shouldn't have, because that UX is just horrible. And it's sad, but I think as an industry, we really need to make sure we're moving forward and looking at how can this UX be great, not just the dev experience, but how can I hand this off to one of my family members and they're not saying, dude, why do I have 50 versions of Tesla stock? There should only be one in the end.
Well, I'm glad you brought up IBC because it wouldn't be an interoperability panel without bringing that up. And as an IBC maxi, I think I can say that. I've always sort of believed that this sort of client verification model for interoperability, and specifically, I think what's great about IBC is that it is an open permissionless protocol that everybody can use. And build implementations for. So we have teams like Union and Polymer that are building implementations of IBC into Ethereum. And there's actually a solution to this. It's called packet forward middleware, right? And so the Strangelove team and others in the ecosystem have built this middleware that routes packets back or routes tokens back through their origin chain in order to avoid this wrapping issue that we have. Is that something that applies also in the context of, say, like Hyperlane or Succinct or interoperability through sequencers? Could we have this sort of middleware? I don't know how it would look like in this context, but that would sort of unwrap tokens before moving them back somewhere else to avoid this problem?
Yeah. So at Nodekit, I would say potentially, but it also comes down to how many fees are you having to pay when you have the packet forward middleware? Because I think the biggest issue with all three of our products is the balancing of security, but also making it so I don't have to spend $30 every single time I want to do transfer, because if I'm transferring $30, I'm not going to want to spend that in fees. I feel like that's kind of the whole reason why everybody went to rollups versus operating on Ethereum mainnet, is to decrease those fees. So if I'm having to pay fees across all these IBC chains, is that how packet forward middleware is currently designed? Because that sounds like you may have aggregators that don't use packet forward middleware, just if I'm aggregating liquidity, and a simple kind of algorithm of if I'm trying to get the most liquidity for the best price, but I'm paying this amount of fee using packet forward middleware, you'd never route it through it, would you? I feel like that's the issue there. And if there's subsidization, I think that also is a great route, because if we think there's going to be 10,000 chains, we have to have revenue generating there. Otherwise, if we just subsidize, it works great for a bit, and then it's just, boom, fees spike the day after subsidization ends. That's kind of our stance.
Yeah, so we recently launched a CosmWasm implementation of Hyperlane. The goal was to bridge TIA from Celestia via Cosmos chains and then to Celestia rollups.
Very cool.
And yeah, I think the whole experience has just like continued to reiterate, that meme of like Cosmos has built out all these really cool things, but nobody uses them, and like let's bring them outside of the Cosmos ecosystem. And those hooks that you talked about, like the IBC hooks, are super, super cool, and you can totally do that outside of IBC. I think, I guess riffing off of what you said, I think maybe this is a hot take, but I feel like in the IBC world, relaying is like not super well thought out, and like a lot of the relayers, to my understanding, are just like entirely subsidized by some grant from a chain. And when you do start working in an environment where like fees are going to be higher and you're doing multiple hops, I think it does kind of come more to mind. But that said, like I think a lot of the patterns and standards that IBC has pioneered are super interesting and like clearly are really well thought out.
Yeah, I think our relationship with IBC is we can help with ZK proofs. You can make IBC possible to like actually be verified on Ethereum mainnet or Ethereum rollup, and yeah, make it much more like applicable to a variety of domains, even ones where gas is super expensive.
Cool. So on the topic of sort of bridging IBC into Ethereum, this brings me to this idea of mesh security. Now, this is something you brought up in a blog post you sent me by the Informal team, and something that I've sort of become aware of recently was this idea of being able to utilize Ethereum stake to secure chains across interoperability protocols. So interoperability protocols are not only about moving tokens, but they're also about passing messages, which would allow you to do this sort of thing. So effectively, you could have like a Cosmos chain or like a Cosmos app chain or a Cosmos rollup secured by Ethereum stake. What are your sort of respective projects doing in that realm?
Yeah, so I think restaking is like super cool. It's amazing to see the way and like different flavors that exist in these different ecosystems. One of the cool things about Hyperlane is each message, when it's dispatched from the origin chain, it's inserted into this smart contract level Merkle tree. So there's this root that like attests to all of the messages that have ever been dispatched from that particular origin. And it means that it's super easy to tell if somebody has ever signed something, like one of these roots that attests to all these messages on that origin chain that is fraudulent. So you can have like totally trustless, deterministic like slashing conditions on the origin chain. And using, like for example, an eigenlayer with Ethereum, and leveraging like the native bridge between the L1 and the L2, you can even have the eigenlayer level stake live on the L1, and then have validators or whoever that are signing these roots on the L2, and then still have that like property of like a trustless slashing condition by like using that native bridge to notify the L1 like, hey, this validator's committed fraud. So I think that stuff is super cool, and like it's exciting to see that happen in all these different chains as well. I think one of like the cool things about Hyperlane, and I think really a lot of what everybody on this panel is doing is those kinds of things that like might take a while to implement in these different communities can totally be added like super easily and supported by our protocols. So I'd love to see that happen.
Yeah, I really like the Hyperlane team's approach, because your guys' modular approach makes it so that when the eigenlayer restaking comes live and is working and people implement it, you can integrate it into your bridge mechanism. Or when the ZK stuff finally becomes like maybe performant enough or it gets implemented, then you can integrate it. So I think it's like a really smart approach to accommodate like a whole wide range of security mechanisms that might be appropriate for different protocols.
Yeah, I agree 100% on that, especially with the messaging kind of mechanisms that different people are figuring out. I feel like one of the biggest issues right now for interoperability as a whole is everybody's developing all these different standards. And if we have 50 different standards of how messages are supposed to pass through, who's going to develop on these different standards? Because it's the Google problem. I don't know if people are familiar, but like Google Stadia and Google Music, all these different products, Google makes all these different products, but they kill them off because there's no so if you're an outside party integrating on Google, it's scary because you don't know if they're just going to kill off the API. So I feel like the more people you can get to adopt a standard, the better. But one thing I did want to talk about with eigenlayer and kind of its security as well is you have the security of eigenlayer. Yes, you have Ethereum stake backing it, but you are still relying on the security of eigenlayer itself and its smart contracts, as has been seen as some of the exploits that have happened on other smart contracts. It is Ethereum security, but because of just the way it's built as a smart contract, you are still reliant on that. And I think that it's a very interesting proposition, but I think the jury's still kind of out on whether or not it's as secure as we all think. And I think that I really hope it is, because a lot of people are building on it. But I think that kind of this mesh security point makes a lot of sense. But I definitely think it's still very open on, does it work long term? Is it as secure as we all think? And we just haven't seen it at scale yet. I'm excited to see how it all goes out.
Yeah, so looking into the future, as we wrap up this panel here, because we're running about out of time, what does the future look like? And I think it bears thinking about the the evolution of the web and how just 15 years ago the web was a lot harder to use between platforms, between types of devices. If you were using an application on Windows, that application you wouldn't have that application on a Mac, and also the same for like Android and iOS. And the way we achieved interoperability is really at the application layer, where now you have everything living on the web and living through some sort of an API, and that's how we've achieved interoperability through the application. What does interoperability look like for blockchains in a world where we all think that there will be thousands of blockchains or decentralized applications utilizing shared permissionless state to verify the ordering of transactions, et cetera, to provide us with this sort of future of cryptographically verifiable ownership of digital assets? In 10 years from now, if we're sitting here on this panel, what will that world look like?
Well, I hope in 10 years that there are no more interoperability panels and that we've solved the problem and users don't have to worry about it. And there's maybe some canonical standard, maybe it's IBC or some of evolution, and only like a small group of developers have to worry about it, and there's clean, nice APIs. Like similar to what kind of like Stripe did for Web 2, where to most websites you just go, you put in your credit card, you don't worry about any of that infrastructure. And honestly, most developers today don't even worry about that infrastructure. They just use like the Stripe API or widget or whatever. I hope we can get to like a similar spot with interoperability, because it feels so core that I don't think adoption will get there unless we have kind of that ease of use.
Yeah, totally agree. I mean, we all get to interact with a lot of these chains, and sometimes I have days where I'm like, man, like the fragility of like this entire ecosystem is like a little bit worrying. Like we have all of these different like flavors of one EVM, but like on all these different chains, and like some tools only work on certain chains, some don't. Like pairwise connections between chains, like the security model that's used there, like sometimes you need to do some on-chain digging to figure that out. So I totally agree, like moving towards some kind of standard that every single like blockchain, regardless of execution environment or consensus, can kind of adhere to, something maybe with either economic stake or like succinct style proofs would be interesting. But yeah, I feel like I hear a lot of people say like, we want to build something so that way when people use a blockchain, they don't know what blockchain they're on. And like, at least in the current environment, I think that's like totally unreasonable. And there are like so many things relating to what you just said that are required to have that kind of feature.
Yeah, I agree. I really think that whether it's using succinct proof or economic staking or both, I think that building a future where blockchains aren't scary, I think that should be kind of crypto's industry, like, we really should have that be something the industry echoes, is saying crypto isn't scary and making it less scary for consumers. Because if you look at applications like Robinhood or eToro, for example, it makes it so trading isn't scary. These opaque boxes, but it makes it so it's less scary. I feel like the easier crypto can get to use and the easier the more specifications we can kind of have fleshed out and make sure that everybody's using the same specification will really help it make it so we're able to have these crazy apps, able to do this crazy stuff at scale, because the modern finance industry is just getting a hold of some of this stuff. Like, Robinhood just came out a few years ago. So we're still early, but I do think that building out better standards will allow us to have a better future for crypto and a better future for how money moves globally in general.
Thank you. Well, I hope you all enjoy this panel about interoperability, and I hope you're hopeful about the future as well. That, this will be maybe one of the last interoperability panels we have to do.
Hopefully.
No way. All right, thanks, guys.
Thank you.
Thanks.
All right, good afternoon, everyone. My name is Ismael. I'm the founder of Lagrange Labs. So for those of you who don't know, Lagrange is an early stage company that builds infrastructure improving systems that make it efficient to verify the results of data parallel computation, things like SQL, MapReduce, Spark, and RDD, over on-chain state. So to put this in concrete terms, think big data co-processing. So the topic of my talk today is emergent applications of zero-knowledge proofs for modular developers. So conceptually, we can think of verifiable computation as something that enables us to shift the safety of a computation away from a low-trust prover onto a high-trust verification environment. In the blockchain context, it allows us to shift this safety off of an off-chain actor who is executing some computation onto an on-chain network that can guarantee the verification based on the safety of the consensus. So in the blockchain context, we have traditionally seen zero-knowledge proofs being used to answer a simple question. How do we increase the abundance and privacy of block space? And the first generation of applications in the current state that we've seen tackling this question have mostly been ZK rollups and privacy protocols, private transactions, shielded pools, etc. But As most people here are likely aware, there's a new generation of emergent ZK applications that are surfacing, that are tackling a very different set of questions. And the question broadly that they tackle is, how do we increase the safety of data access on chain, and how do we increase the expressivity of computation in the execution environments? And we'll touch on both these points very shortly. But we can think of applications that sit in this domain as co-processing VM extensions, non-EVM ZK execution environments, ZK Interop, and more. So what do I mean by safety of data access in the execution environment? Well, when we think of dependencies for on-chain applications, traditionally, there are large off-chain dependencies for a lot of the most used applications on-chain. Think of price feeds for lending protocols. Think of K of N bridges or centralized bridges for the other DeFi protocols. And we think of the future state, we can remove the dependencies on potentially insecure off-chain actors and ensure that the data that the applications rely on have the same underlying safety as the consensus of the chain that the application runs on. And so this future state is what we can think of as the ZK oracles and the ZK Interop protocols, or things that allow you to introspect into the historical state of a chain and execute computation over it, in the case of what we do. And what do I mean by the expressivity of a transaction? Well, if we think of the status quo of what a transaction is on a blockchain today, it's traditionally one of two simple things: a simple exchange of value between two parties, or a simple state transition for some arbitrary DeFi or NFT protocol on chain. But when a transaction can in fact be a proof that's being submitted, that's verifying an off-chain computation, the design space expands substantially. You can start thinking of asynchronous computations that can be executed and then verified back in the execution environment. You can think of verifiable inference from ML models or from statistical analysis that's too large to fit on chain. And you can start thinking about, in the case of what we do, very large, expressive, big data style computations over single chain and multi-chain states. So this gets into what Lagrange builds. The core of our product is what we call ZK MapReduce. It is a proving stack that's optimized for verifiable big data scale computation over storage, receipt, and transaction states, both current and historical, across both single chains and multi-chains. And to make this very concrete in terminology that I think is in the lingua franca nowadays, think big data scale co-processing. So what do I mean by on-chain state, and why is this relevant to modular developers? Well, think of on-chain state as the current storage values of all contracts in a given chain in a given execution environment. And it's important to remember that with a given block header, you have a commitment to an ordered sequence of chronology of a chain. All the blocks from the chain to that point can be proven with the most recent block header, all the transactions in those blocks, all the receipts from the execution, as well as all of the state encoded in the chain. And what this enables you to do is to have computation that's verifiable with respect to that block header. And now let's put this in the modular context. Well, when we think of modular rollups, specifically application-specific rollups, it's all fragmented, it's disparate. You have separate execution states, and you have separate storage structures across all of these different modular rollups that can only be accessed by the movement of a commitment to chronology, a block header, between them. This is where cross-rollup state access is so important, and I think there's been plenty of talks today on that. And this is traditionally done by messaging and bridging protocols through moving block headers. And what this creates is a veritable data lake, a fragmented morass of on-chain state that continually updates at regular intervals, asynchronously, that in the current state is very hard to compute, query, or search over at a meaningful scale. And what I mean by that is, if you are on a modular rollup and you want to compute over 3 other modular rollups historical state to determine the average price of some asset pair on some exchange, you cannot do that right now without creating substantial dependencies on off-chain actors. This is where our proving systems are designed to come in. We allow you, as the same way you'd compute over your databases or your data lakes in Web 2, to compute over on-chain state verifiably in zero knowledge at a high depth of historical data and a high breadth of contracts and chains within each computation. And so to put this in concrete terms, what does it require to generate a proof? Well, you need a block header from 1 or more chains. You need a range of block numbers and storage slots. And you need a computation that's parallelizable. Think SQL, MapReduce, RDD, something you distribute in Web 2. And what you can do is you can verify this back in the execution environment after this computation has been conducted, such that you can rely on it with the same security as the consensus of the chain in question or wherever the rollup has its security derived from. And what this creates is a new primitive we like to call transport layer agnostic proofs. These proofs can be used in both the single chain context with a precompile to access the block header of the current chain you're on, or in the multi-chain context by using any of the many protocols that message or bridge or move commitments of data between chains. So if you move a commitment with Hyperlane, for example, between, let's say, modular rollup 1 and modular rollup 2, you can then verify a proof with respect to that commitment and its security is inherited from the execution environment and the cross-chain protocol that moved that block header. So it becomes unopinionated on where you derive your security from. You can design your application as you see fit, with the trust assumptions you see fit, and inherit robust computation from that assumption set. And how is all of this possible? What is it that Lagrange does that pushes the state of the art? Well, in August, our team presented a new paper at SBC, Stanford Blockchain Conference, called REC proofs. What are REC proofs? Well, REC proofs are a novel vector commitment that allows us to concurrently prove both batched set inclusion and dynamic MapReduce style computation over the data. And to describe one of the properties of REC proofs that makes it special, it's important to understand updatability. Zero-knowledge proofs today are not updatable. Imagine I wanted to compute a moving average of price over a range of K blocks. Volatility of price over a range of K blocks, where I want to derive the price per block, and I want to take the standard deviation, and then I want that over some interval K. Great, I'm going to compute one giant proof that does that with some proving time. Well, it's a blockchain, so the data changes. And a new block comes in, let's say every 12 seconds on Ethereum, or in a modular rollup, even faster. I would have to recompute this whole thing from scratch, because my ring buffer, the data I'm computing over, has now changed. So the computation I must expend is linear with respect to the amount of data I'm computing over. That's not a very effective paradigm when we're talking about structures that update every few seconds. This is where REC proofs breaks this paradigm by being updatable, the first zero-knowledge proof system in proof construction that is updatable. Whenever a new block is added, we can take a previously computed proof and we can update it in logarithmic time with respect to the amount of data that is being computed over. Which means you only have to expend computation proportional to the change, not the amount of data that's been initially computed over. This makes proving time substantially faster on applications that compute over very large sets of data. And this leverages intrinsic properties of blockchains themselves. They are append-only data structures, and state is low entropy. The majority of the blockchain state does not change from block B to B plus 1. So the updatability means that your proof is as performant as it can be with respect to the chain in question. And so, in essence, we can minimize proving time through recomposition of proofs, not recomputation. And this makes the overhead of supporting new chains incredibly low, which makes these even more applicable in the modular context when we're talking about thousands of different rollups. And so, in terms of where our performance sits compared to the state of the art, on our early benchmarks, we were 135 times faster than recomputation, but I expect the production version that we're going to be releasing later this year, or later next year, to be in the order of thousands. Rec proofs are fully parallelizable, meaning we can unlock efficiency improvements up to 10x by going embarrassingly parallel on them, and the verification time is way lower than anything else. And so let's talk about some applications of this, because I really kind of want to move away from these more esoteric conversations about proving systems into what this enables for the actual developer building modular applications. And so digest transformations are a very underappreciated use case of this that I think is going to become increasingly top of mind for developers over the next few years as zero-knowledge proof systems take off. When we think about zero-knowledge proving infrastructure, it's important to also realize that this will become modular, just as blockchains have. Different proving systems are optimized for proving different things. It's not homogeneous. As such, there are certain data structures that are not performant to compute over in certain proving systems. For example, the Ethereum blockchain, structured with Keccak hash functions and RLP encodings, is not very performant in most snarks, which pushes high dependencies on proving time onto downstream applications. And you can think about this as an extensible concept to data root equivalents for DA layers. In the situation where you want to have a ZK rollup that computes over some subset of transaction data in a DA layer, that ZK rollup in many contexts does not want to compute over the state structure or the stored structures used by that DA layer. It wants to compute over a hash function in the serialization mechanism that is very performant for that proving system. And as such, with rec proofs, we can take a data structure that is built in a specific way for consensus, and we can prove dynamically and iteratively that it is equivalent to a new structure that's performant for the next snark, the next zero-knowledge system that wants to compute on this. And so you can think about the pipeline of ZK rollups, coprocessors, ephemeral rollups, booster rollups, wanting to compute over data, and you can think almost as an ETL job to transform the structure that's unfriendly to that rollup into something that it is performant for it to compute over. Now, a more fun application and more financially viable is verifiable reward issuance. Think of CSR, DEX fee rebates, DAO rewards. All of these situations, you want to synthesize a computation over some amount of on-chain data, and then you want to verify it back in the execution environment to trigger a financial payout. In this context, what you need is a very large computation over a lot of data, something you could easily do in a data lake. Now it's provable. Now you can take this computation and you can use it back on chain. You don't have to trust us. You don't have to trust whoever's computing this computation for you. All you have to trust is the proof, and you can issue your rewards based on it. Next is a new primitive that our team has pushed forward called updatable BLS aggregations. If you think about how BLS keys are aggregated today, the aggregation time is typically linear with respect to the number of keys you want to aggregate. That is not very performant when you have to continually update and change the aggregation of signer set whenever that signer, a new subset of those signers have signed some message or some state. With our constructions, we allow that BLS aggregation to update such that you can prove both inclusion and the pairing operations within a single proof that does not require recomputation. Next is something I like to call full storage queries. As we push the boundaries of what we're storing in on-chain state, think of an NFT contract that has metadata associated with it. Or think of a ERC20 contract that stores the balances of a group of users. In these situations, what you want to do is search over that data such that you can verify the result of that query, like it was a database, back on-chain. So you might say, show me all penguins or all people who own a penguin with the following properties, because you want to issue a reward or have some on-chain action that is predicated on some ownership of something. Right now, if you did this in the execution environment, you'd have to go into your mapping and iterate through every single NFT or every single ERC20 owner, and that's just not going to fit in the gas limit. Now, you can treat your contract that's already on-chain as if its storage was a database that your application can query asynchronously to the chain. And finally, one of the things I really enjoy is exotic DeFi primitives. Think volatility, think options protocols, think DEXs that have dynamic pricing based on multi-chain states. In these contexts, what you can now do is structure your proofs such that they can rely on the data that's already existing in this data lake of on-chain state and verify that in the execution environment without requiring you to rely on an off-chain feed, thus substantially reducing the risk profile of your application and improving your security posture holistically. So if you guys want to learn more about the technical underpinnings of what makes this possible, there's two resources I want to point folks to. The first is our Rec Proofs paper. We presented this at Stanford Blockchain Conference this summer. And secondly is a recent construction our team put out, combining Rec Proofs and folding by Nicola on our team. And this is a phenomenal resource for those who are interested to kind of better understand how this works with both recursion and folding. So thank you, everybody. And I hope this was enjoyable and hope you learned something.
Can you guys hear me okay? Cool. Awesome. All right. Well, thanks everybody for coming. Hope you had a nice lunch. Yeah, so today we're going to chat about security. It's not necessarily the most sexy topic out there, but the next time Samsung tweets, you'll be happy you were on this panel. Awesome. So today we're joined by three people who have three different definitions of what security means to them. So maybe we'll just start with some quick intros and what you're working on. And maybe like what your definition of security is. So we'll do a fun question. And then we'll jump into some questions about modular security. So maybe we'll start with Juno.
Hello guys, I'm from Chainlight. And Chainlight is blockchain security company specializing in smart contracts audit and some kind of on-chain risk monitoring. And our clients are from the major exchanges in South Korea, and some of them are Blur, the NFT marketplace, and ZK Sync. So yeah, I'm happy to talk about the security. So for me, the security is the minimum baseline of the product that they have to do when they want to launch their product. So yeah, that might be the security.
Yeah, I'm Rushi, co-founder Movement Labs, bringing the Move VM to the Modular stack, announcing we're deploying on Celestia, also integrated with Hyperlane, so love the modular folks here. To me, security is not getting hacked for $4 billion every year. Smart contract hacks is probably the most notorious thing hindering our industry, and partly is that the EVM is broken, Solidity is broken. It was great for the first few years, but now it's time to move on. I think a lot of different groups have realized that. We saw Solana VM, the Fuel VM, and now we're bringing the $1 billion protocol that Facebook looked into to the modular stack.
Awesome. Hi, everyone. I'm Kaido. I'm the protocol researcher at Eigenlayer. Eigenlayer abstracts providing economic security to protocols, and you might be familiar with the term restaking. And security to me is more on the economic side, which is around consensus, Sybil resistant, all these different aspects.
Okay, awesome. And I'm Jacob. I'm from the ETH Gold team. I run partnerships there. Yeah, excited to be here. Cool. So, I mean, security, smart contract audit security, security in the base layer, consensus security. There's a lot of different securities. So I think for today, maybe the goal is to kind of talk a little bit more about the mechanisms that exist as we kind of think about more modular systems and how we can kind of secure those mechanisms and the underlying smart contracts that run on top of them. So maybe as a place to start, maybe just setting some framework. Maybe Kaido, if you want to start. Would love to understand just a little bit more about, especially rollups, whether sovereign rollups or kind of existing layer 2 rollups on Ethereum. Like, where do we kind of see them starting to touch the data availability layer, and like, how does that kind of like mechanism work right now? And then after that, we'll jump into kind of securing that mechanism.
Yeah, great. I won't pretend to know anything about layer 2s, especially from this crowd. But to start, I think data availability is probably a good part. So I think in probably a year or maybe 2 years ago, a lot of people are just posting DA to Ethereum, and the costs become a problem because the amount of transactions, transaction cost is linear to the total cost. So there's a big congestion problem, and people think about alt data availability solutions. And Celestia, I think, really jump-started the entire industry around data availability. So now we have alt DA, and now the question is, okay, compared to traditional, what some Ethereum people might call base DA, which is posting call data on Ethereum, what are the different security trade-offs, in terms of what's a new avenue of attack, from the security of the code perspective, what does the additional complexity look like? So there's a lot of different things added on top of the modular stack that security become really, really interesting. On top of DA, I think there's a few other things that also come about in modular stack, sequencer decentralization, watchtower, all these different additional parts, even prover market, all these additional parts have their own security properties, and how does all these individual systems, all come together at the end and help the modular system to be secure. That's a very interesting discussion. Yeah.
Awesome. Okay. Well, let's jump into it. So, whether you're using an alt DA or base DA, if you're a rollup, you have all this call data. You need to post it somewhere. So we made a decision whether that's Ethereum or Celestia or some other option out there. Why do we even have to do anything with that data? Like, why are we even putting that somewhere? And what's the first step towards making sure that what does that have to do with security, basically?
Yeah. So the premise of why DA is a thing is, I think everyone here knows, but just quickly recap is you need data availability guarantee, so to prevent some centralized party withholding the data so that you cannot construct the layer 2 block on base layer 1. So that's a quick summary on why DA solution is needed. So the base layer is basically, hey, let's make all the data available on Ethereum, so you inherit all the security property of the DA, the base settlement layer of Ethereum. The alt DAs are basically instead of doing it all on Ethereum, let's do some alternative routes. Whether it's Celestia, you're trusting the Celestia trust assumption, which is there's a certain amount of light nodes are always sampling, plus the underlying trust assumption for the Celestia consensus. For EigenDA, that's some other trust assumption you're placing, and each of these different trust assumptions have different some economic value behind them. Give the sort of assumptions or statement you can make is, if X amount of dollar is now trying to be malicious, then these underlying assumptions I provide to the DA solutions will hold. So that's sort of how these things tie into each other.
Got it. You talked about.
I have a question for Kaido.
Please.
We've all heard about dank sharding, and everyone's like, okay, why is DA even needed if Ethereum itself and the foundation itself is going to be pursuing cheaper methods? I know the answer, but I'd love to chat, hear your thoughts. But how does these different DA layers play into Ethereum's roadmap for eventually providing cheaper DA solutions?
So first, I'm not a DA guy. I'm an Eigenlayer guy.
Never mind.
But I think it's sort of like how you get there, right? Dank sharding, especially given effective EBO, these different discussions on the load balance. The load level for the individual nodes when Ethereum has so many validator accounts, and how do you do signature about aggregation of these different things. So I think there's going to be some time before we can hit there. Yeah. But the problem is demand is here, right? The users are here, they want it now. Do we just tell them to come back 2 years later, so we have dank sharding ready? Right? Probably no. So it's in between this process, how do we implement the process, or improving the process to keep up with user demand? Yeah, that's the way at least I think about it. Yeah. Once again, DA is one very small part of my job. Eigenlayer is a very broad scheme of things, trying to enable different modular stack as well. Yeah.
Yeah, jumping into some of the broader security work that's happening in the space. We're talking about data gets put on some DA somewhere. And then there's some sampling is one opportunity for us to kind of check with the light nodes to see if that data is actually there and not being withheld. But who's actually checking for the correctness of that data or the execution? You mentioned watchtowers. Can you maybe introduce the concept of watchtowers and sort of how that kind of comes into play?
Yeah, of course. Also, feel free to jump in. I don't want to.
Yeah. Chill, Eigenlayer. Chill.
Yeah, chill, Eigenlayer. That's my job KPI actually. So for Watchtower, so there's a lot of different aspects, right? We talk about DA, you need to post data to make sure something is available. For a lot of optimistic rollup, there's another key component in the stack that a lot of people don't talk about is the Watchtower. So the role of the Watchtower is to observe the layer 2 blockchains and detect whenever there's a fraud happening. Whenever there's a fraud happening, it can submit a challenge on layer 1 and kickstart the entire fraud-proof window. So this entire process right now is done by centralized entities where we don't even know, right? Most people don't even know who's doing the Watchtower for these major optimistic rollups. So it will be better in the future that we have some sort of network of decentralized nodes, permissionless, that anyone can join and coordinate and watch these layer 2 blockchains so they can detect when fraud's happening. So that's like another layer of where could be a potential role, and how EigenLayer supports that is instead of launching your own token, bootstrapping your own network, raising a big VC round, you can tap into the existing economic security of ETH and focus on the actual tech and leave the the financial capital side aside.
Got it. Juno, could I bring you in on just sort of observability of these networks as well? I know you've been working on this too.
The Arbitrum one?
Well, not the Arbitrum one, but I mean, we can talk about that in a minute, but more like Dart and kind of the work that you guys are doing there too.
Okay, so basically, every the decentralized protocol and centralized protocol also are monitored by some other third parties like the Watchtower and some kind of that. So we are trying to monitor the state variable changes and some kind of the address changes, and some kind of the fraud proof is even correct. So yeah, we are trying to do that with our product Dart. So yeah, I'll just mention about the Arbitrum case. So I had
Sorry, DAR. What does DAR stand for? Is that
the digital asset risk tracker?
Okay.
Since our the first customer is the crypto exchange, so this is why I just named with digital asset. But yeah, we should change the name to the the general Web3. I don't know. So yeah, I had an Arbitrum case, since the Arbitrum is an optimistic rollup, so they need some kind of the validators. And as you know, that the Arbitrum is not the permissionless protocol, so all the validators are all by the what is the name? The Arbitrum governance. So yeah, and the validators should have the ability to send a transaction that if there is an invalid assertion, then they need to send a transaction with some kind of challenge, and some kind of taking some value to the challenge, the period. But with our the system, the monitoring system detects that the over half of validators does not have even the zero, even just point Ethereum to send a transaction. So I think we submit to the Arbitrum Foundation, but yeah, it didn't receive anything. But according to the Arbitrum docs, that they mentioned that some of the validator types does not need to have a single amount of Ethereum. But yeah, the users don't know that even if they have the enough balance, when there is the invalid assertions are happen. So I think we need to care about these kind of risks.
Yeah, I got it. So yeah, just to summarize that, on Arbitrum right now, the validators, there's not enough of them that have actually Ethereum to submit the challenge if necessary.
Yeah, even the transaction.
Wow, yeah. Okay, cool. Maybe open question, it feels like we have a lot of chains all of a sudden, but with the modular blockchain future, we're thinking about millions of chains, chains for all use cases. If we can't get this right now with the validator sets for, call it a couple dozen chains, how do we set this up for millions of chains in the future?
I think the EigenLayer is doing well on this part to
EigenLayer.
Yeah.
I swear I didn't pay these.
Yeah, since I just
OTC's going up.
I just read some kind of the EigenLayer white paper during the flight, and yeah, it was great. So if you guys have some time, just read 19 papers. So yeah,
Sriram's smiling somewhere.
Yeah. Maybe we can jump into another aspect of these roll-ups, is the sequencing layer. So of course we were just talking about the data, but now somebody also chooses which transactions are part of which blocks and make sure that that data gets posted and all that stuff. I mean, what's maybe the current setup on the security for sequencers right now? Do we feel like that's going great? How do we feel about that?
Yeah, it's awful.
Everyone should trust every sequencer. Right?
Yeah, I mean, like base went down. I mean, it was nearly a few million lost. Like Arbitrum goes down a lot. So like, if you're ever going to believe, like when this peak spikes come up, that like this one node that we should put all our trust in this one node, you don't know what you're talking about. But also, it's like you need to have financial incentive, right? This shared sequencers are great, but you need to give Arbitrum a financial incentive or non-financial incentive to use these shared sequencers. When like Base's all revenue stream comes from a sequencer, they're not going to use one of these decentralized sequencers unless you force them to. So I think what's really interesting, and there's a few other groups that are using current consensus mechanisms to turn into sequencing. If you look at the CELO proposal, what they propose is turning their existing validator set into a shared sequencer. Why that's really interesting to me is because A, it's value accrual, because now you have to stake the CELO token to power the Ethereum rollup, and B, CELO is actually incentivized to a decentralized sequencer because now they can actually make money from decentralized sequencer. While compared to like Base and Arbitrum, it's going to be very difficult for them to convince them to be like, hey, you should decentralize your only point of revenue, right? So I think the current state of centralized sequencers is ruining the industry, but we're heading in a good direction with a lot of other options. But I'd like to hear your guys' thoughts on that as well.
I think the centralized sequencer is the only the business model of the layer 2.
Yeah.
Then they just took the money to like as a fee that sequencer should upload the bunch of data to the layer 1 or DA layer. So it might be hard to they change the like the sequencer layer to the shared sequencer.
I mean, as let's say dank sharding comes down the pipeline sometime next year, or cheaper DA solutions for storing as well, like the fees on layer 2s will go down as a result of this, right? And like the amount of money that these networks are making operating these networks will also go down as a result. Like, what can we, like, it seems like right now there's the best financial incentive to sort of be a really great validator or very good like supporter of the network. Like as things get cheaper or the money on the table is lower, like what kind of economic systems do we have to like secure these chains that are both more decentralized and offer the same kind of economic guarantees that we expect?
I think on the sequencer side, like
sorry, just before we touch that, I want to defend the layer 2s. Even though we say it's centralized sequencers, they have really amazing distributed system, you know, things to try to load balance, all these different things. You can like, pseudo consider them as like a centralized distributed node of sort. Yeah. So and they work really hard, you know, trying to keep this liveness problem that I think it's pretty difficult to maintain. So I'll just like jump in, try to defend them on that front. But I agree in the future, not just from like liveness from a technical perspective, also liveness from like a jurisdictional, regulatory perspective, where you have a truly decentralized set of nodes, and that will be really, really powerful. But I think these, like especially the Arbitrum team, I read their sequencer designs really, really cool. Even though like we just slapped like a centralized sequencer role on it, but yeah, also shout out to the Arbitrum team for working really cool sequencer designs. Yeah.
They are only team that in the stage 1 or stage 2.
Yeah. Yeah, but that is true on the security portion. I'm talking about just like how their Kubernetes work.
Yeah, do you have any thoughts on like how that model adapts over time as it becomes more decentralized and as maybe the revenues go down as well as these chains get cheaper to operate?
Yeah, I think it's acceptable for these fees to be really high. It's because if Ethereum is about $8, you can charge like $10 and the user probably doesn't care because you're not like targeting the market, right? But in this world where DA becomes really cheap and there's like other costs, like eventually the rolls become cheaper. Let's say, for example, it's now $1 to the transactions and now your sequencer makes what, 10%? So now Arbitrum's profit per transaction goes from like $5 to like 10 cents. So now that sequencer is no longer profitable. So in the long term, the sequencer actually does not make sense because if you're taking a percentage of a transaction, that's cool for now when transaction fees are really high. But if the whole DA thesis plays out and all these rollups start using different DA layers, then the cost of transactions should be very much minimal, which means profits from Arbitrum and Base go down. So now the question is, how is Coinbase going to justify that, hey, this rollup is actually worth? They're probably not going to launch a token because Gensler's not going to like that. And second thing is the sequencer probably not going to make sense. So that's when you probably need to decentralize the sequencer.
Cool. Awesome. We talked a lot about rollups. That's not the only thing that's going on in the space. So maybe kind of jumping out of just thinking about rollups, but more just thinking about broad future of modular blockchains. Concept of modularity. You get these different pieces that you can combine in unique ways and get a blockchain that you need for whatever goal that you have. That creates a much wider permutation of what can be done in the blockchain space. So maybe, Juno, curious about how do you think smart contract security is going to change in a crazy paradigm where there's tens of thousands, hundreds of thousands, different permutations of blockchains?
Okay, so from my perspective, I think the smart contract security will not change much more than the just monolithic blockchain. But the biggest issue is the security issue on what the modular blockchain apps uses each module. So I'll give you some just examples. So if just the app can choose the 5 module from the rollup layer and DA layer and other consistency layer, and what if they can choose like 2 or 3 module developers from it, then their complex is like the 5 power up to like 2, so it can be like more than hundreds cases. But I think that every security researchers don't have much time to review the whole combinations. So maybe it can be very, very hard challenges like in a general audit or yeah.
Got it. I mean, it'd be good for business, I imagine.
Yeah, maybe good for business, but we don't have much capacity to do that. So yeah, we are trying to do in an automated way. So finding the risk metrics in an automated way in some the combination of modules, then that maybe help. Yeah.
Got it. I mean, we spent some time poking fun at the state of rollups and layer 2s. Poke fun at something else that we all love. How about solidity? I mean, one of the cool things with modular blockchains is we could swap out the execution layer. We can do whatever we want. Maybe Rushi, could you talk a little bit more about, now that we have that flexibility, the stuff that maybe you're doing at Movement around taking advantage of that.
Go
ahead.
Can I ask something?
Yeah.
I'm just curious that if anyone that uses the other execution layer rather than just EVM. So is there any team that uses the other?
We actually use we have the Move VM for our tech stack, right? And we saw clips with Solana VM on Ethereum. I think what's really interesting with the modular thesis is customizations for your use cases, right? So the Clips thesis was we want to bring speed to Ethereum. Solana has speed. Ethereum has security and settlement. How do we combine both worlds? And that's spawned the Clips thesis. I think for us, it's similar. We're saying speed is important, but also security is the biggest issue in today's smart contract security. Analogy I say, if Bank of America is ever going to use blockchains, they're not going to write Solidity because they're going to hack for $3 trillion, right? It just doesn't make sense to house consumer assets in smart contracts that are fundamentally broken. But that does not diminish network effects, right? All the big blue chip protocols like Aave, Curve, they're all written in Solidity. So the question now is how can you scale Solidity and specifically Ethereum? Ethereum is probably going to be a settlement layer for a short to mid-term future. You'll have other DA layers to make the costs go down lower. So the last piece of the puzzle is execution smart contracts. How can you prevent Curve from deploying on these rollups and not getting hacked the next day for billions of dollars? And also consumer apps, right? If you're a college dropout coder and you want to deploy something in mainnet, you probably don't want to pay $100,000 in auditing fees and go to the whole process of getting audited and making sure there's not one bug that can destroy your own protocol. So I think that's when the thesis of alt VMs and Rust-based VMs really gets exciting because now you can bring the Move VM, bring it to Ethereum settlement, bring it to a DA layer where it's relatively low gas fees. And what we did is made it fully EVM compatible. So now you have Curve, Uniswap, Aave, all deploys on SDK. It'll transpile down to Move bytecode. You have all the provers embedding formal verification on top of Ethereum settlement, on top of DA. So now what you built is a bulletproof rollup that A, you can launch for your own use case, and B, our mainnet solution. So now you'll have Curve coming to a modular thesis and not getting hacked for billions every year.
on this tooling around formal verification, I mean, formal verification's been around for forever.
Yep.
Move is a programming language built by Facebook, I think, like many years ago as well. Like, we've had these tools for a long time. What has been, in your opinion, what's been slowing us down from using these tools in the ecosystem to prevent these hacks every year?
Yeah, I think it's just been locked up. Like Rust-based VMs have been around for years, but the issue is, okay, if you force developers to leave their ecosystem, go a new chain, you have new wallets, you have new ecosystem, you have low liquidity, it's a very difficult process. Plus, you have the whole like VC chain, like derogatory narrative that comes up. So I think it's been really difficult to see adoption in the recent years. I mean, Solana's kicking up now, but like for Aptos and Sui specifically, which stem from the DM project, it's very difficult for them to attract users. A, because they came through a Web 2 native way. They're a bunch of Silicon Valley people who had to build the ecosystem properly. And B, they weren't able to tap into where liquidity is. Liquidity and ecosystem and community is all in the Ethereum mindshare as of right now. Specifically, now the modular narrative is kicking up, right? So now what we're thinking is, okay, this Move VM is pretty cool. We will have formal verification built into the VM itself. So if you're a developer, you don't even need to know how to embed these methods. You just deploy contracts, and it checks for resource type and memory safety built in. And now you can just leverage your Ethereum settlement and use whatever DA you want. So now I think now in the next few years, A, the DM chains are doing better these days, but B, we're able to actually come to the Ethereum and bring it to the users without them even realizing.
I love formal verification, and I'm not know more about the Move languages.
Yep.
So, but as far as I know, that the Certora is one of the company who does the formal verification and the Solidity code. So, what do you think that the biggest differences between the Certora's approach and the Move Lang's approach?
Well, any auditing firm or security firm does formal verification when they check contracts, right? You pay them $100K a year to do that. They check.
Yeah, making some kind of models.
Yeah, auditing firms are probably the only companies in crypto right now that make money. But in terms of the VM itself, when you're able to embed provers into virtual machine, that's the first time it's been done. So for a little context of the VM, the Move VM has these bytecode interpreters and bytecode verifiers. So when you execute a smart contract, it checks for, hey, does this code have any reentry bugs? Does it have integer overflows? Is there like flash zone possibilities that aren't checked for? It is basically a checkbox to make sure everything's intact and then executes. So for example, in Solidity, if you have a 257 integer overflow, it doesn't check for that, and it can just be manipulated. That's what we saw in the curve attack, that's what we saw in the DAO attack. With Move, that's not possible, because when you execute a smart contract, it says, hey, is this contract okay? Is everything verified? Is everything good? And then it executes it. So if you're an average developer and you don't have 20 years in Solidity experience, getting paid $500K by consensus, you can probably deploy secure code to mainnet and not have to worry about getting wrecked.
Oh, good.
Yeah, I think it's the difference between running the formal verification after the fact and understanding how your contracts apply versus it's like a pre-commit hook every time.
It's like runtime verification where you can make sure your code isn't bad.
Very cool.
Move is very cool. Yeah.
Move is very cool.
Coming to Eigendia too.
Yeah. I was going to make a joke about where'd you get the name from for your company, but
it's literally in the name.
Yeah.
yeah. I thought it was the same thing until I Googled it. But yeah, very cool. Awesome. Okay, we've covered a lot of ground. We've talked about some mechanism stuff, sequencers, DA availability. We've talked about smart contract auditing. Let's see, what else did we talk about? Shared security. I don't know. What do you think is missing from the conversation right now on security? I do have more questions, actually, but I'm just trying to see if they have any things they want to chat about. I think shared security could be interesting, but go ahead.
Do you guys do any stuff with slashing in terms of security? I know that could be a possibility for Eigenlayer.
Yeah, we already have slashing. So the way I normally describe it, if you think about any proof of stake chain, it basically provides some kind of guarantee, right? It's like under one-third honest majority, less than one-third of the stake are malicious, then I can guarantee some sort of services to the external users, right? If that assumption is broken, then I can no longer do this. The other thing you have is, hey, if the malicious party commits something bad, then malicious party will be slashed. So basically, Eigenlayer abstracts this and basically put it on Ethereum. So anyone can build a proof of stake network on top of Ethereum using Eigenlayer. Using Eigenlayer just means using the smart contract. We do have slashing ready, or you can. We do not have currently slashing live yet, but we do have the concept of slashing very much there. And you can basically program any kind of slashing condition on Ethereum and taking any arbitrary proof and slash the malicious actors on Ethereum.
Yeah, maybe just to like dive into this paradigm specifically, as we get more networks, blockchains doing weirder and weirder things, like I think this idea of having a set of validators that are already tasked with doing something else, basically just available compute and or resources sitting around that could be, restaked in the case of EigenLayer, it's the word that they've used, to like define like applying that group of people to another thing. Like one of the popular comments that people have made is, how does that affect the underlying security of like many of the system if many chains are using that set of validators? So, whether that's for EigenDA or another 50, 60, 100 networks being secured by the same underlying set of validators, in that case, the Ethereum validator set.
Yeah.
How does that impact the security overall, and what are some of the considerations there?
Yeah, so this goes into the fragmentation of security versus pool security or shared security paradigm. So if you imagine there's a million different rollups, each one of them having their own infrastructure in terms of decentralized sequencer, decentralized watcher network, et cetera, then that world is very fragmented in terms of to compromise any individual rollup, it would be pretty easy. Versus another world where let's say they use a shared set of operators or validators who are validating these individual services, but they share the security budget, meaning the economic robustity of any sort of add-on services for these layer 2s are going to be a lot more higher. You can think of it as individual one, for these a million chains one, then the shared one is going to be a million. So in the previous world, to compromise any individual rollup would be, it just costs $1. In the new world, to compromise any individual rollup, it would cost, $1 million. Something along that line. There's a lot more caveats here, but I think that's a general mental model that I think is going to be pretty important when we think about, in the future world where there could be multiple rollups and how we think about the security among them.
Okay, awesome. We've used almost every buzzword in this talk, so we're going to go for one more.
ZK.
Yeah, there it is. So, if as proofs get cheaper to compute, as hardware gets better at running circuits, like how do we think that is going to play into some of the security, either at the base layer or observability in these networks? Like, how do we feel that ZK and hardware improvements are going to affect the security network of these networks?
I think ZK is a great add-on for now. The sort of belief I always have is whenever you have a technology, you just need to wait for the Eastern European 16-year-old kid to have 2 years to catch up, and then we're sort of like screwed. So I think it's a combination both where you want to have very future-looking ZK system, at the same time you have ways to protect the users now. I think ZK Sync has a great way of doing it where they have their ZK VM and submit the proof on chain, while there's also at the same time a 1-day delay on the withdrawal, just in case something could happen. So I think these kind of approaches are going to be really powerful in the short run, probably in the next 2 to 5 years, as we because our cryptographers in the space work really hard and they keep up like new proving systems all the time. So as we iterate through them, and we're gonna before the proving system and the ZK part become more ossified, we can have a safety feature. I think the safety feature is where all these decentralized systems come in. That's really powerful.
I think most ZK teams are cool until you ask them the proving costs, and they're like, I think when we look to work with different infrastructure partners, that's the unknown that's left behind. It's like, sure, you can integrate a ZK bridge, a ZK rollup, whatever, but if it costs you a lot of money to submit the proofs, you're basically rendering your consumers useless, because it just makes it unviable to use a ZK rollup in today's kind of economy. I think Polygon CDK is very interesting because they're able to distribute the one proving cost across the multiple different rollups they have. So in theory, the tens of $1,000s proving cost they have for the type 1 prover can be split amongst the 100 to 1,000 rollups that they're already establishing. So it becomes next to nothing proving costs. But a lot of these like ZK bridges and these ZK rollups have extremely high proving costs. So when you put them on mainnet in an actual production environment, it's very difficult and painful for users. So I think that's something to keep in mind.
One of our team members just found a circuit bug in the ZK sync. So I think the ZK in a mathematical way is very cool and fun, but using it by cryptographers are very hard to maintain the code quality, since usually the cryptographer does not code some kind of the programs. So they can make some little bugs on their circuit, but it can make hundreds of millions of dollars of fund loss. So I think that they should more care about making the like inherent safe language which can make the circuit and yeah, some kind of the ZK program.
One of my ZK friends told me a joke. Is something goes like, it would be more impressive to write bug-free code than make ZK into everything. Yeah.
Yeah. The another thing is the every cryptography technology that we are using in these like 2020 years, then it is verified for like 10 to 15 years by NSA and some kind of the NIST in US. But zero knowledge proof, I think it's very, very new and cutting edge technology. So I'm just worried about why we are relied on this cutting edge technology, which is not proven for 10 years. So yeah, this is one of my worry part.
Awesome. Cool. I think we're out of time, so I kind of provide a quick summary on all this. I mean, like you said, I think I agree with Juno. Like, this is a cutting edge time, especially for security. When it comes to these networks, there are huge validator sets that are going to need to be implemented across many, many, many networks just to validate what's happening and all these different permutations of those networks. This data availability layer, somebody needs to watch the watchers and run like clients and have watchtowers, making sure all these things are correct. It is going to be a very interesting time. And of course, all it takes is one thing to go wrong for there to be another hack that sets us back. So be careful with your programming and keep up to date with the latest. And yeah, thanks again to our panelists for being involved.
Thank you.
Thank you.
Thank you.
Is it working? Okay. So thank you for coming for the infrastructure panel today. We have quite the panel here. Infrastructure, like big brains from really different areas. We have like ZK, we have Rollup as a service and relaying and developer tooling, and we are making them connected in an interesting way in few minutes. Quick intro about myself. I'm founder and CEO of Verblock. We are delivering programmable privacy using threshold cryptography like identity-based encryption and fully homomorphic encryption for private intents, private governance, Elbit actions for all of the ecosystems. And yeah, let's begin with quick intros and about yourself and projects.
Yeah, sure. Is this working? Hello? Is this working? Yeah? Okay, cool. Yeah. Hi guys, I'm Hilmar. I'm one of the co-founders of Gelato. Gelato is Web3's cloud platform. What we do is we provide a platform for projects to deploy and host their own rollups. These optimistic rollups, ZK rollups, whatever you like, and we do so in a way where you have a bunch of really important Web3 middleware services out of the box available, such as native account abstraction, smart contract automation, access to off-chain data. And yeah, we want to build the end-to-end cloud platform for developers to build their applications.
And I'm Galen. I'm one of the co-founders of Kurtosis. We are a developer tool, and we make it easy for developers to spin up dev nets, test nets, canary environments, really anything that involves running somebody else's nodes or relayers or that kind of thing. Will take away the DevOps burden just through the developer tool.
Cool. I'm Brandon. I'm the CTO now of O1 Labs. So what we do is, well, ultimately, like, we are catalyzing a new generation of Web3 applications using zero-knowledge cryptography. And we're doing that through the MENA protocol. So we're the team that incubated MENA. Through our proof system, Kimchi, and with our ZK tooling, O1JS.
Awesome. So as to just begin with a general question, so how do you envision the infrastructure landscape of blockchains when we have thousands of applications and hopefully billions of users? And in general, what would be the topology of the network, in terms of how many rollups, what kind of rollups, L1s, I know, bridges, and predict the future.
Yeah, maybe I can start. So I think what we believe in, and I think there's a difference between this sort of quantity and quality of a lot of this, and TVL and value and volumes, and just like the sheer mass of applications. But I think how it will look like is that you will have a lot of different application-specific L2s and rollups. I personally think that we will, like, a blockchain will just be sort of like a database that you as a project will select, and it's like one piece of the puzzle, but there are all these kind of modules on top that you need in order to actually build like a sophisticated application, be it like UX integrations with like social login, private key management, all these kind of things. And most projects will probably have their own blockchain, but they don't even know about it, right? It's just like they come to a platform like ours, they click a button, and then they can deploy their smart contract, but they don't even understand that this is actually their own L2 that they're deploying it to. They just know I have the security of Ethereum. Probably at some point, like data availability and everything is completely abstracted away from them. They don't even know where they post the data. They shouldn't even care where they post the data. They just know what the guarantees they get from the provider and what guarantees these services provide them, which might be trustlessness and so on, trust minimization. And then you have these middleware services. So I like to think of it as like the execution layers here. And then you have these middleware services on top. And these middleware services include like SDKs, bridges, oracles, on-ramp, off-ramps, all these kind of things. And there we'll probably, what we have seen is we have seen this explosion of infrastructure projects in the last bull markets that just get a lot of funding, right? And provide all these different services, kind of like trying to differentiate themselves. But there we will see conversion probably to like one or two for each of these verticals, and then most applications actually interface through them. And then how this whole like cluster of L2s play out, right? If someone actually, like if this one cluster, like the optimism cluster or like the Arbitrage cluster or the Polygon cluster will sort of succeed, I think they will just get abstracted away, and there will be one interoperability layer on top, similar to like the internet. You had these small like local internets, and then they all just got connected via TCP and so on, right? So I think that probably something similar will happen. And yeah, that's, I think, the topology.
Awesome. He already answered all of my questions.
It was very thorough. Yes, roughly agree. I think it's hard to predict exactly what's going to happen, but I think it's definitely going to get a lot more complicated. More chains, more bridges, more back-end services of different kinds that just all together compose what mainnet looks like to an end user, even if it's abstracted away, which I agree is going to happen. Under the hood, there's going to be tons and tons and tons of different services. And that's kind of what we've been looking at a lot, is how do you recreate that kind of an environment in a test scenario or in a development scenario, or if you're trying to run your own subset of what that looks like for your own end users. Things just get a lot more complicated when it comes to being able to spin up all those different kinds of services. So it's definitely gonna get more complicated.
Yeah, agree with everyone. I guess we're focused on the kind of like within the ZK layer. Like, what is ZK? I mean, ZK doesn't in and of itself provide value to users or developers. Like, it solves problems. There's several kinds of problems it solves. But I think one, and this, we're not, at O1 Labs, we're not only focused on this one, but I think one interesting one is privacy. And that's sort of, a lot of the stuff that we're building is in that space, and I think that space is, there's still a lot of interesting stuff going on. But, the most important thing is, like, of course, yeah, it's going to get more complex, it's going to get more crazy, but it's so important that users don't get exposed to any of that. And right now, they're already exposed to too much. Like, why? Like, who cares if I'm on? My dad or whatever. Like, he shouldn't need to care if he's on Ethereum or Base or whatever. Like, he just wants to use an application.
Exactly. But I think it's also a symptom of the sort of trust guarantees of these chains being so different right now that you need to expose it to them, because otherwise they end up on BNB or on other side chains which have arguably lower trust guarantees and potentially sometimes are like custodial, right? And then they just need to know about the risks that actually exist, and something can go wrong there, and it's not Ethereum that you're on. I think we come to a point where we can literally scale Ethereum's trustlessness via rollups. Then we can come to a place where it's like, okay, it's all the same, but right now it's just not there, right?
Okay, on that note, so there are people in other events today that are saying they're based on the rumors, they're saying that we already have too much infrastructure, we have more rollup as a service providers than actual rollups, we have more bridges than actual chains, we have, I don't know, more ZK and than actual ZK rollups that we want. So is that too much? Should we build more infrastructure, or like, I don't know, what's actually like blocking the application developers from like building the coolest applications ever?
Yeah, I guess I'll start. Yeah, I think we do, like, our space, what do we call it? The Web3 space in general. We have we're a bit heavy on the infrastructure side. Yeah, ultimately, I don't know. I guess I agree. I mean, I think where we don't have enough is, like, again, in the privacy space. There's a lot of tools that are coming out these days with ZK that you either have to be like you're either like a cryptographer and you're building a custom proof system, but then you can solve the problem that you want in the right way, or on the complete other side you have like a ZK VM, which then it's really hard to get access to the privacy features and a lot of really interesting things in proof systems. And so I think the space in the middle is really interesting, and there's not any production ready infrastructure. Like, we're trying hard to get ours production ready as soon as possible, and we're close. But yeah, it's this like good developer experience, expose the deep interesting parts of the proof system, but make it available to product developers, to application developers, the people whose expertise is building great products for users. And there's a lot of infrastructure there that we still need.
Any comments?
Yeah, I think, so who's to blame? I think the VCs are to blame about this phenomena, but I don't blame them, right? Because it's in this emergent industry, if you are betting on, like, a lot of VCs got burned by betting on apps, because these apps can rise and fall super quickly, and then just was the case that this application no one really wanted, and then you just burned $50 million that you invested and it's gone, right? Whereas infrastructure is kind of like a hedge. It's kind of like an index that you buy for the entire space. And so obviously the more uncertainty there is in an industry, the more investors converge on investing in infrastructure, and this is what happens. And now there's a lot of infrastructure, but I think it's a good thing, because now there is competition to really innovate. There's competition around pricing, and you need both of that to actually be the case for then application developers to come in and build on top. And like, infrastructure still sucks. It's not like infrastructure is solved. It's not like, hey, now come build. Have you tried building an app? It's not that easy, right? I also build apps, still building apps, even though I'm building an infrastructure project here, and it's freaking hard. And the UX is not there yet, the reliability and the cost is not there yet, so we need more money, actually, unfortunately, to be poured into infrastructure until we get to a point where just apps can click and everything works, right? Right now, we have to deal with what is there on Rollup, what is the data availability layer, what is this? This is not, for me, readiness in infrastructure. Readiness for infrastructure is, okay, this is the thing that scales trust and everything else, and I click it and I have it. And we are not there yet, and luckily we have a bunch of teams working on this. So I think it's just a mantra of maybe too little application ideas being there and not actually too many infrastructure.
So what's blocking developers to develop actual applications? And then, like,
is it a lack of ideas or a lack of tools that are easy to use? Because we see, like, in Web 2, like, there's so many ideas, people are doing it because it's easy. But as you said, it's not easy, and I don't know. There's, I guess, yeah, some of it is maybe like a lack of kind of knowing the things that you can get when you build in this space. We've seen a lot, like, people just can't believe that they can do these kinds of privacy things that you can do with ZK until you kind of show them, explain to them. So there's some education missing. education and then like really high quality.
But I think it's also the performance still, right? So if you want to build a new social media application, right, and you want to build it, I don't know, on an L2, like that still doesn't work. Like you need the scale of a Twitter to be able to compete. Like none of the technologies right now really enable you to do it. So like we think infrastructure is solved because it's like 5x better than it was 2 years ago, but 2 years ago it was horrific. Now it's less horrific, but it's still not there.
Bad.
It's still really bad. If you go to some Web2 developer and you tell them to build on an L2 right now and they have to post data to Ethereum and the transaction costs 20 cents, well, that's not something scalable, right? So like there's still so much improvement that has to happen. Like it has to be kind of on par with what we can do in Web2, but then the benefits of the Web3, what we can enable, and then then it is, okay, why would I even build on this like old system? Why wouldn't I leverage a new one? So
I think your answer was really interesting because at the end of the day, we really care about not having monopolies in like blockchain industry and just having one company who is like the monopoly of like cross-chain bridges, for example, makes them in a situation that they just build a like really expensive tool, really like import performant like tool. And right now what we have seen is that there is like 20 cross-chain bridges companies and none of them are good. Like some of them are so expensive, some of them are like not secure and they're lying. So having this kind of competition that they can point to each other and like point out that what is wrong is the best thing that we have because like we cannot expect like normal end users to understand what's the security assumption, where is it wrong. So we are, I think, as you said, like we are not still there, we are quite far, and this kind of competition will eventually happen somewhere. And then I think it's the time for educating users and developers and what you can actually do with these.
And it gets harder over time because, like, you know, every year there's another 100 products to choose from, and you need to learn about the pros and cons of each in order to, you know, pick your poison, I guess.
Do you think we will have like more infrastructures for some time, and then after some time it will go less because some of them will work out and have the whole market, and then developers can clearly focus on one of them, or is that?
Yeah, I think we are like right now still in this expansive mode, right? A lot of ideas, we are like this, but we have this sort of different flavor or this kind of small change, right? And which is great because now you placed all these bets as an industry on these different implementations, and then like it's kind of like evolution, right? So just like the one with the smallest little extra feature will win, and then probably get the customers. But there has been a lot of money being poured into the space, right? And we are right now seeing a conversion, so less projects actually, like some are capitulating, some are dying because they run out of funding and they were on the wrong track. And now it's kind of converging, but then as soon as like the markets go up again, I would assume personally that there will still be another big wave of infrastructure investment because infrastructure is still the safe bet. It's still the index that you buy as an investor to benefit from the rise. And so I think we will still have at least another cycle of infrastructure first.
It seems like applied research on steroids, like because in research you just combine two ideas and say that I've like solved the whole problem, and the other guy in other university says I've solved the problem, and then someone combines all of those ideas, and finally we have something. Maybe we are like still in the applied research era.
And you know, this is the benefit of modularity. We're in what? We're in modular day. Yeah. Yeah, like it's important to build systems that are modular, so that you can take ideas. So, for example, like our proof system Kimchi, we've designed it to be modular, but ultimately like it's Raison-Detra. I don't know how to speak French. Is it's close enough. Okay. Is like keep recursion efficient, and then just with that core, like do everything. So like any time there's new research, there's new papers, there's new things that people come up with, we take it, spin it, plug it in, because ultimately like rather than having, I mean I know this isn't like a ZK focused space, but if you don't know, there's like every few weeks there's like this new proof system, and like here it is, and here's its trade-offs, and here's the thing, and it's like static, and this is it, and that's just not where we can be, because yeah, then you get stuck. I don't know.
Okay, so yeah, as you said, since we are in a modular event, so what modularity, like, I don't know, what modularity makes for what you're building? What does it mean to you, and like, vice versa?
Yeah, I think modularity is extremely important. I think a lot of money, it's this buzzword these days, right? But why is it important? Is if you think about the last 10 years of like Ethereum and other sort of monolithic blockchains, we moved super slow when it comes to improvements. Why? Because everything was kind of like baked into each other, and you had to change core protocols to have like incremental changes, and it like once a year there was like a small update that we did, right? And it was so slow. And now what we are doing is we are splitting up the base layers into like each thing like components, and you can stack them together, you can switch them out, and now it's really up for developers to take them and sort of combine them in the way that makes sense for them, and then build their use case. And what we are, for example, doing at Gelato, is why we call ourselves like a Web3 cloud platform, is we are actually taking all these modular pieces, which are, okay, let's take the OP stack, let's combine it with Celestia, let's have a Hyperlane bridge in there, let's use the oracles from XYZ, let's use automation from us, right? And these SDKs, we're providing like an end-to-end package for developers, where they don't have to go out and read research for 10 different people. We just have for specific verticals, a really well thought through package that they can have with one provider they get, and it scales, it does its job, and it is, from our research, the best thing out there in the market, and we take away a lot of the work of like actually thinking through all of this. And so modularity for us is super important, because we can work together with the best projects in the space, with the best infrastructure providers. They come to our platform, we work together with them and provide the users with the actual solution that they're looking for. And so I think this will just accelerate innovation and improvement significantly.
I think it's actually really valuable, because like we cannot expect the developer to understand every piece of the technology that they should choose and all of the trade-offs. So if someone can suggest that for your application, the ChatGPT says that you should use that, it's really valuable. Okay, so what does it mean for Curtis?
Yeah, and we kind of work on a similar layer where we work below the layer of each of the components in a modular system. And one of the first things we did coming into the space was we worked with the Ethereum Foundation DevOps team during the merge. And that was a moment when the Ethereum architecture became very modular. Separate the execution layer and the consensus layer. You have a different structure for how MEV mitigation worked. And all of a sudden, those test nets went from one node to do a reasonable test net to 12 different services that had to be spun up, configured the right way. And then you had to be able to do all of your testing on that thing. And it got much more complicated to do that from a DevOps perspective. And that's kind of where a lot of our tools started getting a lot of usage. And as things get more modular, there's more and more systems that kind of look like that. Like, oh, I want to get some security guarantees, I want to get some reliability guarantees, or I just want to spin up a dev net where I can do some kind of prototyping on it. That stuff just gets tricky. And that's where we hope to help a lot with these modular architectures, is just to help developers get that stuff off the ground.
Yeah, I guess like continuing our discussion about like how it's like applied research, so you guys can help finding out all of the bugs and problems before going on production, and a couple of $1 million, right?
Yes, there was actually a talk in the TrustX event earlier from Trail of Bits, where they were sharing something called a TACnet, which used kurtosis in combination with Chaos Mesh on Kubernetes. And it was essentially this. It was essentially, let's just blast the whole system with all these different fault scenarios. And they were able to reproduce a finality bug that had happened on mainnet previously using kurtosis. And that's the kind of thing that we can enable
we
here.
definitely like need this kind of, even like in Celestia airdrop, you said like we clearly saw that how infrastructure failed the whole crypto ecosystem, because everyone was trying to like transfer their assets like to osmosis, and then nobody has tested that all of those arbitrage bots will literally like fail the whole like crypto narrative. It was like bad marketing for the whole industry, not just for Celestia. So like this kind of, I don't know, like preparation may help in the future. Okay, so how can we use like DA layer for Mina?
Yeah. So Mina, I mean, like I think it fits into this like modular picture in kind of like both sides. So as a consumer of modular platforms, as you mentioned, like Mina's applications are unique in that, well, I guess I should say. So Mina is one big recursive proof that stands in for the blockchain. And that proof on mainnet right now proves all the blocks that have ever happened and all the payments inside of them. And we're working on an upgrade that we're very close that adds smart contracts so that single proof will prove all computation that has ever happened. And so all of that computation, the application logic, it actually runs client side. And you need that. You need that for privacy. Anyone who's not doing that can't give you privacy. So, but the thing is, like, these applications and Mina itself, they're, the core of it is succinctness. It's about not having data that sort of enables decentralization and bridging and all these nice things. So yeah, like sometimes your applications, they need to use, to have a data availability layer. And it's interesting, like Celestia and these other DA solutions, right now they've been applying to like the L2 use case. Like L2s need a DA layer so that there's a way to have like safe exits and all of these things. But actually on Mina, the application layer needs a DA layer sometimes. So that's sort of a really interesting use case, and it's something we're really excited to be building. And then, on the other side, like Mina itself can be a module for this like greater landscape of whatever this collection of blockchain amalgamation thing we end up with, probably Ethereum at the bottom. If, for example, you're building some application and you need to have some kind of KYC, but rather than doing KYC, you have like a proof of KYC. So you can just like verify a ZK proof directly on whatever chain you're on, but if you what you miss when you do ZK proving kind of more directly is you miss the ability for composition. So you can't compose things together. So like if you use Mina as your layer where you do your attestations, anything private, you can sort of do these things once. You can mix them together, and then you can bridge over Mina, through the Mina bridge, through the Mina state bridge, you can kind of access these private attestations. Anyway, I'm kind of weaving my narrative into this.
I think this is like an actual really important problem that people like underestimate, because right now, specifically for privacy, we have all of these isolated islands of free happy words, like, I don't know, Secret Network, Penumbra, like all of the other privacy solutions. And Ethereum is like notoriously bad for anything that you want to do with like ZK or privacy. Like, it never happens. And so doing it like in a way, like in other chains, or doing it in a like modular way that you can actually meet the privacy needs of people where they are, and without needing them to install another ZK wallet or like going to another front end, or just like having it on the Ethereum side.
Yeah.
In the background, something happening is on Mina, but like it actually happens on Ethereum. Like,
right.
This
exactly.
is like the correct way.
This is kind of like what I think we're going to end up with. And we're trying to get there. So the user shouldn't care. So that means like we need the Kimchi Mina's proof system needs to be able to like work with Ethereum data natively, and we're working on that, and we're doing it in like a super efficient way using lookups and things. And it means that it means that all of that is hidden away from the user, because ultimately the user experience is what matters more than anything else.
Awesome. Okay, as last question, as a way to connect all of you guys together, so let's talk about ZK rollups in a way. So the problem is that like we've seen a lot of like hacks on ZK. So the protocols are working on papers, research papers, but when you implement them, there is obviously potential for bugs. And so maybe using developer toolings, we can like test them better, or like I don't know, using like what O1 Labs is doing for fraud proofs, we can combine the like 1 day of optimistic thing and then combine the additional layer of security for ZK. And what does it mean for you?
Yeah, so we actually have a couple of ZK VM rollups in production right now with customers. And yeah, I think how we are approaching these things to make it secure or basically flexible to react in cases something goes wrong, and the same can go wrong, of course, like in an optimistic rollup that doesn't have any fraud proofs implemented, right? It's kind of like the same thing. So how do you do that? You have like these sort of guardrails in place that you have upgradability and admin controls over bridges and these kind of things that you can at least sort of try to isolate and control damages, do a bug fix, update the system, update the smart contracts, and try to sort of have an iterative process to this. I think this is the right way of approaching this period where we're still trying to test things out and figure things out, because like the first ZK VMs have been launched, I think, beginning of the year with Polygon, right? So it has been not even a year since we have them live, and they have been far from like battle tested, I would say. But we are in the process of accelerating this. So yes, it's just about how you approach a DeFi protocol. It's the same thing. Yeah, you might not just want to launch in production completely immutable and get everyone to deposit $100 million. You say like, hey, be careful. Yeah. We have upgradability, we have guardrails, and then you sort of remove them over time.
Exactly. Any comments?
Yeah, I mean, we actually have some folks that are starting to work on doing some like Starknet style testing with kurtosis, and it's kind of what it looks like is the similar thing to what's happening with the Ethereum use case. It's it's a testnet in a box, so it just makes it a lot easier to do all the different kinds of tests that a security expert or somebody who's much more in touch with like ZK technology than I am to use it to do everything they need to do. So starting to see it, and it's gonna, from my perspective, from the perspective of our tooling, it's gonna look pretty similar to other roll-up style testing too. Just get it in a box, do it as many times as you want to in different configurations, get your test nets where you want them, the way you want them, just like that. So I'm excited for this. It's gonna look like it's some more usage and some more use cases on our tools. So it'll be cool. Awesome.
Yeah, and then I guess so on our side, one thing I haven't mentioned yet. I'll be concise, I promise. So at O1 Labs, we were experimenting with ZK VMs, like efficient ZK VMs of the of the sort of classical compute sort. When we for eventually like putting into Mina, and we came across an Optimism RFP for creating a ZK fraud proof for Optimism, and ultimately that demands a ZK MIPS VM. So we saw that and we're like, hey, like these things we figured out about our proving system, we think we can build this in a really efficient way. And so we were one of the winners of that RFP along with Risk Zero, and our solution sort of builds that ZK VM into Kimchi. And ultimately, like and I'm not speaking on Optimism's behalf, but from what I can see, what I can tell, and I think this is a great idea. They're thinking about moving towards this like more like ZK rollup world in steps, because first like we need fraud proofs, and then like, okay, well, if we make the fraud proofs ZK fraud proofs, that's like what we're working on, then it's sort of one step towards validity proofs. You get some nice efficiency benefits with respect to normal fraud proofs, and then sort of you can take steps carefully to get to this sort of ideal world where you're just in validity proofs, but in a really safe way.
Yeah, I think that's a really good way of putting this together, because it's not a fight again between optimistic rollups and fraud proofs and ZK rollups. It's actually like a transition to that word. And yeah, we shouldn't be defensive about what we are building. Okay, I think we are out of time. Yeah, thank you so much for our panelists and for the audience. Let's give it up.
Okay.
All good. All right. Thanks everyone for joining us today. My name is Verity Coltman. I work at Espresso Systems. We're building a decentralized sequencer for Rollups, and I'm the ecosystem lead. I have the pleasure of working with all of these projects, actually, so I think we're in good hands. We have some good panelists today. But before we jump in, I would love it if each of you could quickly introduce yourself and give an overview of what you're building.
Me? Okay.
Yeah, let's start with you.
My name is Amit Kumar. I'm the Chief Operation Officer at Hoai. We're building a Rollup as a service platform that makes it easier for people to deploy rollups. And our goal is to allow or make it possible for even a marketing person or BD person to be able to deploy a rollup. So it should be as simple as that. One really cool thing that we do is we offer this new kind of rollup that we call flash layers. It's a rollup that you can spin up. You can use them for as long as you want. And when you feel like you're done with it, you don't need this anymore, you can take them down. And that can be settled on any chain. When that network gets taken down, you can settle the assets of the state on a base chain of your choice. So yeah, this is all clear. Thank you.
I'm Parker, co-founder CTO of Caldera. We're on Rollups as a service as well.
I'm Matt. I lead the product team at Opchain Labs. We build Arbitrum technology, including rollup, interest chains, stylus, etc.
I'm Gabriel. I'm DevRel at Cartesi, and Cartesi is building RISC-V verifiable computation, and the main branch nowadays is application-specific rollups.
Awesome. Thanks, everyone. Well, I thought we would kick it off by talking about some of the most compelling reasons why developers and projects are spinning up rollups today. So, Amit, starting with you.
Well, we have developers like Arbitrum and folks who are spinning up general purpose chains. Mm-hmm. And I think we have understood over the last year or so that rollups are the way to scale. And we are seeing over the last year or so, we have seen trend of people deploying their own application tailored rollups. They had the choice, or they still have the choice, to go and spin up, Cosmos style chains as well. But I think the benefit that rollups give you is, one, it's much more easier to bootstrap because all you need is maybe one sequencer and that's it. Mm-hmm. Because you're deriving security on the base layer, so you don't have to worry about finding hundreds of validators. And so a lot of people prefer something like rollups because it's much easier to spin up and you don't have to bootstrap the network. And then you could still customize in many different ways. So you could have different runtimes, you could customize in terms of your gas token and things like that. Which is doable in app chains as well, but it becomes much easier.
Mm-hmm. Awesome.
Yeah, so I think for us, is my mic?
Yeah, can everyone hear Parker?
I guess this is why they use this. Can people hear me now?
That's better.
Okay, fantastic. Yeah, I would say I would highlight 2 reasons why someone would choose a rollup, or 2 or 3. I guess one, rollup over a mainnet chain would probably be cost and performance. Rollup over another app chain would be, as Amrit says, bootstrapping and liquidity. But I think more fundamentally, the reasons why someone would choose a rollup or to build their application on top of a rollup is 1, performance optimization, right, cost and execution speed, as well as 2, value capture.
Yeah, there you go. Yeah, I think generally we enjoy having kind of trustless databases where we can build applications of any kind, and so block space became valuable as a result. So being able to access that block space for much less cost became very important to developers and users, so rollups became very important. I think we're now seeing kind of an interest in other versions of chains that are not necessarily posting all the data to the settlement layers that we're used to, but that would be mainly why block space is valuable. We're still seeing why, but yeah.
I guess that's what they said, but to see it from a different angle, I guess, why not rollups? Before, we tried different iterations of other solutions to scale the base layer or even to have different base layers, and yet rollups were so successful. I guess that's because at the end of the day, people really trust Ethereum, and they really want to have this Ethereum as a judge solution. So rollups kind of fits the bill. It makes a lot of sense.
Awesome, thank you. And there's something I want to tease out a little bit more here that you've all kind of touched on, is this do you build a generalized rollup or do you build an app-specific rollup? For people who maybe are newer to the rollup space, a generalized rollup you would think of as a lot of your established rollups today, where there's many different types of apps operating on an L2, whereas app chains, like Zora, are just there to kind of buy and sell and mint NFTs. And provide creator rewards as an example. So yeah, what are the hypotheses and like kind of predictions you have for like generalized versus app-specific rollups?
I think the moment you move the execution out of Ethereum, right, it gives you a lot of flexibility in what you can do. And as you mentioned, of course, the first thing that you do, or we have seen, is the likes of Arbitrum, Optimism, zk Sync, and others, which are general purpose in nature. And since then, you could go as degenerate you want, right? So you could start with, let's say, general purpose chain. Then you could go, hey, I want to go an app, not app specific, more like sector specific chain. So you could, I don't know, build a DeFi chain where you have Uniswap. I mean, let's hope that will happen one day. But you could have, let's say, Uniswap, Aave, all the main DeFi projects sit on the same layer, and then you could have liquidity that's shared across these apps. You could go then one level down. You could say, hey, now that I built sector specific rollup, I would go app specific level as well. And then the third would be where, which we work on, which is basically, we could say, I don't want this rollup for a long time. I only want for, I don't know, this event, because I want to do ticketing on this event, and I don't want this forever. So I think depending on the purpose, you can go as degenerate as you want with rollup, simply because you're not tied with the limitations, execution limitations that comes with a base chain like Ethereum, simply because you have moved that execution out of the system.
Okay.
I would say a lot of our larger customers at the moment, although we do strongly believe in high levels of customization for app chains, I think a lot of the existing rollups that have found success, especially from our end, like Injective and Manta in particular, are maybe that second level, as Emergent talks about, not like general purpose chains, maybe one level below that, in that they are slightly more specialized to specific use cases. And I think we ultimately do believe in like the app chain, app rollup thesis, but at the moment, I think it is a little easier to launch like an ecosystem chain, maybe in a specialized vertical, probably more from like a BD perspective than anything else.
I think I'd categorize this into three things. So if we're just talking about like the scale of general purpose to specific, one of the main benefits of blockchains in general is just public access. And so building apps in a composable ecosystem with liquidity that can move across any application is the primary use case we've seen succeed today. That's part of the reasons why rollups in general are so successful, is because they are general purpose. And so I think we're going to continue to see that play out and see that thesis play out, just with value accrual being slightly different, right? With the ownership of those, I guess, development environments shifting. There'll be a lot of trade-offs with that, so we'll see exactly what happens. The middle one, which I think we're seeing a lot of traction with the likes of, obviously, the rollups as a service teams and individual teams spinning up their own chains, are making certain operations a bit more performant by adding them as precompiles into the core protocol. Some applications need to do something very specific all the time. They want to make that more performant. What we have yet to see, but I think we will see, are highly whittled down protocols that are very, very specific in purpose, where only a certain set of instructions can actually be executed by the nodes. And that'll allow those to be very, very performant and reduce transaction costs by an order of magnitude. And I think, again, this kind of goes back to the payments, built on top of a blockchain that was built because the original payment theory wasn't as interesting, but we're getting back to that original thesis. And so, yeah.
I guess I agree with everything that was said overall.
You want to swap places?
Yeah, we can, we can go first next.
Yeah. But I guess one thing that we didn't mention, though, is how the first generation, I guess, of rollups, they basically mimic Ethereum in a way, and that's because it's familiar to us. I think what we're going to start to see is they become more, they have the freedom to become more particular, even though they might be general purpose as well. And that's going to be further trickle down into the application-specific ones. And I think it's going to be a back and forth, like a spring. So application-specific are going to be teaching the general purpose on techniques and things that are possible but haven't been thought because of security threats, or just you don't feel sure about it. And you're going to see, oh, it's working so well for that, or there are other dev out there. We might implement this in this second layer that is more general purpose for all the other applications as well.
Okay. And I know Cartesi has launched Honeypot, and it's kind of been running, for 4 or 6 weeks now, maybe longer. Like, what kind of lessons have you learned from that so far?
I guess one of them is it's really, really safe. There's quite a bit of money there. I won't try to guess right now because I don't have top of my head. But nobody hacked it yet. And
Is there a bounty for it to be had?
the dApp itself is a bounty. So the Honeypot dApp, for who doesn't know, is a dApp where the Cartesi Foundation is putting money every week, I think, and it's inviting people to just try to steal it away. We won't go after you, no police, no nothing, that's your bounty. And so far, it's pretty sturdy there. And it's running on a RISC-V VM. It's written in C, this version of the dApp, but it could have been written in JavaScript or any other language, and it's super safe.
Awesome, very cool. And Paco, I wanted to pull on a thread that you mentioned about like customization versus like just having stuff out of the box and kind of running with it. Like what kind of customizations are you seeing rollup teams ask for?
Yeah, so I would categorize this into a couple different ones. There is like business logic customizations that we will occasionally do. For example, certain cryptography libraries in as a precompile, or someone who's doing like a perp trading protocol might want to have some more complex math. In addition to some other teams who might want to write their actual like application layer logic in Go rather than Solidity for performance reasons. For example, some teams want to enshrine royalties at the node level rather than at say like the Solidity layer. But broadly speaking, we've seen a lot of requests for custom gas token. We've seen a lot of requests for shared sequencing, and also Alt-DA, of course.
Nice, thank you. All right, well, we'll start with you for the next question.
For sure.
Could you share more about like who are your ideal customers and how are you thinking about go-to-market?
At least at Cartesi, we don't think about like ideal customers exactly. But we've been looking to like onboard Web2 users into the Web3 world, like have newer developers, and it's been like a battle, right? I guess the whole industry have been battling with it. And what we learned throughout this journey is like it's much easier to talk to students, to talk to junior developers. They are more willing to learn about new technology, and that's what we're focusing on for a while now. We've been going to universities, we've been talking to blockchain clubs, and to them it's really refreshing to know that they can use the language they just learned there in university to code smart contracts instead of having to learn about Solidity and this whole very specific environment. Yeah.
Nice.
Yeah, it's a tough question. I think lots of different technology, lots of different users. I guess the way I would think about it is there's kind of an order of operations to the way that the industry is developing. You have DeFi. So speculative trading is kind of the primary use case we see in crypto today. And I think in many ways this kind of mirrors a lot of technological development. You need something to subsidize development of the core tech. That is the product market fit we've seen. Now we're getting to a point where there's enough liquidity and confidence in the core technology, right? As you mentioned, you've launched something and it's safe. We've seen this kind of play out now with a few different pieces of technology that the enterprises, larger institutional asset holders are starting to evaluate that it might be more performant for them. So we kind of target DeFi, early adopters. We now have kind of this like more interesting nascent use case. For me, and I think most people, we are all interested in the kind of the rest of the market, which are kind of everyday users being able to send payments on-chain as the kind of default path. But I think in order to get there, we need to onboard the institutional assets first. So I think that's kind of how we think about things. Depending on the product, you have a different target.
I would say our ideal customer is probably one with a lot of money. Or
you stole my answer.
And there it is.
But we really enjoy working with teams who are going to push the idea of what you're supposed to be able to do with an app chain. So technically strong teams who have a clear idea of how am I going to make my rollup special. So I'll give a couple examples. Like Lit is putting a lot of cryptography out. They're like a decentralized key management solution who are putting like cryptography precompiles on an OP stack chain. Or Frame working on an Arbitrum L2 who are enshrining royalties and building out an ecosystem chain for NFT creators, but doing a lot with like at the node layer. So we really, at least I just personally enjoy working with teams who are going to work with us to push the boundaries of what you can do on a rollup.
Yeah, I would say, unfortunately my answer was taken anyway. So yes, everyone likes, the ideal customer is someone that pays. Wealthy customer is an ideal customer and client. But I think, as Paco was mentioning, it's not necessarily about, I think in the end it also boils down to the eventual number of users that client has, right? Because you could be very fancy and come up with all sorts of fancy stuff, but in the end, if there's no user, it doesn't bring you much, much marketing. It doesn't. You can't boast them. You could say, hey, I have this client that is using us, and they do, I don't know, 1 million transactions a day, and that's a huge boost for your client base. However, having said that, if you go back, let's say 2 years ago, maybe during the DeFi summer, if you had said, hey, DeFi project should go and build an app chain or app rollup, many would have disagreed with you, said this is not possible, right? We would not do this. Maybe because DeFi started, their own thing, and now you see a lot of people in the DeFi space trying to go towards app rollup. I think that's a good sign. Now, from an end user perspective, we have seen a lot of gaming companies coming to us. I think that's one sector where we've seen people wanting to have control over the infrastructure. Simply maybe because of account abstraction, maybe because they want to be able to customize. For example, we talk to game builders and they have these contracts that are huge. And even if you wanted, you can't run that on a general purpose chain because, you could blame them and you could say, hey, you didn't write your contracts properly, and go and customize your contract. But in the end, if you are building a really fully on-chain game, your contract would become quite heavy. And so you want to be able to have an infra where you can go and control the limits, for example, gas limit and things like that. Mm-hmm. So in reality, we are seeing quite a bit of demand from game developers, some on DeFi side. And then, as was mentioned previously, you want applications that drive consumer base, right? That drives user base. And so anything around, consumer applications that has become very popular in the VC space these days, I think that's one sector that definitely needs app-specific rollups.
Mm-hmm. Got it. And yeah, I'd love to hear a little bit more about a couple of examples you could share around gaming specifically. I would imagine that some games might be worried about noisy neighbor problems. If you're sharing block space with a number of other apps, you don't want people who are playing the game to suddenly have a gas spike while they're right in the middle of getting the best NFT reward possible or something like that. What are you hearing from them in terms of what's most important?
So there's several things. One is, of course, the block gas limit. So they want to make sure that they can push beefy blocks on the network. In some cases, some of these builders are using hardcore cryptography. So they want some sort of a crypto tools and libraries that goes as an opcode in the runtime level. And in some cases, what we have seen is there are people who say, hey, account abstraction is great, but in the end, we are only going to use it for regular, gasless transactions. Do I need the full power of account abstraction? Maybe not. So they want a network where there's no notion of gas at all. So basically, when you as a user, you use that rollup, you send your transactions without owning any gas token, and behind the scenes, the sequencer is the one basically bearing all the cost and posting data on Ethereum and basically covering that cost on behalf of users. In that model, these game developers are building solutions where they can prevent spam because they still have to prevent spam in some way. So they're building, let's say, a fee model on top. So basically, when you send a transaction, you don't have to own any gas token, but you're paying a fee to the application, and therefore that acts as a spam prevention mechanism. Mm-hmm. So some of them are not going the full account abstraction route, but say, hey, just this bit I need, and can you remove gas token completely?
Mm-hmm. Super interesting. Thanks for sharing. And Matt, I'd love to hear a little bit more from you. I spent 5 years at Coinbase before I joined Espresso, and we were often saying the speculators come first, or the vice aspects of the industry come first, and that brings more people and it helps create more use cases that help things go mainstream. You mentioned bringing in kind of more institutional players and DEX and DeFi and perps. When do we get to the point where we think there's good payments use case adoption that everyday people would be excited about using?
When we get regulation. That's the unfortunate answer. At least in the territories that I work in, I think currently there are solutions you can use in blockchain tech, both in the EVM and outside of the EVM, that are cheap and fast enough, sometimes faster when it comes to settlement of your payment than current solutions. If I use PayPal versus, say, an L3 AnyTrust chain, it's going to be a very similar experience, provided that the UI is actually built in that way. I'm not sure this is answering your question, but I think, when there's confidence from enterprises that hold a lot of assets to be able to tokenize what they have and bring it to a wider group, and they actually start deploying, it'll be just like the airline industry when they started charging for bags or charging for seats with an inch more. This type of user they tend to all move at once in one direction. And so once we see one major player go, I think we're going to see kind of a waterfall, and that'll unlock a lot of rails for the then payments providers to actually build on. And in some cases, they're the same organization. Yeah.
Could I add a point on customization? So there's one thing that I forgot to mention, which is it's talking about regulations. There are people who come to us who are building, let's say, real-world tokenization apps. So imagine, for example, tokenizing private equities and those sort of things. And at the moment, or previously, what they used to do was have some sort of an app which is gated in the sense that only if your wallet address is whitelisted, then you're allowed to interact with the app. In that model, if the contract is somewhat permissionless in that sense, you could still bypass this entire front end and basically send transaction directly. So you do not have to use their wallet infrastructure and their app. You could basically send directly a transaction to the contract. And so what some of these guys are doing is they're saying, hey, I want to have a roll-up where the sequencer basically blocks everything. Because they have to be compliant and they want to make sure that you cannot bypass this by using a different wallet or by sending a transaction directly to the network. So they want to make sure that the sequencer has the rights and the controls to basically check, okay, here's a transaction that comes in. It's not in my allow list. I'm going to reject it. So this is one customization that we've seen from people who want to build real-world assets because they have to be compliant.
Oh, okay, interesting. Very cool. Well, I'd like to move to a little bit of a spicier topic and ask you all about what you're seeing and hearing about like roll-up value accruals. So we know, at a basic level how roll-up economics work today. So you're paying a DA fee, you're paying for execution, and then there's some revenue once you kind of settle to your preferred base layer. How do you think this might change? What are you hearing from projects about what they're thinking about for how to make this sustainable? Gabriel, if we want to start with you.
Honestly, I haven't think too much about it. I've been thinking more about the infrastructure and then how things can be built. I'm much more of a nerd about the tech itself, and I haven't really thought about the crypto economics of that.
Yeah.
I really defer to him. Probably you just thought about that more.
Yeah, spent a decent amount of time. I think there's probably two main ways I see this happening, aside from the classic fee token narrative that we're seeing play out, at least for now. One, which is kind of already played out on the base layer, and now we're going to see it, I think, on scaling solutions generally, is incentivizing network security. Proof of stake was created for a reason. And I think the fact that that doesn't exist currently in a lot of chains is an interesting one, because the reward mechanism for actually participating in the network is almost nothing. Right? Only if you win a challenge, you will get a reward. And so there's a lot of innovation that can happen here. It's very, very tricky. And also, there's a lot of social coordination required in upgrading any of the protocols that are live today. But that's one main thing. There's lots of ways to think about kind of value accrual for systems that have a security mechanism. The other one, and this is obviously something that you folks are thinking a lot about, is MEV. You have arbitrage happening at massive scale on these networks. It's only going to continue to grow in size. On L1, we have lots of kind of value capture now going to a select group of participants through kind of Flashbot's MEV boost. But on rollups generally, there are, we published our thoughts on time boost, kind of ordering policies that could be adopted by certain chains to allow for MEV capture to be done in a more kind of slightly more user protecting and more efficient manner. And as chains decide to adopt technology like that, that does capture value for the chain, they can decide how to distribute that across their user base. And so there'll be a lot of opportunity coming forward.
Yeah.
Yeah, makes sense. I think I agree with what a lot of Matt said. I think in terms of where we prioritize value capture or where we see a lot of it happening right now, there's the whole like custom native token narrative. I think that it is yet to be fully proven out, but I think the empirics are that it is relatively useful for people's token, just as a narrative, just being honest about that one. I think sequencer fees, everybody has the thesis that they'll go relatively to zero, but at least in the short to medium term in practice, it can be a pretty decent source of revenue for a project on the order of, say, like, depending on the amount of traffic you have and depending on what your settlement costs are, a couple K a month, 10K to 15K a month for a chain with like decent usage. Another interesting one that I've seen is sort of like staking the ETH locked in a bridge. So taking basically like Circle's business model, which is like, oh, we are securing X amount of customer funds. Why don't we earn some kind of yield off of it and share it? Which is actually something that I think could scale quite well. That's something I'm quite bullish on.
In context with app-split rollups, of course, what I mentioned, I completely agree with them. So one thing that I would like to add to that is, unlike the big giants like Arbitrum, Optimus, and some of the other ones which have an established network and ecosystem of nodes and systems around them, for example, it's Explorer and indexes and whatnot, many of these app-specific roll-up systems, they actually want to lease out some of those systems as well. So you could say, hey, you can come and become my node operator, not sequencer, but it could be like, I don't know, become an indexer or become a watchtower node, which basically keeps track of how the network is operating. I want to lease out that service to you. And if you're building something on top of that, for example, you're building Explorer, you're building indexing service and something like that, then it'd be something back to me. So it also kind of becomes like a sink for the tokens as well, where basically it becomes like a network where you are, imagine something like an eigen layer, where basically you stake your token, and then you're allowed to become an AVS operator that serves, let's say, a watchtower node. So we are seeing some of that leasing out features as well for some of the network parts.
Okay, interesting. So it would be like if I wanted to participate and perform a certain role within the rollup ecosystem, I might stake that native token to get access to that. Right. Super interesting. Yeah, I think all these points are really fascinating, and especially as we know today, the Ethereum ecosystem is rich with MEV, and we all have different opinions on whether that's a good or a bad thing. But yeah, I think that the rollup ecosystem has just grown exponentially in the last 2-3 years, and has overtaken ETH in terms of transaction activity and volume, and so much cheaper that I think that as we see this ecosystem mature, there are going to be opportunities for intra-rollup MEV as well as cross-rollup MEV. And it's going to be a super interesting space to contribute to and hopefully shape things in the right direction so that customers are not bearing the brunt of those costs. But yeah, I think that's a really valid point. And I think that there's some really interesting models here about, how do you gain more utility in a way that is very real and feasible to participate in the network and align incentives long term. Cool. Well, we're kind of coming up on time. I'd love to close out with your top roll-up predictions or things you're most excited about for the next 12 months. Gabriel.
I won't make predictions. They are really hard. But I really am excited about seeing solutions and these new systems where you can have cross rollups messaging. Like these gateways are going to be really interesting and important coming forward. I think it makes a lot of sense because these applications, they are going to grow, but now they are kind of like siloed away from other applications that might be really interesting if they work together. And these bridges are going to be like super, super helpful, and it's going to make everybody grow together. So again, like comparatively to like bridges on across chains, they are like super hard, and there's like some really hard trust issues going on. When you think about rollups, you have better solutions that really, I think, makes things feasible and decentralized in a way. So I'm excited to see what happens in the near future. I'm not working on that, so I'm just following along, and I think it's going to be interesting.
Awesome.
I guess I can't sit on a panel without shilling Stylus. So, at Offchain Labs, we're working on a new upgrade to Arbitrum Nitro that allows you to publish any smart contracts in any language that compiles down to WASM. And as a result, you actually gain efficiency improvements. They can be up to like 500x, 1000x, depending on the type of operation that you're doing. This is fundamentally new for crypto developers in the EVM, so really excited to see what kind of applications are built. There's a lot of cool stuff that I can't share that I know, which is going to be really exciting to see. I would say two other things really quickly. One, we're having this talk right now. 6 months ago, this would not have been a panel that people would be talking about. Just the number of people building ancillary services and working on the core protocol and supporting pieces of infrastructure that benefit rollups just means more brains are on it. We're going to see improvements that make things cheaper for everyone, which is really important. And then the third thing is I'm a big gamer. While most games I have played on-chain are not fun, there are some fun ones now, which is awesome. And really, I think if we can help these teams and force the big publishers to open up their in-game currency networks to kind of on-chain elements, that'll be amazing. Used to trade WoW Gold back in the day. You can sell for real money, but now if you can do that on-chain, it'd be great. So I'm excited for that.
Yeah, I'll give a bit of a boring answer, I think. And it's that I think that app rollups have been a thesis for a while. I think it has been sort of quote unquote maybe a elite consensus, like a big VC narrative for ages. Last year at DevConnect in April, we were talking about Celestia is going to launch. It's going to be a modular thesis. It's going to be this, that. But if you look at it for ages, there have not been a lot of mainnet app rollups for the vast majority of the history of our company, as well as the past year or so. Right? It's at conferences like this we talk about the hottest technologies, where things will go theoretically. But most of all, I'm just excited that right now and in the next couple months, it's here. Mainnet rollups are launching. Mainnet app rollups are getting tens of millions of TVL, one way or another. And also, the modular thesis and a lot of bits of infrastructure that was regarded as quite theoretical for some time, like Espresso, like Celestia, DA layers. A lot of this has been sort of just out there. Someone's been talking about it, but where is it? And just super excited to take all of this stuff to mainnet.
I would say I'm hoping, for a while we have been asking about users and where are the users. And I'm hoping, it's not a prediction, but I'm hoping that should change in the next year or so. And I think that, I love DeFi, but I think DeFi has become way more complicated for average users today. And I think the users that, people talk about consumer application, I think it has to be something around that.
Yeah.
And I would say I'm more bullish on games and socials than on DeFi, simply because at the moment today, if you want to use a new DeFi protocol, you have to go and watch a 1-hour tutorial video to even understand how the thing works. And you have to go and read dev docs. Seriously, are we expecting average user to go and read dev docs? The reason many people do that simply because they hope that they will make money from that. I think we have to come out of that cycle, and hopefully that happens where people actually use it because they like it, not because they think that they're going to make their money double or triple in the next, if they go and read the dev docs from end to end. So yeah, I'm very much bullish on games, and as I was saying, yes, the games are clunky, they're not great, but I think hopefully this will change, and this has to change.
Yeah.
If you want to bring users, you have to go beyond DeFi.
Yeah. Agree. Yeah, I'm really excited to see more user adoption and better user experiences. I did fall down the dark forest rabbit hole for a while, but the process of bridging there and back took a few hours every time once I ran out of whatever the token was. I think it was XDAI at the time. So I hear you. And I think that where there are opportunities for customers to have these crypto native experiences but not even have to run into all these friction points, it's going to be a very positive sign for adoption. So with that, thanks all for sharing your awesome insights, and thanks everyone for joining us.
Well, thank you very much.
Cool.
Nice work.
Well, thank you.
Hi, everybody. Welcome. As she said, my name is Nasei, and I work for a nice project called Alio, and we're heavy into the ZK. So even though I'm not an engineer, or I like to say that I'm not the most technical person, I find value as a regular, non-technical person loving or really liking ZK in general. The way I think about it is that, ZK is really the secret sauce for proving that, things without actually giving the necessary details. So I just want to welcome our panel. And I want to give each of you guys a chance to introduce yourselves and tell us a little bit about your projects.
Can you guys hear me? Okay, thanks for staying back. I know the weather's not the best right now. My name's Mansi. I work on a project called Rosito. I lead our product and growth teams. And Rosito is a general purpose ZK virtual machine. What that means is essentially you can run any piece of arbitrary code and in a ZK environment and get a proof for it. So it's not necessarily specifically built for EVM. It's a general purpose virtual machine. And because we've used RISC-V architecture, it enables people to write their pieces of code in normal languages like Rust, C++, and Go. So that's the technology I'm working on. I've been in the crypto space for almost 6 years. Prior to this, I was working on a decentralized data storage protocol. And prior to that, I was in the TradFi space.
Thank you. I'm Orkun. I am CEO of Chainway. Chainway is an infrastructure company that builds ZK and Bitcoin tools. And previously, we built ZK compliance upon Tornado Cash, which is called Proof of Innocence. And now we are building the first ZK rollup on Bitcoin. And I am an engineering background people, so I worked for an engineer for years. And last year, we co-founded Chainway with my friends. We are actually based in Istanbul, so we are kind of host. And yeah, I'm excited for the panel and the panelists. I can hand over.
Yeah. Hi, my name is Maya. I do business development and partnerships at Lida Foundation. We are also developing a zero-knowledge virtual machine. It uses RISC-V inspired architecture and Plonky 3 as a proving system. We're building a suite of services and tooling atop of the VM, and are excited to share it with you guys, and very happy to be here with these lovely fellow panelists today.
So as we were talking about ZK and everybody's building onto ZK, I'm curious for you guys, how do you envision ZK technology influencing the broader adoption of blockchain and decentralized technologies across various industries?
Maybe I can start.
Yeah. Go
Okay. So there are 2 points that ZK is right now used, and I believe most helpful for blockchains. One is, of course, privacy, because blockchains are public ledgers mostly, and if you don't have privacy enough, then you shouldn't do any important transactions on it. Besides these aspects and scalability, of course, the base layers are targeted to be the most secure and decentralized layers. However, their capability is limited to what they can do, and moving those transactions or computation to off-chain helps you to scale the base layer, staying in the same trust level. And this is only possible with verifiable computation like zero-knowledge proofs.
Yeah, I definitely agree. The 2 major buckets of use cases are privacy and scalability. Just clicking down on scalability, again, I put it under 2 buckets. One is, as we've discussed in the previous panel, rollups is a big use case. So just scaling traditional L1, scaling your blockchain, scaling throughput. You can do that with ZK technology. And then the other use case that I'm personally super excited about is using ZK as a coprocessor. If you're not familiar with this concept, essentially, instead of building a rollup, now you're using ZK at the base layer, where you can think of it as a CPU and a GPU, where a GPU does some special computations and assists the CPU in whatever task it's doing. So you can think of ZK coprocessor, which is similarly helping the L1 do additional computation. So let's take an example of a DeFi protocol that wants to implement an on-chain order book. It's really expensive to do that. The smart contract gas costs are really expensive. And just the complexity that Solidity currently enables, it's not there to implement a more complex DeFi logic on-chain. So you can use ZK or a ZK coprocessor where you offload all of that computation and logic. It does the auto matching on behalf of the L1, but in the process generates a ZK proof. So you don't have to trust this off-chain computation. The proof will guarantee that the execution was done in the manner you wanted it. And then you bring that proof back on-chain and use that for your application. So it just expands the capabilities of what's possible, even at the L1 level.
Ooh, I'd jump in and say I love these breakdowns. I think when it comes to the adoption of blockchain technologies more broadly, I would focus on kind of the opportunities that zero-knowledge proofs open up to a variety of developers. And that doesn't just have to be in necessarily financial infrastructure. It can also be in gaming applications. I think zero-knowledge proofs open up a lot of doors for private autonomous networks and for private communications between various devices, be they running a blockchain node or not necessarily. We still have a long way to go when it comes to standardizing the ways that proofs are accepted and communicated between devices. But when that happens, I see a lot of opportunities for, let's say, gaming, for privacy infrastructure, and some very cool use cases.
Yeah, just to add to that, I think ZK as a technology definitely has the biggest use case right now in the blockchain space, but ZK, I think, in the long term will be valuable across many industries, even beyond blockchain. Again, going back to the two functionalities, privacy is critical regardless of whether you're using blockchain or not. Computational integrity is critical regardless of whether you're using a blockchain or not. And we are actually starting to explore what Web2 use cases can leverage ZK, so I'm happy to talk about that.
Yeah, some of the other things too is that for myself, identity is such a really big thing, securing identity. I'm from Nigeria, but I live in the States, and so the idea of, having your identity on chain is super important and safe, especially if you're trying to go to different countries, if you're in a world where you have your government is unstable. This type of technologies, I think that kind of will help that. But if I can go to Maya specifically and thinking about some of the challenges, how are these products designed to cater to the diverse needs across all these platforms, whether it be the financial spectrum, and what role do they play in fostering more equitable and decentralized digital era?
Great question. Well, I would say to answer the first part of the question, I think here we have to hone in on developer accessibility, right? Web3 developers make up, by some estimates, 0.15% of all global developers. And the languages that Web3 developers use, especially when it comes to writing zero-knowledge applications or other zero-knowledge programs, can sometimes be a little difficult to learn or a little difficult to master, which creates a barrier for entry for developers. Now, I think as proving systems become more standardized and we start to see people and teams coalesce around, oh, actually, this proving system is really great for this use case, that's when we're going to start to see, let's say, Web3 developers and non-Web3 developers who are interested in the space, mastering a variety of languages or mastering developer environments. Until then, I believe, and we at Lida believe, that meeting developers where they are is crucial. So we're actually building an LLVM compiler for our VM, which would allow developers to write in Rust, C++, Go, and other languages to fully harness the powers of ZK. And to the second part of your question, how is this generally applicable, and how can we open up ZKs for very important and critical use cases? I would say let's put it into the hands of more developers. Let's tell people what they could do with it, and not just the technical aspects of ZK. That's rapidly advancing. That's rapidly advancing anyway. So I would say I love reading a blog post or watching a video about people tinkering around with new applications and going the extra mile.
Nice. And keeping on the challenges that a lot of these projects are facing, for Chainway, what challenges do you guys see when creating ZK rollups what challenges do creating ZK rollups on Bitcoin create?
Yeah. So while working, we previously worked on ZK also too much, and I have several counter arguments also here. I believe that making ZK accessible is highly important for developers and etc. But however, creating too many proof systems can result in a fail. So we should stick to the simplest form of ZK in some points. For example, today everyone makes a minor changes to some protocol and maybe release a zero knowledge primitive. However, in long term, this cannot be sustainable because all these codes needs to be audited and got into enough security considerations. However, today most of the ZK tooling are unaudited and no one knows what will happen while using it. So for my experience, I can say we should stick with the simplest ZK forms. However, we should make the tooling as easy as possible to onboard as many developers as possible. And in our case, in the background, we are running RISC-V, RISC-V and RISC-0 ZK VM, and we are running an EVM inside of it. So we are making small changes in the prover to make it more performant with EVM and EVM-like environments. However, keep sticking with the RISC-V architecture, we make the loss of security assumptions go away. So we trust the RISC machine that is working for years, and we are adding ZK on top of it. So for us, it was an easy decision to choose this kind of ZK VM. However, we made small adjustments to make it possible to work on, in our case, like a ZK VM.
Yeah.
Go ahead.
I think it's just, evolution of any technology where the early days, it looks, similar to what we are seeing in the ZK space, where there's a lot of work on the core infrastructure, and the proof systems is what a lot of people are iterating, trying to optimize, figure out if there are better ways to run proof systems that are more performant or specific to certain use cases. But to your point, if we have like 100 proof systems and they don't really work with each other, they're not interoperable, it's really hard to build applications, and like even for a developer to think through like which ZKVM do I use or which proof system do I use. I think it's just a level of maturity that we as an industry are now hitting, where we are starting to find these like toolings that are built, additional like developer just points of access, where now the focus needs to shift towards, instead of like the core infrastructure exists and it's there, for developers to start building on top of that infrastructure and iterating based on their needs and problems that they want to solve, as opposed to thinking about the underlying cryptography and math. And that's our biggest mission at ResZero, is making ZK accessible, again, to your point, where we are taking care of the ZK piece. You don't have to worry about it. As a developer who's trying to solve a real-world problem, why don't you focus on that problem, and we'll handle the underlying ZK cryptography, and hopefully that's working for you guys at Chainway.
Yeah. Well, for ResZero, though, I'm curious, what challenges for you guys do you face while creating this platform that lets users trust programs running like anywhere in the world, like using ZK, right?
Yeah. So definitely, it's not a trivial task to build a RISC-V general-purpose ZKVM. It definitely took us around more than 2 years to get to that stage. But again, like I said, once the foundation has been built, of course, we have to go through security audits. We have to ensure the technology works as it's promised. We have to do formal verification on the proof system to identify how many bits of security the system guarantees. But once we get to that level of maturity, again, it becomes very easy. Though I would say, ZK definitely has one challenge beyond, accessibility and developer tooling. Performance is still a big component. Even today, I would say ZK is probably 10 to 100x slower than other execution environments. And it's just a trade-off, right? You're getting additional security. There's a cost component, but it's slower. It's just, again, we need to continue iterating and evolving. I think just in the last year, we've gone from like proving an ETH block takes multiple hours to proving an ETH block taking like less than 20 minutes. So that's a significant improvement, but we want to get to like seconds of proving time. And as an industry, I think we are working on optimizing those underlying performance, and that's going to be critical in terms of getting ZK in like mass adoption stage.
Yeah. Completely agree. And one of the things too that's interesting is that when we talk about all these challenges, it's easy to get boggled down in like, the length of this, but the smallest the smallest win is monumental for a lot of like these projects. But going and looking at real world use cases for Chainway, what are some like real examples of ZK to boost the capabilities of security or of the blockchain on platforms like Bitcoin and Ethereum?
Mm-hmm. I think in Ethereum case it is different, but to be talk on Bitcoin, Bitcoin is like world's most secure and decentralized blockchain, and it is the oldest, and it is perfect for simple payments. However, it is not designed or optimized to make lots of on-chain financial activities like swapping or lending or borrowing. However, as the neutral and secure base layer, we need to inherit its security and build some financial infrastructure on top of it. And we should do it as efficient as possible, and this is through ZKPs actually. So while building a ZKP layer on Bitcoin, we use the Bitcoin security actually. Like there's a debate between one of our friends and us. Do we scale Bitcoin or Bitcoin scales us? We don't know that. But we scale Bitcoin in terms of capabilities, and Bitcoin scales us with the security. So while combining this with ZKPs, we create a trustless environment on Bitcoin, just like Lightning. However, it is much more capable than Lightning can do, like make any EVM transaction or any EVM smart contract on it.
Nice. And then for Maya, do you have like some like real examples of how people are currently using like Light or working with Light Foundation to like use cases?
Yeah. So currently, we're still in the process of development, and our MVP is set to be launched at the end of this quarter. We're starting to talk with a variety of teams and a variety of developers to foster adoption upon completion of the LLVM compiler and of other elements of the VM and our service stack. But what we're really eyeing is, look, as a developer, we want to give you like the best performance that you can possibly get at the moment with the most seamless experience for you to build what you want. Behind the hood, we're working on a few templates and a few custom APIs and SDKs that will be accessible to all sorts of developers. But that's just to show the capabilities of what you can build, and not to, not to do the building for you necessarily. Yeah.
And for Rasiro, like what are
use cases? Yeah, I think there's a spectrum when really.
Well, what are the ones that you're the most proud of?
Yeah. Yeah, definitely. Love to chat about that. So, like I mentioned, there's definitely the roll-up spectrum, which is where, projects like Chainway are using our general purpose technology to build roll-ups on Bitcoin, build roll-ups on, Ethereum non-EVM roll-ups. One thing that I'm most excited about on that front is, how do we bring ZK to optimistic roll-ups? We talk about optimistic versus ZK as like two separate, but there is a hybrid capability here. And we are working actually with Optimism and Optimism Foundation to essentially enable ZK for fraud proofs. And that's step one, right? If we can do fraud proofs using ZK, we can then extend that to validity proofs, essentially proving every single optimistic block. And then we can bring that to both reducing withdrawal times and interoperability between different optimistic chains. So that's on the roll-up side. On the non-roll-up use cases, definitely very excited about expanding the capabilities, like I mentioned, of DeFi, like creating order books, off-chain order books, or creating more complex pricing logic, like running a Black-Scholes model is really impossible right now on-chain, and ZK enables you to do all of these off-chain computations that then you can leverage on-chain. There's also we just released couple days ago this use case called Bonsai Pay. It's essentially enabling you to send crypto to any Gmail account and claim crypto using a Gmail account. So it's connecting your login with Gmail to a proof that's generated that you own that Gmail and connecting that to your address and really making payments with crypto accessible. So ZK touches just so many applications across identity, KYC, gaming. It's hard to pick a favorite.
I mean, with that though, how do you guys, how do you account for like regulations and securities? If we're talking about ZK and we're using all of these like identity and payments, how do each of your projects address security and regulations?
Do you want to go first?
Sure. So I think this might be in reference to GDPR and regulations that have been coming out of the EU. those are potentially the most progressive globally, but privacy should be a right for every single person, and for every single person interacting with other people, with networks, with digital entities digitally. To this end, zero-knowledge technologies are still rapidly developing, and so are regulations when it comes to privacy protection. There's no consensus globally yet about what your digital passport or digital identity should look like and which protections should come with it. To this end, we hope to be nimble enough to work with regulators as new regulations are released and kind of be at the forefront of programmable compliance. That does require an extensive variety of security audits, of working directly with regulators, and so we expect this to be a multi-year long, if not infinite, ongoing process. But we're excited to, bring protections to people.
Yeah, regulation's definitely a tricky one, especially if you're based in the US or parts of the world where the government definitely is, pretty muddy in terms of what you can and cannot do with crypto and blockchain technology. On the positive side, though, I think ZK definitely helps a lot. As a developer, as an application builder, as a entrepreneur, as a builder, you really don't want to hold PII information for your users. It's definitely a liability. And with ZK, what you can do is essentially, if you only care about, say, a particular person's location in terms of whether they're in the US or not in the US, or they are, whether they are of a certain age, say about 18 or not, you don't really need the PII information. You can definitely have the proof of their identity, age, location be generated locally at the client side, and all you need is that proof to verify whether they meet a certain criteria without necessarily holding or getting all the information about the PII for the user. And that reduces your surface area in terms of how much regulation you need to comply with. So I would say there's some positive side to ZK in terms of how you can protect the privacy and protect PII of your users.
And just like ZK provides privacy infrastructure, and previously we all see that the ZK is the only thing that provides on-chain privacy. However, we also showcased last year, you can also own your compliance using ZK. So you mentioned that, some service providers can use ZK to store some data or retrieve some data from user. And also, users can use ZK to show they didn't do anything wrong or they didn't give any data to some other provider, for example. In our case, while building proof of innocence, we created a concept where you can withdraw from Tornado Cash and you can say that, I withdraw from Tornado Cash, but I am not one of these addresses. So basically, you are not leaking your address, you are not leaking what you are or what is your address. Basically, you just say, I am not these, and it is mathematically proven. This way, you can be compliant for many countries or many other things. For example, you can just say, I withdraw from this pool, but I am not from a risk-throw team. You can eventually say that, and this allows you to hold your own custody and own compliance, actually.
Yeah, that's a really good example. I think when people think about privacy, they automatically think, it's going to be really hard to be compliant with any regulation. I think with ZK, for maybe the first time, you can have privacy with compliance by proving certain aspects about your transactions.
Nice. It's like a holy matrimony, or maybe not the greatest holy matrimony, but trying one between ZK and functionality without sacrificing security and privacy, right? So then looking ahead, what do you guys, for Chainway, how do you anticipate partnerships between blockchain technology and ZKPs evolving in the next, 3-4 years, something like that?
ZKP evolved a lot since they put on chain, and it started from privacy and moved to the rollups, and now we are talking about co-processors. But eventually, this whole process shows that we will move some computation to off-chain than on-chain, and we will verify it on-chain, basically. So instead of, for example, in the machine learning case, instead of running a model with thousands of computers, you just run it in a single computer, and you later verify with hundreds of or thousands of computers. So it is eventually a verifiable computation, and if you can verify something happened with the loss of computer without an overhead, you will do that instead of running the same process with each computer. And eventually rollups, like sovereign rollups, and what we are learning from modular thesis is that you can just move all the computation off-chain, you can settle on your own, you can settle on another blockchain, but eventually this is all about moving data and processing from on-chain to off-chain, and later proving it somewhere else. And we talked about like peer-to-peer proof broadcasting, and this is something we haven't yet experienced it. And we just sending proofs to the base layer. However, what if we can send the proofs through a peer-to-peer layer, and we can do everything between us, like without settling to anywhere? This is also a new concept, and I think if we can do it with something with ZK, we will do it in the 4 or 5 years.
For Resiro, can you name a couple of practical wins for users and developers, and also maybe something along the lines of things that you guys have done to shake up this whole trust game that you guys are doing?
Yeah, I think, just, taking an approach that's very different from a ZK VM. We've shaken up the industry a little bit with our general purpose approach to ZK. But I think the key thing that it has enabled is essentially we're able to build a ZK VM on top of our ZK VM in 2 months' time frame. That's just ridiculous. People have spent millions of dollars, years in developing ZK VMs, and that again speaks to how far ZK has come. Really, it has accelerated over the last year or two, where building really complicated applications with it has become super accessible and easy. Maybe in the 3 to 5 year horizon, and I think Justin Drake at the EF talks about this, is enshrined rollup, which is essentially your entire ETH L1 becomes snarkified. It's like every single block gets ZK proven. Your rollup becomes, Ethereum essentially becomes a ZK rollup in itself, and you don't need to run, a full node with taking a week. You can essentially create, a single proof for an entire Ethereum from Genesis and verify that in a really short period of time.
Awesome. So. And then the last bit, I just want to give you guys all an opportunity to just, shill your projects. Just
we've done that.
What are you guys the most excited about? Just real quick in 1 or 2 sentences, and we could start with you, Maya.
Sure. So I'm very, very excited about the release of some of our services and our developer tools. Please check us out. Happy to integrate, happy to talk more, including to talk about some, technical advancements on the proving system side.
Nice.
Yeah.
Yeah, maybe I can. When we go to the Bitcoin conference, we talk about ZK, and when we come to the Ethereum conference, we talk about Bitcoin plus ZK. And I can say that Bitcoin is evolving since you last interacted with it, maybe. And right now we are talking about, for example, full state proofs, like ZeroSync team compresses all the blockchain into a single Stark proof, which eventually gives you the full UTXO set and blockchain state. This makes we are talking about enshrining the Ethereum, and right now we are doing it with Bitcoin, and we are creating a ZK layer on Bitcoin, which eventually we can convert the base layer to the ZK. And this makes thinking really fast, makes the blockchain scalable, at least we can say.
Nice. Yeah. And then, real short, you give.
Yeah, I'm really excited to see what developers do with this technology now that it's easy to build, accessible. I think we've only scratched the surface in terms of what's possible with ZK. I can't even imagine all of the functionalities and apps that we can do. So I'm really excited to see what comes with it. And Resiro specific, definitely check out Bonsai Pay, which we released recently. It's a good showcase of what's possible with this technology.
Nice, thank you, panelists, and I'd like to give them a round of applause because this was great.
Thank you.
Me too.
We can go whenever. Cool.
Thanks everyone for coming. I believe this is the last panel of the day, so
Woo, closing out strong.
Closing out strong. I'm gonna have a good conversation on modularity versus monolithic. Let's have each of the panelists introduce themselves and their projects first.
I'm Nick White. I'm the COO of Celestia Labs, and so I'm Team Modular. And yeah, we're building the first modular data availability network. So it's a layer 1 that scales with a number of users, and it's built to provide block space for rollups to plug into.
Nice. I'm Keone Han, co-founder, CEO of Monad Labs. We're building the Monad blockchain, really high performance EVM layer 1. Some of the things that we're introducing to the Ethereum ecosystem are parallel execution, asynchronous execution, and just more generally a bunch of performance improvements to help Ethereum scale.
Yeah. Hi. Yeah, I'm Mariano. I'm head of engineer of C Labs, which is the company behind the technology of Celo. Celo, it's like a layer 1 that has been around for like 4 years already. And we are currently actually in the plans of transitioning L1 to an L2. And yeah, I guess that's it.
And I'm your moderator, John Wu. I'm head of growth at Aztec. We're a privacy-first layer 2 on Ethereum. So I think we've got an interesting set of panels here because we've got Nick providing modular infrastructure. We've got Keone, who's pretty committed to monolithic infrastructure. We've got Mariano, who's moving toward modular. But maybe let's define modularity. It seems like what it is we take these Lego building blocks of execution and consensus and data availability, and we get to pick and choose. So maybe to start off, Nick, could you help define each of these kind of layers of the stack?
Yeah, so modularity is all about splitting out the different parts of, like functions of a blockchain into separate components that can be designed like optimally to solve that problem, and then recombining those different components into like a fully fledged application. And there's a lot of benefits to that. One is that you can specialize to make things super efficient for that thing, and also people have a lot more freedom of choice. So you get to actually, like, as a developer, say, well, I want to pick and choose these things, rather than being locked into one single offering. So what those different functions are, there's a lot of them actually. It started out with just 4, and so I'll just start with those 4. So there's consensus, which is ordering of transaction data, because everyone needs to be able to see and agree on what the order of transactions are in order to arrive at the same final state. Then you need data availability, which is you need the ability for anyone to be able to see what those transactions are, download them, and then you need to have settlement, which is there's a lot of different ways to talk about what settlement are. I think the most important one in terms of rollups is sort of like dispute resolution. You can also think of it as like bridging. And then the last one is execution, which is all about verifying the transactions, executing them, and computing the output state. So those are the 4 main ones, but there's a lot of other things that have emerged in the modular stack, like shared sequencing, shared prover networks, a lot of stuff that we can get into.
So that all sounds pretty good, right? Being able to pick and choose different layers of the stack. So maybe a question for Keone. Why be committed to a monolithic architecture? What advantages do you see in designing everything as a single unit rather than shopping around for each layer?
Right. So I guess I would say, first of all, that Monad actually is a modular system as well, in the sense that there are several major components, those being consensus and execution, and those are actually separate. They are actually separate concerns run on separate processors, and there's still modularity in the design. But I think to your original point about why build all of these different components, and why build the interaction component that governs those. I guess there are a couple of major reasons. The first one being just simplicity. Second one being performance. Like at the end of the day, having for each node in the system, that node responsible both for communication, like the consensus mechanism, and then also for maintaining state and being the single source of truth shared across all those nodes, and all the nodes are in the same state, that ultimately we think is the most performant architecture. And then I guess lastly, I would just emphasize decentralization, because at the end of the day, what matters is we're building, like all of us in crypto, we care about this idea of shared global state, of having thousands of nodes all around the world that are all in sync with each other, that all agree on the exact balances of Nick's EOA or Mariano's EOA, or the amount of deposit in a particular Aave vault. Like all that needs to be in sync. And it needs to be the case that there are thousands of nodes that all agree on this state. That's what decentralization is. And having decentralized sequencing of transactions, consensus, and then decentralized agreement upon state, all of that is really something that's important to us and that we achieve by building a single system that works together.
And Mariano, I mean, Celo has decided to, maybe I'm blurring the lines here or misusing terms from going from monolithic to modular, but definitely becoming an ETH L2. Mm-hmm. Can you talk through the logic behind that and why you guys have decided to come into the ETH ecosystem?
Yeah, I think well, first of all, at the beginning when Celo was originally created, the idea was that we wanted to do some things that were at the point impossible or not possible on Ethereum, and that's why we said to build our own L1. I think nowadays, the landscape has changed. No, I guess the possibility of building a layer 2 on top of Ethereum to me makes much more sense. The reason for that is because I think again these systems that we create, I think we kind of over-index on the technology we use, but I think it's not the technology. This shared state that we are talking about actually creates an economy, right? And so this economy has a lot of value, and that's actually part of our product. When we actually selling block space, we are basically selling access to an economy. And for a chain like Celo, I think it makes a lot of sense to be kind of close to Ethereum economy, right? And have access or have a good bridge or have a good highway of communication with Ethereum. And so for us, it made a lot more sense to try to make that change now. And that's where I think actually the future is going to go in that direction.
Maybe that's a good segue, because I read in your announcement that a big part of the shift was technical. It was to move to a more secure settlement layer. On the other hand, it seems like some of the justification is business related. So how much of it is technical? How much of it is commercial?
Yeah, I think probably they're intertwined. There's a technical aspect of Ethereum can provide a more secure settlement layer. Now, is that a function of technology? Partly, but also it's part about the economic size of Ethereum, right? The settlement, the economic security of Ethereum, it's actually a function of how much it's at stake there, right? But there's also a big business component in the sense of it's kind of gets you closer to this kind of economy that right now it's the biggest on crypto, in my opinion. No? And so by being closer and not trying to compete against but join, I think you get you have a lot to win. So I would say it's business, and probably it's I guess it's both, but maybe a bit more business than technical.
I think an interesting thing maybe for Keone from the last cycle was seeing all the alt EVM L1s pop out, and this cycle it seems like there's more emphasis on EVM L2s. It seems like be an explosion of EVM L2s facilitated by some of these modular building blocks. How do you think about differentiation as kind of this cycle alt EVM?
Yeah, I think at the end of the day, the good news for the entire crypto space right now about any new alt L1 or L2 is that the success criteria is really bringing new users into the space. It's just not, any chain that is high performance is only full and only delivering value if, it's only delivering value to the space if the blocks are somewhat full. You have blocks that have a lot of space, they need to be full. And so the KPI really is getting users, getting new applications, like net new applications that appeal to people that maybe like aren't on crypto Twitter all day or don't even know that they're using. I'm just stating obvious things, but the success criteria is really about adoption and specifically bringing new users in. So I think, commenting about previous cycles of, to what extent were they successful or not, I think it is just about user adoption. So we're just really focused on supporting builders who are building net new applications and then helping them to grow their businesses to gain millions of users.
So to keep on differentiation, Nick, you're kind of one of these vendors of off-the-shelf components, right? That new rollups can pick and choose from. Where would you recommend rollups focus their innovation of the 4 pieces of the stack, right? You can purchase all the components off the shelf right now. You can pick SVM or EVM, integrate Celestia. Where would you say the room is for technical differentiation, or where should teams focus?
That's a good question. I think the room for differentiation is like to be creative, and like, we have this mantra of build whatever, and what it captures is the fact that the modular stack exists to remove constraints for builders and break open like new potential ways of building applications and even entirely new applications that couldn't exist before. And so it's about like, and I think where you get that is by like choosing the right components and putting them together in the right way. And like there's so much room for experimentation there that I'm just excited to see where like the creative ways that people use this. I think there's one of the things I'm very excited about is that like we're going to blow open the doors in terms of innovation and experimentation at the execution layer part, because what a rollup is sort of like a plug and play execution layer. And before, if you wanted to experiment with like parallel EVM, you couldn't just ship that to Ethereum mainnet. You would have to launch an entirely new L1, which is a huge lift. Now with rollups, you can just like hack around and then try it out and then see if it works. And this is not just for parallelizing the EVM, but adding, there's a team that's building on Celestia now called Manta, who took the EVM and added special opcodes to verify ZK circuits. And so it makes it dramatically cheaper to do ZK type things on chain. And so I think there's a lot of innovation at the execution layer, and I'm excited to see, like it's the same thing that Ethereum did. It made it so that in the Bitcoin era, if you wanted to launch a new application, like each chain was an application. That was like the original app chain era. Then Ethereum came along and said, hey, you don't have to launch a new chain to innovate at the app layer. Just write a smart contract. And I think rollups and modular blockchains do that for the execution layer as well. So like innovate, experiment, let's see what happens.
But does that mean we're going back to less interoperable blockchains, right? To say, hey, look, we're going to have this wide variety of execution environments. What are the implications for interoperability now that it's super easy to spin up new execution environments?
Well, so it depends, right? So like, I think if you share enough in common with like some standard like the EVM, I think it's possible to be quite compatible. So it depends like how far off you want to veer. And we're also really lucky to have teams like Hyperlane who are making it so that it's really extensible and easy to and flexible to like add new bridging solutions to these rollups. So yeah.
A question for everyone here, Keonia, you kind of hinted at this, where you're building the architecture of your system in a modular way. Is the distinction between modular and monolithic kind of forced? Like, are all blockchains inherently modular in some way? Maybe we can take this in order from Nick.
Well, I'll let Keonia start.
Sure. So I think there is actually so certainly it's true that all well-designed systems have different modules with separation of concerns. I think the distinction here is sort of the question of like the fractal scaling idea of a rollup, where the rollup is like a separate blockchain that is compressing all of its, making a commitment to all of its state and pushing that down into some other layer. So like, I'm just restating what probably everyone knows about rollups, but the benefit of the rollup is you can move the work off of the L1 to the separate layer that's doing all the work and then just pushing kind of results back. And then introducing other things like data availability to make sure that the proof mechanism for proving that that Merkle root that's been pushed down is actually the valid one. So I think that is sort of inherent to the modular notion, is this notion of fractal scaling, whereas with monolithic, it's like, we'll just focus on making this base layer, the L1, very performant. We'll push the limits of what's possible from an execution perspective and from a distributed consensus perspective. Fight the speed of light, transmit as much data as possible to thousands of nodes at the speed of light, build a really performant system. But I think that there are just sort of different philosophies that can interact with each other. Like, you could have Monad as the base layer for settlement or potentially for data availability in a modular system where there are other components on top of it as well, and use that fractal scaling type mechanism to unlock even more performance.
Yeah, that makes a lot of sense. Mariano?
Yeah, I guess I agree with this concept of again, blockchains itself has all these kind of 4 components that Nick was talking about at the beginning. Again, you see Ethereum, original Ethereum, they're all in the same block, right? You have data availability, settlement, consensus, execution all happen there. Then you start extracting parts. So I think the more you go into, I guess I don't know where you would put the difference. Say, okay, now it's modular. Now it ceases to be modular because it's kind of maybe a progression. Maybe the extreme is you have different subsystems that are running different parts, which is what we are seeing tonight. But I guess there's probably parts in the middle where you can also the design space is kind of you can set where you are, wherever you want to go there. I think we are going that direction. I guess it makes, as again, it's separation of concern. It makes easier to reason about the system, the more separate things are. I think it also might do some things harder, right? When you are, reason about security, the atomicity of having everything in one place makes simpler to reason about the security, while having different parts make it harder, but still, it's a nice thing to solve because it allows you to horizontally scale at the end, right? You can have different parts and also allow you to kind of upgrade the system in a way. You can, change one layer eventually. And as we see, technology kind of keeps evolving, and you'll find better ways of solving the different layers as you progress. And it's good if you kind of have a good separation of interfaces so you can switch eventually. Not that it's not going to be easy, but I guess it'd be nice.
Nick, anything to add?
Yeah, well, I think early on when we were trying to explain what modular blockchains were, a lot of people kept getting kind of stuck on this idea of oh well, the Cosmos SDK and Tendermint, that's modular, so all Cosmos chains are modular blockchains. But there's a difference between modular software components. Almost all blockchains are now moving towards modular software. Ethereum has the execution client, the consensus client, and they have an interface, and a lot of things are following that pattern. However, it's very different from what we talk about when we say modular blockchains. You can having modular software is not the same as having a protocol that is designed to be a protocol as a service, essentially, for other chains to plug into. And so our definition is a modular blockchain is a blockchain that outsources some component to another system, whether that's execution. In Celestia's case, we outsource execution to rollups. And so I think that's what the power is hey, these chains can plug into each other. You don't have to reinvent the wheel. Every time you want to launch a new chain, you can just plug into something that already exists. And that's just really powerful because instead of you can think of Cosmos SDK as a kit to build a car or something, but there's no engine in it, or maybe there's no batteries or something. I don't know. But Celestia provides you the car and the battery, so you're just plug and play, ready to go. And so I think that's the main difference.
Taking this in a slightly different direction, it's going to be easier than ever to kind of spin up these new systems. Do we think this is going to be the rise of the business people? Do we think that there's going to be less emphasis on technical differentiation and more go-to-market?
Potentially. I mean, one of the things that I've been excited about for like modular blockchains to take off and rollups in general is that I think they're the perfect, they're kind of like perfect for enterprise, frankly. And I know that there was a lost era of enterprise blockchains back in the day, and like this idea of blockchains as a service. But that's actually kind of fundamentally what rollups are. They give you the ability to have, actually Mustafa tweeted about this earlier today, that modular blockchains allow you to have the decentralization and security of Web3, but with sort of like the user experience and scale of Web 2. And I think in his tweet, he used an example of how like PayPal could easily spin up a rollup, and you might not even know as a user that you're using a blockchain underneath. And it would all be powered by rollups and modular blockchains under the hood. And so I'm excited because I do feel like in some ways it's like there's people, it's hitting a new spot in like the trade-offs where like bigger businesses will be like, holy shit, like we could actually use this.
Gianni?
I think that in the previous era, like the 2018 era, there was still plenty of forks of Ethereum, which were very business driven. The most prominent being BNB chain, or BSC at the time. But a number of others, like I think Neo was a fork, I think Tron was a fork. I don't know. So like there's always been this possibility of taking the existing system and then forking it and then focusing on more like the usage patterns in business. So I don't think that necessarily changes, and I feel like if anything, because there is complexity in the interaction between different live systems at different layers, it might not necessarily be any easier. But that isn't to say that there's not some merit in doing it. And I think when you were talking about the like corporates, like JP Morgan chain and Bank of America chain and so on, it would be kind of cool if they were all just operating at one layer, but then they're sort of forced to interact with the rest of the crypto ecosystem from the other layers. I think the collaborative nature of a more modular system is potentially something that could have good effects as there's more corporate adoption.
Mm-hmm. Yeah, I think like maybe I wouldn't talk about like maybe business people in that sense, but like I think it's also like understanding what's the product here, right? I guess we are building these general infrastructure companies that I guess we sell like block space, and as I said before, this block space there's like a technical component, like there's like I don't know, your block space has privacy feature, which is great, no? And there's like some use cases are going to be unlocked by that, or has like a great scalability, so maybe you can like I know do games, right? But it's also about like these kind of economies that you are creating, no? And that's like what we are referring as the business part. Like we are like creating and nurturing an economy, and the more successful you are in that, like, and it's not necessarily a technical differentiation. It's probably maybe a business differentiator that you are creating, no? You will. I usually kind of like I don't know, like I give this example. Like let's say like you are I don't know like a fashion designer, right? And you want to open a new shop. Like your first shop. Which city in the world would you choose? Would you choose, I don't know, New York, Paris, Milan, or I don't know, Buenos Aires? And probably if you want to go in high fashion, you'll probably go one of the first three. Why? Because fashion happens there, right? And so same goes here. Like these blockchains are like economies, and if you want to build your project for X, where's the best place to do that? Or similar, if you are a founder, a startup founder, where do you have best access to capital? Like, what's the country in the world, the market where you actually get that better, or where you have higher potential users, like that, like already exist in that economy. I think all those things are the things that we are creating, and that's part of the product that we are creating. And so, again, I repeat, I think it's kind of like sometimes I feel like we over-index or in technology, and I think technology is definitely a thing, but I think also technology tends to be more like commoditized. Like even like things that right now like are very hard to solve, like privacy, will like in a few years probably become like a commodity. And so I think to me the focus it's kind of like needs to be in this kind of product. And then maybe you have all these I guess other systems that are already like kind of like these app rollups that we're saying that maybe are trying to solve one specific problem. But again, it's the products, it's not a technology. Technology is kind of always a means to an end.
Yeah. Let's close out by giving everyone one thing to look forward to that your project is working on. Maybe let's go backwards from Mariana.
I guess I'm working on this kind of solo transition tool. So I'm basically very eager to see that, and again, it's like a fun journey because there's like so many kind of like choices and ideas, and we've been actually receiving like a lot of like feedback, and so I super look forward to that like of day. So
yeah, I'm looking forward to introducing superscalar pipelining to the EVM. Pipelining is something that's really common in computer processors, allows a lot of work to happen in parallel, scheduled intelligently, and I think there's just a lot of optimizations that our team has been working on for quite some time, and just from the Twitter discourse recently, I see a lot more people excited about parallel execution. You've got Georgios from Paradigm talking about it, and all of the alignment anons talking about it, and so on. So I think it's going to be really exciting to bring it to the world, and just excited to share.
I'm excited for that too, actually. And I hope also it's okay if we take all the parallel execution and like put it in rollups too, like because I feel like a lot of people are going to want to build if there's like an EVM that's better. We recently launched mainnet like a couple weeks ago, and so the next thing for us is really to onboard builders. So we'll have our first few rollups coming online in the next few
It's feeling really bright. This one, okay.
Oh, sorry.